Okay, good morning everybody and welcome to the event La Rioja Connection, International Network of Computational Linguistics, Natural Language Processing and Artificial Intelligence Applied to Language. As you probably know, the University of La Rioja is running a transformation plan that includes teaching programs and events in the area of language technology. The main thrust of the plan is the interdisciplinary combination of technology and humanities, and to be more precise, of computing and linguistics. This year we received the third cohort of the MA program in language processing and artificial intelligence, and we are also preparing a BA program in language technology, along with a series of short courses in NLP and computational linguistics. The plan of transformation has scheduled a number of events revolving around the technology of language. Today, the event La Rioja Connection is the kickoff of an international network focused on natural language processing and natural and computational linguistics, with special attention on the convergence with humanities. We welcome our distinguished colleagues who are going to present contributions dealing with the teaching of NLP in the area of artificial intelligence, the research in natural language processing with large language models, and interdisciplinary experiences in computational humanities. Our first speaker is Professor Andrzej Tyki of University Charles in Prague. So, Andrzej, the floor is yours.
Whoops, sorry. Now that's working. Okay. Hello everyone. Thank you very much, Javier, for inviting me here. It's always great to be at Logroño. And today I'll talk about how we teach digital humanities to the students of philology. For us, that's linguistics, but also literary studies, cultural studies, and a bit of history sometimes. But of course, given the topic today, I'll be focusing also on what AI is doing and is probably going to do with the field. And I'll be focusing specifically at our faculty, so Faculty of Arts at Charles University, which is largely a humanities faculty. So we do have units that do specifically NLP as well. But it's mostly linguistics and, quantitative linguistics like corpus linguistics. But there is also a faculty of mathematics and physics, and they have a complete unit that is dedicated to NLP. So I'm not talking about them necessarily. This is the faculty of humanities. I would like to start by saying that we've been teaching some form of digital humanities, of course, for a long time. After all, corpus linguistics has been with us for a long time. But it was only last year that we started something that is called Center for Digital Humanities at the Faculty of Arts, whose a stated role is to promote, support, and coordinate teaching and research in digital humanities. It's not a center as a center with an office or an actual unit at the faculty with its own budget. It's really a platform, a virtual kind of network of people, both researchers, teachers, and students who work in digital humanities and who help each other out. We have about 80 members. There is a website that has profiles, the projects and courses that we teach. And one of our main issues or core issues, and something that I'm going to speak about today, is how do we train our future members, right? How we create more digital humanities researchers, including future developers, so more or less our IT staff, and what role AI is having and is going to have on what we do. So what are our training motivations? Obviously, first and foremost, we are training our students to be, competent, quantitative linguists or philologists, mostly in corpus linguistics. So for this purpose, we mostly teach data mining, both in general and corpus querying, data processing and analysis, and a little bit of statistics. But it needs to be said that a lot of our students who are coming to the Faculty of Arts as a humanities faculty and who are signing up for philology do it, amongst many other things, with the motivation of escaping the compulsory mathematics and science stuff they had at high school and didn't like. So not all of them are really enthused about digital stuff necessarily. So for them, we are just trying to make it palatable, because we think that everyone needs a little bit of statistics, at least if they're doing linguistics, for example. But with quite a number of those who are more enthusiastic about the digital aspect of things, we're trying to turn them into DH researchers. And by that I mean people who know enough about digital stuff and about development, perhaps even, not necessarily that they are able to develop digital tools themselves, but who are able at least to negotiate with developers, knowing what they're negotiating about. And that's one of the aspects, by the way, that may be changing perhaps. And in the end, we are also trying to train our own developers, because that's a constant problem for us, getting developers, competing with the commercial world outside. So this is one way to get developers, and I'll get to that later on. And the way we are training, I mean, again, that's pretty obvious. We have, of course, courses that are focusing on specific programs and specific needs of students in those programs. But we also have general courses in digital humanities and some of its aspects. And then we have summer schools, workshops, hackathons, often connected to specific DH projects, where we try to involve students as much as possible, because that seems to be one of the most efficient ways of training them. So just a selection from the specialized courses, especially for students of linguistics. We have a lot of corpus linguistics courses, because we have a large center for corpus linguistics at the faculty. And as I already said, we are mostly focusing on teaching them how to create their own corpora, so data preparation, corpus creation, of course, corpus analysis and querying, and apart from the usual synchronic corpora of English, Czech, and other languages, we are also focusing on diachronic corpora, parallel corpora, so multilingual corpora, and spoken corpora. Apart from that, this is just really a selection, courses in network analysis, specifically for linguists, statistical analysis in R, and some introductory NLP courses, some taught by us, some taught by the Faculty of Mathematics. We have new courses focusing on machine learning for linguists, and even some started last year focusing on LLMs. Added to that, we have the general courses. Some of them are for any students of humanities at the faculty, and some are even open to public. This term, we actually started or piloted a course that has the EU micro-credentials, so can even, it is accredited to give this micro certificate or whatever it is called. So it is open to public in that sense. And we try to organize it partly ourselves, partly in cooperation with experts from outside the academia. In fact, a number of the colleagues teaching that have both roles and work inside and outside academia. So for example, and you can see the topics there. So for example, my colleague who's a linguist at our department is also working for a banking institution doing data linking there. Another of our colleagues teaching app design and accessibility also works as a professional programmer and designer, and so on. We have a librarian teaching there. We have a colleague who's actually also working as a data analyst for the university itself, but is teaching here relational databases and data analysis using databases and so on. We also have a parallel course with higher capacity for students only that is partly done online, digital methods in AI, in social sciences and humanities. In topics, they largely overlap though. I would like to focus more or point out more some of the projects and workshops we've been doing. We have a number of running projects in digital lexicography. The Bosworth-Tolle dictionary I was talking here about 2 years ago, but also Czech thesauri or thesauri of Czech, Catalan, Czech Catalan, online dictionary, Latin, multi-dictionary search tool. So these are projects where we usually focus on digitizing print dictionaries and making them as accessible as possible. So a lot about search, but the underlining design of the data in XML, that's something that the students are usually very much involved in. Not so much designing of that, but transcriptions, editing, and so on. We have a lot of projects in corpus linguistics. So if you go to corpus.cz, you will see the set of apps that they have there. But we also have a couple of AI tools as projects. So Scriptum is a project for semantic similarities in Latin text. Corpus Linguist, something that I would like to show out later on, a custom GPT for corpus queries. And a lot with digital editions, especially of medieval manuscripts. And for that, we have a long running summer school that is focusing on digital editing of medieval texts, in fact. So we are trying to teach students basics of XML, about schemas, TI standards, so on, quality control in teamwork, some basic app development, mostly not for them to develop apps themselves, but to know how to communicate with IT experts and developers. We are starting to teach some of the AI tools now, and we'll see what it does. And while this is often more complicated than doing it without students, in a sense, it adds complexity. We really see that as necessary and also very useful, because really surprising number of students are turning up as relatively competent developers who, unlike professional developers hired from outside, do not have such a tendency to just leave us for better money elsewhere, but are also enthusiastic about the matter itself. So that really helps. So what is the role of AI in all this? Just on Thursday, we had a conference or workshop at Charles University, and people from Copenhagen University were presenting their survey, student survey, where they asked students how they use AI in their student and activities outside university. Most of them, 58% of them, said that they use it to explain definitions and concepts, mostly GPT, of course. 34% of them use it to check if their perceptions of some problem are correct, and 28% of them use it to search for facts and literature. And I mean, given what we know about LLMs and how they work, these are probably not the uses that we would steer them to, or at least not by using simply GPT without anything else, without any additional instruction. And it kind of reminds me of when we were using Google as a dictionary and spell checker, or as a corpus. So it's a bit tricky, right? So from that alone, it seemed to me that we really need to teach some responsible and effective use of AI, so that some training is required, especially when combining LLMs with other tools, enabling LLMs to do more things. So I have now a couple of examples where I try to show what we either already do teach as part of our training, or we are kind of considering whether to do that. And that's my final point then in the discussion, whether we should actually do that. So for example, for searching for things like literature review, for example, we're trying to point out that it's not a good idea just simply to ask GPT about, a topic because it hallucinates and so on, but that there are tools. There are ChatGPT assistants like the consensus one. There are specific tools like Elicit, which you can ask for literature review, and it's connected to the databases of journals and so on. So it actually searches semantically searches the databases, and it's based and can quote actual research. We are trying to tell them that if they try to research specific topic and get useful, citable, quotable information, they need to use techniques like RAG. So they need to use data sets of books, for example, on the topic to ask very specific questions. Here the question is, can you give me some examples of variation in nominal gender in Northern Middle English? So that's very specific, and normally ChatGPT just gives a very kind of a generic answer there. But if you fill it in with books on Middle English syntax, like Mustanoa here, it actually gives you a very detailed, correct answer, quoting Mustanoa on that. You can find the quotation easily. So this technique is useful, I think, and workable. And so that's what we are already doing. Some of this, so for example, using LLMs for data mining and data processing, that's something that we've just started introducing past term. Normally when teaching data mining to students, and I mostly teach like web mining, how to get data from the web and, for example, create linguistic corpora. That way I would teach it using either a browser extension for those who are not that good at coding, or perhaps using, Python to script that. But now I also show them that they can actually ask GPT to do that, and that they can actually get a pretty functional Python code that would do the data mining for them if they want. Or they could use tools like Open Interpreter to actually directly have LLM run on their own computer, do that data mining for themselves. In corpus linguistics specifically, people are not, especially humanities people, our students are not very keen on learning some of the formalizations they need to learn to do corpus querying. So we have a couple of GPT assistants or custom GPTs that can do this for them. So this, for example, was my experiment just a couple of days ago, where I again used the RAG technique. I gave GPT, the custom GPT, a manual for BNC, manual for corpus query language, manual for the corpus.cz API. And then I can simply ask it, create a query that finds all plural nouns starting with a capital letter indirectly followed by verbs in the third person singular present tense, but within the same sentence in the BNC. And it comes up with the correct SQL query. It gives you the description of how that query is actually composed. It even gives you the Python API call that you can run yourself. It works. This is another example of that, a bit more advanced. Corpus Linguist is actually now a publicly available ChatGPT assistant by Jiří Milička, a colleague of ours. And he even has something called GPT Actions in there, meaning the GPT can actually reach out and go directly to the API. So you can access the publicly accessible corpora at corpus.cz infrastructure. It works not, for example, with BNC, but with all the universal dependencies tagged corpora. And it's really kind of clever, I think, because when you ask it, I have analyzed, here's the question, sorry. Search and analyze Spanish equivalents of the English word love, analyze their usage. So it knows that it will need a parallel corpus for that. So it looks into intercorp Spanish-English corpus. It looks for occurrences of love in the English one. It gets you the 3 most common equivalents in Spanish. It gives you charts for that. And it even asks you, would you like some further analysis? Would you like some collocations for those equivalents? Would you like to see the concordances? It creates collocational networks, and some summaries of that. And my question kind of today is, should we do this? Because isn't learning the formalization really useful in some ways, although a bit painful for the students? So that's a question out there. And you can go on and even, of course, upload the exported concordances and have the GPT do analysis. So normally I would, actually overlaid something there. I just wanted to say that normally for data analysis of the corpus results, I would use Excel with Power Query and pivoting, or R scripting, or Jamovi for statistics, or again R. But now ChatGPT is relatively good in data analysis and in spotting out things in the data. So this is a huge file from a corpus of early English correspondence about the use of you and thou in correspondence. You just upload it, and it tells you, what the data are about. It gives you a summary of the data set. It shows you things like diachronic development. If you ask it, it does logistic regression for you to look at the influence of the different variables on the choice of the pronoun, and it gives you some interpretation. For example, pointing out that gender is a salient variable there, things like that. And again, the question is, should we do that? Do the students then actually know what they're doing? So on one hand, this is a bit problematic. On the other hand, what I really think is nice is that it's very approachable, and also it gives you quite a lot of commentary. So for example, understanding and explaining the results of a logistic regression is not simple for our students. And here they have a very good description about what things mean in that regression model. But are they going to read it? I don't know. Here, a couple of our digitization projects. So this is the Bosworth-Thaler, this is the Zori, this is a database of medieval Czech texts in translation, going from the facsimile through the translations, transcriptions, notes, all the way to corpus tools and searching, and one of the biblical editions. And now looking at what the OCR can do there. I don't know if you try that. ChatGPT to me seems surprisingly good, although not probably usable out of the box for actually transcribing medieval manuscripts. It seems better than some of the tools like Transcribus, but I'm not an expert. This is just a quick comparison. I just gave it a bit of Old English Andreas, which is a very readable manuscript, I think, but it doesn't know it, so it had to do the transcription. Especially if you prime it for the content, if you tell it, so here is an Old English manuscript, transcribe it, it does a relatively okay job. I'm not sure if it would save time rather than transcribing it yourself, but certainly it can do a bit of that. It can certainly do very good orthographic normalization. So this is from an MA thesis that is being prepared now. Here's a piece of a early modern text that 38 of the tokens need to be normalized to make them more present-day English-like and perhaps more usable in natural language processing. And ChatGPT does it almost without any problem. It capitalizes things where you wouldn't necessarily want them capitalized. And it modernizes word formation here and there. So for example, encumberment, it changes it to encumbrance, because there is currently no encumberment. If you compare it with what we find in early print, so the standardized version that you can work with online, I think there are more errors there so far, just looking at it. And that's, I think, partly automatic, partly manual. So that's an area where that could help, definitely. You can use it to, and I think this is definitely something that we'll use and teach. For translation, glosses, and test creations, I'm not necessarily sure we will teach this, but we are starting to use it ourselves in teaching. So it's really useful, you give it a bit of Old English poetry, ask it to do Leipzig glosses, so glosses with equivalents and morphological definitions, and it produces a gloss in PDF. It can produce an alphabetic glossary, and it can do a little, multiple choice test on that if you want. So that, I think, is a time saver, more for the teachers than for the students. And then looking at what we are doing with the digital editions, you can actually give it an example of the TI structure, a valid TI file, and ask it to transform all that into TI, what it transcribed in Andreas, and it actually produces a valid TI file. So again, we love teaching our students what XML is and how standards like TI work. This can do it partly for them, so is it a good idea or not? And before they even start coding more in earnest and perhaps start using more sensible tools like coding assistants, or even complex tools like AI developers like Pythagora that walk you through the whole process, they can just ask ChatGPT, right? Using the image and the transcription, create a web edition of that text. And it actually spits out a stuff that is kind of barely useful. You have the image there, you can click the lines, it gives you the translation and the glosses. And what I, again, find useful, especially there, it gives you out of the box quite well commented Python script, or you can ask it for more commentary. So it's good for the students to do that and then take it apart and ask perhaps what this bit is doing actually, and fiddle with that. So not just to do the job without ever talking with the developer, but to learn things like that. All right, I think I'm running late a bit, so just a few conclusions. So I see the role of AI as perhaps narrowing the gap between the digital humanities, between the digital and the humanities, between the future project investigators and the developers. So it can help do some of those things by themselves, or perhaps teach them how to understand them. It may be widening the gap at the same time, so there are all those socioeconomic issues, who can afford what kind of LLMs and so on. But I have, for example, quite a lot of anecdotal evidence that one of the narrowings of gaps that I find particularly appealing is people with certain disabilities like dyslexia, who find it very empowering that they can now use these tools instead of perhaps friends who help them produce text. So that seems very good. So my final question is, does it actually help or hamper the learning? Is it analogous to the development of typing and printing instead of handwriting, or using calculators in class? Does it mean that if you use calculators, kids will no longer be able to add up? Or is it something a bit different, since it's about formulation, precision, formalization? If people get used to do that through ChatGPT, if they do not have to learn how to do queries for Corpora, are they losing something? And for me, one of the appeals for quantitative methodologies, quantitative linguistics, for example, is that it forces me to be precise, to formulate the questions, not to forget about things. I hope this is not going to be lost in that way. So that's probably all. I'm happy to debate this further. Thank you very much.
Yeah, thank you. Okay, we have time for one short question. Sergey.
If I may, so actually, I'm back to your discussion of hackathons, and in my experience, I'm actually very much in your shoes, because I straddle between computer science and the arts, right? And then organizing hackathons is very empowering. So some students love it, right? But also for some students, this alienates them even more. At least this is my experience. Other than what's your experience, and what are the topics of the hackathons you?
All our hackathons are optional, so students can do it if they want. They don't have to do it. We've been running one as part of the Erasmus Plus scheme, so it has been moving around. And one is running right now with Eyal Poleg in Cambridge. And I think some of the students are really enthusiastic, and it helps. It shows them how to do things. For the students who are not that enthusiastic, they at least, those that decide to go there, they are usually enthusiastic about their own research. So they may be doing, I don't know, Latin glosses, something like that. And they want to see the end product. They want to see an edition, for example, that they're working in as part of their PhD thesis. They want to see an online version, a pretty online version there that people, can recognize them for. And I think they appreciate especially the part where they talk with professional developers and learn how to do that, how to explain what they need to those developers. Or if they don't enjoy it, they find it very useful at least, I think. So that's been our experience.
Ruslan.
Just a very quick question. Thank you for the presentation. You mentioned that some of the students who have studied languages have become good programmers. So I'm running a Erasmus Mundus master program on technology for translation and interpreting. 90% of the students are language and translation students. One of them
Yes, actually, I just remembered now. Thank you. Yes, actually, quite a lot of them go to big tech companies. We just had recently a discussion when we did a re-accreditation of our linguistics program. We have, in part of the accreditation process is saying who the graduates are going to be, and traditionally it says they are going to be translators, if not linguists, of course, and they can work in administration. Said, but a lot of them go to Google, Microsoft. Shouldn't we also say that? Because that's a relatively new thing. So yes, a lot of them do that. A lot of them now, in past 2 or 3 years, go working with companies on things like chatbots, for example, where they often want someone with a humanities twist who can tell them whether the chatbot actually works as it should. A lot of them are partly there to negotiate between the core developers and the rest of the team or the public. So they are really doing very well. Some of them, luckily, are staying with us, fewer than we would like, but some do. And some do work for the university in general, so they do things like data analysis for the university, and some go and work on our projects. That's the most.
Solve those problems by highlighting the fact that thanks to those new skills, their employability is much higher and much better.
Yeah, we are trying to really stress this, and I think that that's a great appeal why some of them actually want to go into that. But there is still quite a large cohort of students who really don't want to have anything to do with that. They just want to study language, literature, culture, and so we are okay with those as well. Not everybody has to do this.
Okay, thank you.
Thank you very much.
Okay. Thank you. ¿Está?
Just 1 second. Our speakers are Ana María Fernández Pampillón Cesteros and Doa Sami Khalil Shower of the Universidad Complutense de Madrid. Now, the floor is yours.
Thank you, Javier, and thank you for inviting us to this interesting network. Our talk is focused on competences or skills for training computational linguists in the era of artificial intelligence, and our main focus is trying to answer 3 key questions, or what we consider 3 key questions about what's the best practices, experience in building these competences, what are the skills that a computational linguist need to be successfully integrated in the professional world, and finally, what's the future, or how we think will be the future. And beginning with the first one, good practices, we would like to share with you our experience of 26 years training computational linguists. In the extractor, in the context of the extractor of the university studies in Spain, we have 3 programs, the underdegree, the postdegree, and the PhD program. And our degree, being more specific, our degree is a Bachelor in Linguistics and Applied Languages, and it's a degree of 4 years, and it has a specialization in computational linguistics. We also have a postgraduate program, a Master in Linguistics and Technology, and it also has an in-depth specialization in computational linguistics. And finally, we have our PhD that, of course, has a line of research in computational linguistics. And that's our experience. We began in 1996 with a minor degree of 2 years. And it was mainly for linguists and for computational linguists as a track, as a special track. We got our first promotion in 1998. Now all of them are senior computational linguists, so we feel proud about them. And in 2010, we had to change the program because of the Bologna process. In Spain, we had to implement the European higher education area. So we built our 4 years degree. And it's interesting to know that we built the curriculum based on 2 valuable things. One of them was the experience of the previous degree. But the other thing was that we base our curriculum in the reflection in collaborative work of the national network of linguists in Spain. So we got, I think, program that guarantees not only the quality, but also the possibility to interchange our students. In 2014, we got our first promotion of the second degree, and in 2016 began our PhD program, and our first computational linguistic thesis was in 2020. In 2019, we did some updates to trying to correct some weaknesses that we detect, but was slightly modifications. And finally, in 2022, so yesterday, we began our master in linguistic and technologies, and it has, as you will see, in-depth specialization in computational linguistics. So, what's our recipe from these 26 years of work. What is our recipe to train a computational linguist? From our point of view, put 35 linguistics, 36 of 2 languages, foreign languages, 20 of IT, 70% of maths and logic, and finally 2% of psychology and cognitive science. That's in general, but more concretely, that's our curriculum for the degree. The degree is developed in 4 years, as I said. So in the first, we highlight in the squares the subject, IT subject or math subjects, just to see the weight, no, in the curriculum. And first years, the students are introduced in linguistics, in 2 foreign languages, in statistics, and in IT. In second and third year, they go deeper in linguistics. They study phonetic phonology, morphology, syntax, semantic, pragmatics, discourse analysis, text analysis, and in the technical part, they study text technologies mainly, hypermedia also, and acoustic. We have a lab of acoustic. And finally, in the 4th year, they choose the specialization. They have 2 specializations. One of this computational linguistics, and in this specialization, we have 30 credit that we organize in five subjects. The first 3 subjects are in the first semester, and the last 2 subjects in the second semester. The first 3 subjects are, they learn programming, they learn mathematical linguistics, and they learn models for formal representation of linguistic knowledge. And this subject, the contents are needed for the last 2 core subjects or courses, no, of the degree, which are computational linguistics. In this part, they learn the fundamentals, the computational linguistic models, symbolic, statistical, and neural network models. And also, they learn about main natural language processing applications such as machine translation or information retrieval, data extraction, and dialogue systems. And in the second part, the natural processing course, this is the hands-on part, and they build some prototypes for tokenizing, tagging, and also text classifiers with some machine learning algorithms. And that's for the degree, our recipe, as I said. We have approximately 220 graduates in computational linguistics since 2010-11, and approximately half of them go directly to the industry, and they complete their training inside the companies. And the other half go for postgraduate programs, not only in Spain, but also in Europe, to be a really computational linguist. And that's the degree part, and the master part, Doa will explain you.
Okay. First of all, thank you for being here, and I will continue also explaining the experience of the Complutense University at the master level. So we gave our recipe on the bachelor degree, Bachelor of Arts, and this is our recipe for the Master of Linguistics and Technology. The master was launched in 2022, so this 2 years ago. It's a 60 ECTS master for a duration 1 year, for full-time, 1 year. And actually, the 60 credit hours are distributed in a foundational general module where they have advanced linguistics, like about 15% of the load in advanced linguistics, and 10% technology, and another 10% in research methodology, and almost 5% in entrepreneurship, which is also a new component in this type of master degrees. And then comes the more important part, and which is 60% of they choose a track in specialization, and of course computational linguistics is one of the tracks that is highly demanded among the students. And besides other like forensic linguistics and e-learning for language teaching. In this specialization part, it's 60% of the like 36 credit hours, 60% of the master courses has to do with the specialization, and in the and also an important point to highlight that it's a blended master. It has 80% online and 20% face-to-face classes. So in the part of computational linguistics, we will highlight also the details of how this 60% is distributed and which courses are taught in this specialization. So, okay. So they have, they go through the different linguistic levels from a computational approach. So they study computational morphology, computational semantics and pragmatics, speech processing, and advanced programming for NLP. And then finally, these 4 subjects ends up with another subject in the second term, which is more hands-on and practical. It's advanced applications in computational linguistics, or they can choose also, instead of these subjects, to go for an internship. But if they choose the subject of advanced applications, they have to develop 2 mini projects that has to do with computational linguistics from A to Z. So they have to go through all the process in a very mini project, like a small prototype, from the data collection to the data processing or data cleansing, and maybe training a small model. It's not about having a big solution or a very complete application. It is just about how to go from 0 point till to have an evaluation of a model or of a symbol. Sometimes they do, this is the variable, the projects are chosen every year according to the updates and according to the different trends in the computational linguistics. Sometimes they have a part of chatbots, sometimes they have a part of information extraction and text processing. We try to expose them to different types of text processing or different types of natural language applications. And then finally, they end up with a master dissertation, and this counts for 12 credit hours, and they are usually, if they are specialized in the computational linguistics track, they will develop their master dissertation in this field. Again, this is our recipe, having part of good foundation of linguistics and the programming part and the technical part. And by the end of 2024, we have 2 promotions now. One is still ongoing in the process, and one already finished. It's a highly demanded master, actually, and approximately by the end of 2024, in 2 years, we will have approximately 15 graduates in the computational linguistics specialty. It's highly demanded, but it's still strict. I mean, the admission rates are very strict. We try to focus on the quality and to have really good trained computational linguists instead of having many ones, but to have a few number, but well trained and with high skills. And actually, from the first year of the master, all of them are working in the industry. We even had some internships, and we didn't find the candidates for the internships because they are all offered a contract for working, so it was really a good success and a good indicator. This is our recipe at the master level, and Also, to sum up this part of the linguistic studies at the Complutense University, in the last year, according to the QS ranking by subject, the studies of linguistics at the UCM was ranked the second in Spain, and it is ranked 78th at the international level among the best 100 universities in linguistics. So this is a good news for us, and we would like to share it. And then from this point, we go to the second, to try to answer from our point of view, the second question, which is, what are the skills? In this, what are the skills that a computational linguist, or he or she, should have in this era with the demands of the AI and the pros and cons? From our point of view, there are main pillars or strength points that we consider important. And we try to sum up all these strong points or factors that we consider that they really play an important role in shaping the profile of a good computational linguist. First of all, to have a flexible and solid program design that offers a good training and also an updated content. And well-defined learning paths, because the order and in which the subjects are organized and how each subject builds up for the next one, this is very important in the learning path of the students. So this is one important factor that we consider crucial in the process of the training of a computational linguist. Another factors include the interdisciplinary studies. Working with other faculty members in different departments, working with other faculty members in different faculties. It's a very important point, because this is the field, it's interdisciplinary. You have to work with colleagues from the Faculty of Computer Science, from mathematics, from statistics, from psychology, from different fields. And this is an advantage, but at the same time, it is a challenge, because it requires a high coordination effort. And Anna here has been coordinating the programs for long years, and it really requires high coordination effort to bring all these professionals and studies. Not only interdisciplinary studies, and also the staff. The staff are not only from the professors that teach in the bachelor degree and the master degree, are not only from academic background, but they are also come from the companies. We have the professors coming from the industry, sharing their experience with the students, and this is also an important component and factor. Of course, the research methodology, to build up a research methodology and to have an adequate infrastructure in order for the student to have labs and to get access to this. It's adequate. It should, this is also another challenge. It's a good point. It's an advantage and disadvantage at the same time, because nowadays all the requirements for the processing it's high cost, and to keep all the infrastructure updated is not easy. And this we had to have at least the basic requirements, so that they can try and with themselves and implement some small practices. And of course, in collaboration with industry is crucial, either at the level of the staff through collaboration projects with industry, transfer academia, industry academia partnerships with small projects, and also through internship for the students. This is from our point of view, the most important factors that help shaping the training process of a computational linguist. And then in the second, to sum up this part or this question, we believe that a computational linguist should have a strong linguistic foundation, because at the end of the day, he's a linguist. So he has to understand very well and to master the language, the natural language. And not only one language, but a broad coverage of at least 3 languages. Spanish as a native language in these 2 programs, and plus 2 other foreign language. This gets the linguist exposed to other structure and other nature of language, of natural language, and this helps him abstract better at the level of the logical and mathematical thinking, because he's not only exposed to 1 language or 2, he's exposed to at least 3 with different morphological, syntactic natures and structure. So with the logical mathematical thinking, exposure to 3 language, strong linguistic foundation, And of course, skills, IT skills, updated IT skills, and we believe that he should be able to prototype, abstract, and model a natural language and try to implement it in a computational way. So this is, from our point of view, the 4 main skills, and this is what we try to apply both at the graduate level and the postgraduate level. The linguistic foundation, the exposure to languages, the mathematical and logical thinking, and finally the tools, to have the tools. And of course, other cross-cutting skills such as problem solving or critical thinking, team working, etc. But this is like the main distinctive characteristics from our point of view. And this will lead us to the last part, or the last question that we try to answer here. So what is the future for the computational linguist in this era? Of course, we know that this is booming, the AI is booming, the natural language processing is one in the best time ever now in these years, but still there are challenges. Coordinating, as I mentioned before, there's also sometimes unawareness of the importance of the role of the computational linguist. What is the computation? Sometimes many of our students face this problems that we say, I'm a computational linguist, so what you do exactly? And this is really sometimes, no, I'm not a data scientist, I'm not a programmer, I'm not a traditional linguist, I'm not a translator. So this is always something that we also should work on with our students and with the community and with the industry, that sometimes they don't really know what is the value of having this interdisciplinary profile. And also this is related to the next point, which is there are also some professional intruders that sometimes I know something about that, so I can be a computational linguist. I do something here and there, so I'm a computational linguist. And this is not exactly our own definition. I mean, we should be flexible, but at the same time, we should know what is the value, or what is the value that we give to our graduates, and they should be also aware of this value. And of course, another important challenge is the computing infrastructure. Now, to have GPUs and to have strong processing or supercomputers is a high cost, and public universities sometimes are not able to update it, and the bureaucratic process takes time. So we should also be more flexible in this sense from the point of view of the professors, and to try to find solutions, and to go around and find the solutions that in order to get the students to try different applications. And of course, the fast pace. And this also is another challenge, because the contents should be defined in a way that they should give the foundation, but at the same time, that should give the flexibility to introduce and to update the content every year almost, because nowadays, like every week, the state of art is changing. So this is a very demanding for the professors and for the students to keep, and also there are some objectives of the definition of the programs that we should fulfill, but at the same time we try to keep these flexible points to introduce new content every year. And finally, from our point of view, in this future of the AI era, now these pros and cons, the challenges and the opportunities, we believe that it's important to stress the relevance of the role of the computational linguist as the specialist of the language. They are the specialists, they are the scientists of the language. So they are able, or they should be trained, and they should be aware of their value, that they are the specialist of the language, of the natural language, and they should be able just to model the language and to analyze the generated language. I mean, they are the specialists who really understand the natural language, and could model it, could analyze it, and break it up. And they also could understand the underlying dynamics behind its generation. And this is I mean, either it is generated by human, or either it is generated by the machine. They should be able to go and to break this process up, and to know what's going on. And of course, we believe that the role nowadays in the different in the chain of the different process in the AI, we believe that the role is crucial in the selection of data sets and the representativeness of the different training data sets so that the models should be adjusted. In the analysis of the data quality, the data labeling, analysis of the generated language and the different challenges with all the content generated by AI, they could here have more insight on what is the problems and what is going on, and also in the LLM alignment, the new trend that is now how to align the large language models to the values and the social values, etc. So they are also could have some insights on how could we train or adjust or fine-tune these models to be aligned to the ethical part and the values, etc. And of course, in the quality processes and the evaluation of what are the analysis of problems, of errors, etc. So this is actually our recipe, our vision, and how we perceive the role of the computational linguists from nowadays. Thank you very much, and we'd like to also open this discussion on from the experience of other teams and other colleagues. How do they perceive the role of the computational linguist, and what are the challenges they face, and if you're facing the same challenges, what are the recipes as well? So this is also, we came to share and also to know and to learn from other colleagues how this could be always getting in progress or to offer better programs for our students. Thank you very much.
Tony.
Yeah, I thought that was very interesting, thank you. Could you, oh, okay, no problem. Could you say just a little bit more about the internships in particular? I'm curious as to how they're assessed, and in the context of that, how you ensure that they're sufficiently challenging and scholarly, sufficiently rigorous, I suppose. Given the fact that sometimes, in an ideal world, of course, we'd all want the same thing, but sometimes with industrial collaboration, there can be a tendency to want the student to do business as usual, which of course is a very different thing to completing a project or a dissertation. So could you just tell us a little bit about how you balance those tensions?
Yeah, that's interesting. We try that the students do at the same time their final project in the company. So that's the way to assure that they are doing something, that they are learning, they are not doing another kind of thing. We evaluate both the internship with a project. The students have to present their experience. We have the tutor in the company evaluation. And finally, the final project, the master final project. So we get a good idea about what he or she do in the company.
Thank you very much for your presentation. I have quite a few questions, but I'm going to focus on two only. The first one is, I did not see you mention student learning programming. I mean, having a course in Python is essential in my view, and this is what we have been doing. And then the second question is, you mentioned large language models. So not only in Spain, but in many countries, in order to start doing some new teaching, you have to validate your program. So it takes ages. So how do you make sure that you can keep up with the latest development? Because if it takes a year or two to validate a program, then obviously your teaching will be out of date. So how do you find a balance between the fast development of large language models and the fact that you have somehow the official validation to teach it? Thank you.
Maybe I can answer the first question. Concerning the programming, of course, we include the programming. There is a part introduction to computer science, and there is the advanced programming for NLP. And this is definitely, nowadays it's Python. Maybe in the next years, the trend is another language. But we have in the bachelor degree and the master degree, we have a independent course for programming, introduction to programming for computational linguists, and the advanced programming for NLP. So this is the part we introduce, and also in the markup languages and the hypertext or corpus linguistics and textual analysis. They also learn to use different tools. So this is the part about the programming. We try to keep it more generals in order to introduce the language that is used in the process. And concerning the accreditation or the validation of the courses, I think this goes through the national. Maybe here I am not.
The evaluation of the student.
The evaluation of the course, the accreditation of the course.
The question was, how can you keep up
with it?
If you wait for 1 year to get it validated, obviously what you'll be teaching won't be any more up to date.
No entiendo
Yo
bien.
creo que como que si la acreditación para la calidad del programa y tal se tarda 1 año.
More than 1 year. Bueno, with respect to the programming skill, it's quite interesting the question, because in the master we need that the students knows unless they have 150 hours of programming, and that's.
My question is, how can you teach, for instance, large language models?
Yeah.
My question is, for instance, obviously large language models are changing every month. What you teach today or what you taught last month is not anymore up to date. So how can you include this in your program if this hasn't been validated? So what do? How do you make sure that the students are up to date with the latest development? This is very important.
Yeah.
I mean, we have found ways around doing it by for them doing it in their dissertations, but how do you do it?
Yeah, that's one of the not problems but challenge of these studies. Firstly, for us the most important thing is the foundations. If they are well prepared in neural networks and how they work, they give them the strength to going on learning. And secondly, our teachers must be updated, and that's one of the challenge of these studies. And we, for instance, the application part, the course, the application part, in this part, we use the current LLM models, what implies an effort for the teachers to be updated, of course, and that's the challenge. But up to now, it works. We try to be updated. Up to now, we got it. We get it. True. But for me, the key is give them the foundations, give them to understand how they work.
Hi, great presentation, and you have enviable employability statistics for your programs. I wondered though, you didn't mention PhDs. Do you have PhD research, and why do you, is there a reason why everybody graduates from your master's degree and then goes and gets a job? Is it to do with the sectors that they're moving into, that they're very well paid and they don't need the PhD research, or?
Yeah, that's one of the reasons. The 10% of our postgraduate students go to the industry because they are well paid. That's one of the reasons. The other one is that our PhD program is from 2016, so it's quite recent. We have, in computational linguistics, we have two PhD thesis finishes, and now we have 5 in progress. So not too bad.
Okay, thank you.
Hi, good morning, everyone. It's nice to be in this wonderful city of Logroño, as I was corrected this morning. Yeah. So, second time back in Spain, lovely weather compared to rainy Manchester, where some of you are familiar with already. So, thank you, Raquel and Javier. Thank you for having me, and thank you, everyone, for coming to today. My name is Sheon Ajao, but in the UK, my friends call me Sean, and so you can call me Sean because you're my friend, right? So I'll be talking about the higher education assessment practice in the area of generative AI, and I've listened to fascinating talks, and we don't have all the answers, to be honest. We in academia are actually struggling to keep up, even industry struggling to keep up with industry. And I can relate with your experience with your students disappearing. We have it in data science as well. We do make PhD offers. By the way, I teach data science at Manchester Met. But my PhD was around text mining, natural language processing, and misinformation detection. So the area of computational linguistics is also a familiar territory for me. But recently, our work has looked at large language models, and I'll talk about two papers that we recently, released. One in education sciences, and the other one was a review in an experimental paper in the Journal of Applied Learning and Teaching. So this is one of the slides. Please pardon me, this is totally outdated right now. And this paper only got recently published, and it's from September 2023, and the numbers are practically, almost literally doubled in terms of number of tokens, number of parameters they've trained their models on. And as you can see, the most effective large language models are dominated by only a few players: Meta, Google, Microsoft, OpenAI. OpenAI is also Microsoft, basically. So, and even Anthropic, has significant investment by Google. And so basically, we can see that these models are large, they're computationally expensive to train, and they're also powerful because, as we can see, we've used them, and they can do a lot of things. So I'll first start with a systematic review of how we found the use of LLMs for education. So we looked at about 625 papers using the Prisma systematic review approach. And then we went on to, come up with certain terms to filter out some and to determine the ones that we will look at extensively. Overall, we limited to around 163. And we did go on to publish that. Now, in terms of the titles and the abstract, obviously, as you can see, the GPT model is something that is being mentioned a lot. And there's a lot of talk around performance and its use in education and in other disciplines as well, and including the medical education. And there was concern about how, from the papers we found, where models from the major players were taking exams and passing exams, basically like medical exams, licensing exams. We found most of the papers were from authors in the US, Australia, South Korea, in the UK as well, India. And another prominent keyword that was coming up in concurrence with the authors was AI, and obviously ChatGPT. And people tend to see, LLMs as it's just ChatGPT, but there are other ones out there, even those that academics don't even know about and are not even tracking, and students can use them, to get good outcomes for assessments. We identified some certain labels from these papers. We narrowed it down to 10 different topics. One was around the implications of generative AI for us as academics and in teaching and in learning, and also the use of AI in research itself. So how do we also look at not just applying generative AI to deliver education, but also to help our research as well. And then topics around the infrastructure, like the design of these systems, the algorithms, and what approach this framework follows. And there's also a talk about bias and inclusion, as well in some of the papers. And I think one of the concerns, which also is included in the EU AI Act, includes the talk around transparency, which is more emphasized, especially around models that are once being considered black boxes. There is more demand for things like explainability as well. It's no longer black box, it's now more of a white box. Some papers are focused around intelligent tutoring systems, and there's been a lot of talk around chatbots as well. And as we're seeing disappearance of jobs, call centers, because chatbots are taking the place. And similarly, even in education, they can deliver. And also around the proper machine learning applications itself, performance and evaluation in exams, and also generative AI for writing. And again, coming back to talk about the ethical and regulatory considerations about the use of this, especially for teaching and learning. Some academics are for, and some are totally against. And it's hard to really draw a line as well, because there's no clear yes or no answer. It's like throwing the baby away with the bathwater, literally, if we say discard and do not use large language models. Because, initially when Google came, there were some academics that were like, no, Google is going to change everything. We don't need Google. But now, even we as academics, we do our research and we do use it. And then lastly, around topics around deep learning and then AI itself, which are more technical, including images as well. So those are the main 10 topics. And we found the most prominent one was around the support systems, which related to the design of language, the infrastructure, the methods, the development, the engineering, the framework. So they were a bit technical as well. Not to say that there are no other papers out there as well, and some on deep learning models, and the list talked about was what are the implications of generative AI. But to be honest and to be fair, each of all these topics will always kind of intertwine with each other. And in terms of citations, we found out in 2023, obviously, which is when most of these models became very, very active. Most of those citations, because we look back from 2017, there's actually been conversation around the use of AI since 2018. But we found, obviously, there was a massive spike around 2023 as well. So we did our own kind of very, I would say basic, but our own experiments with two of these models. The most common one, ChatGPT-4, which was paid, and Gemini, which used to be called BAD at the time we did this, which was in September. And we gave it 3 tasks. And one was data analytics, data science, data construction. The construction management had to do with a presentation that they should create. The data analytics task was like this. This was literally the task that was given to the models. And they went on to generate tables, results, and outputs as well. And this is the data science. Apologies, it's squashed a bit because of the font. And we asked it to look at, so this one, they were just meant to look at the data and provide some analysis in data science. But basically, what we found from the results was that ChatGPT, was very good with critical reasoning, but it struggled with technical very technical things. So for example, it did not do SMOT, addressing imbalanced data sets. SMOT is a form of technique where you compensate for classes within a data when you are training your AI models. But whereas BAD was very good technically, however, in terms of its presentation and its quality of the conversation, it wasn't very friendly or interactive enough. And they were marked by the authors, because this was our domain, construction management, data science, data analytics, and it was also moderated as well. And those were the grades. Those were the assessment criteria that was presented or used. So whether they can, the presentation is readable, the evaluation or discussion is critical enough, is there a problem that they solved, is it accurate, did they synthesize it with the task that was given to them, and more of the grading band there. So, that's pretty much, the summary of the findings that we found. So we want better discussions were found in ChatGPT, but, BAD was more technical. It was able to do the SMOT. It will even identify within the data what the classes are without us telling it to do it. It will apply the next appropriate technique to use as well. So what are recommendations for teaching and learning? In the task, and I know you've mentioned it in your talk as well, that tutors need to keep up, basically, because things are, it's a moving target. It's a rapidly moving target. For our practice as academics and teachers, we can actually integrate these tools in our teaching and learning practice. So you give the students the questions, and then you ask them to actively go and find the solutions using, and they should specify which of the platforms they've used. And then you ask the students themselves to write their own recommendation that will improve upon what they have found online. So we all know that they're going to go there anyway. We can as well tell them to go there, yeah? And then ask them to improve on what they find using those platforms. And also, we can design vivas. So it's not enough to just give them questions. I know, so for us, for example, at Manchester, I teach 156 students on MSc Data Science alone. But including viva in the assessment can help be a true test of the knowledge of the work that the students have done. It could even be group vivas, group them into 10, 5. And I've mentioned about reasonable integration of AI content detectors. When we have, so for example, we have tools like Turnitin that can, to a reasonable extent, pick AI-generated text. I've said reasonable because we have to be careful, because even tools like Grammarly that helps check spellings when we write and type can, in itself, because it's an AI that's correcting what you're doing, can sometimes be flagged by some of these tools because it's AI checking AI, and AI sees AI, it says, oh, this is a flag. So how do you ensure that? So that's why we have to be careful before we say, oh, the work you have produced was created by AI. And the students say, oh, sir, I did not use AI. How do we prove that they? So we have to use our own academic judgment as academics, looking at other metrics like what's the student's writing style, what's their engagement in class, to make our own decision. So I think that's my talk for today and summary. So I'll take any questions. Thank you.
Yes, Sergey.
Right. Okay, so
Just 1 second.
Yeah.
Thank you. So I think that this picture is very familiar. So then I'm referring to the last part, very familiar to anyone who is involved in teaching and in assessment. And then, so essentially, so you ended up with an open question. But then, in terms of the solution, so then if you have a case of suspected heavy use of AI in producing a text when this is not allowed, so then what is your response?
Yeah. Okay. So, you know, like I said, thank you for your question, by the way. But I think in terms of that kind of scenario, there are many things to consider. So first, how has this student been performing in other tasks? For example, what's their engagement in the class? And we that set the questions ourselves, have we seen students write similarly in that kind of way? So if someone was weak, for example, I won't say weak, we shouldn't use that word. If a student is not, you know, coming up to the standard in that they should, and they all of a sudden produced a very fantastic piece of work, and we've put it into the AI detector, and it says it's been flagged, you could call the student to a viva, for example. Can you come and defend your work? Tell us how the steps you have followed to achieve this task. You know, that's a way to probe, you know, to know further. Or we could give the student another task. Obviously, for us as academics, it's more work, isn't it? But I think the quick and brutal way to do it and say, no, this is AI, it's rubbish, zero, you know. So, but yeah, to be fair, we should probe further. But do we have the time? You know, so there are many dynamics, but we all love our students and we want the best for them, don't we? So we should probably give them the benefit of the doubt and maybe a second chance at least to see where that goes. Yeah, because these systems are themselves, they do make mistakes. So a model is only as good as the data you give it. So yeah, that's what I'll say. Thank you.
Thank you for your talk. In your review, do you find a real intelligent tutoring system that works? I mean,
well, so it's subjective. Like I said, because these are probabilistic models as well, they're linguistic models that have been trained. They have domain knowledge, but the reality is these tutoring systems themselves are not perfect. And this is why you have things like reinforcement learning from human feedback being incorporated into these conversational AI models, where humans are in the middle to check the accuracy of what is being given to the end user. And the model is retrained in the process of the feedback, so to make the model better. So there is no 100% perfect intelligent tutoring system. I know there was a study from, is it the World Bank, that 40% of jobs will go, they said disrupted, but we all know that they're probably going to go as a result of AI. But at the same time, we cannot throw away humans in the middle, and people need to change. So we need to have things like new roles or careers coming up. So for example, things like prompt engineering never existed a year ago. Now, all the AI companies, they're looking for AI trainers, prompt engineers, you know. And so the human element cannot be taken out, but at the same time, we need to understand that these models are very powerful. I mean, the GPT models, they've crawled the entire internet. They've crawled everything, and there's also an issue around privacy. We can start that conversation again, and that's why OpenAI, they have a lot of lawsuits and everything. So they've taken all this data, whether because it's on the internet, doesn't mean you should use my data, for example. But anyway, those models will give back answers based on what is available out there. So they are limited themselves. Yeah. Okay. All right, thank you.
Okay. Okay.
The next speaker in the session is Professor Ruslan Mitkov of the University of Bradford.
Okay. Okay. Thank you. Thank you, Professor, for inviting me in the first place. So I'm, as I mentioned, as Professor has just mentioned, I'm from the Faculty of Engineering and Digital Technologies and the School of Computer Science and AI and Electronics. So a little bit about me. So I'm actually a computer scientist. I'm through and through from the age of 14, done computer science and also computational linguistics. So I actually did my PhD on computational linguistics, so with computer science, and I have over two and a half decades of computational linguistics, the integration with computer science, obviously the natural language processing that you know today. And I'm also been an academic for over three decades, a programmer, employability champion, a load of hats on. So my talk today is reflective experiences of teaching both NLP and research-informed multimodality AI solutions. So, I'm guessing, does this work? Does this one work? Sorry. Oh yeah, somebody switched it on. Okay. Okay. All right. I'm gonna just basically get you thinking a little bit. Let's have a look at a couple of perspectives. Now, we've all been talking about AI. We've had a couple of talks, and but let's just go back down to your grassroots, which is linguistics. What does Noam Chomsky say about linguistics? Now, I'm just going to take a little bit from here, okay? Because he has, in March 2023, he's got his, as a linguist, he's obviously got his, he's a founder. And I appreciate his work because I've actually role and reference grammar pretty well, as Carlos is also there. So I appreciate where language comes from, and I also very much in the space of natural language understanding. Do our systems actually understand, right? Does it actually understand? And I agree totally with what's here. Let's stop calling it AI, and then call it for what it is, and makes plagiarism software, because it doesn't create anything but copies existing works of existing artists, modifying them to enough to escape copyright laws. I agree with this totally, and as a person who's in the computer science space, very keen on looking at the understanding. However, as an academic with different hats on, we are working with what we have. So if I just take you to this point where we are here today, in a moment of decision, the best thing you can do is the right thing, and the worst you can do is do nothing. And that's why we're obviously all here, because of this transformative plan. Okay, so my talking points are, as mentioned in my abstract, I'm going to sort of take you to where we are in 2024 in terms of NLP and generative AI. I know the other speakers have addressed this. However, I might take it from a slightly different angle as a computer scientist, as an academic, as a programmer, as an industry person as well. Then I'm going to go on to some of the technologies that underpin teaching and how does it improve employability. Because at the end of the day, students are there to make sure that they are going to get a job once they graduate. The third one is a little bit, I'm going to talk about two case studies in terms of my work, my research work, a teaching case study and a research case study. And then lastly, I'm going to highlight a couple of key takeaways. Well, a fair few takeaways. Okay, all right, a couple of building blocks, because I think sometimes everybody's got a viewpoint, but I just wanted to get you thinking first of all, because I think I do it. So I've got this little phrase, someone's knocking at the door. Can somebody tell me what comes next? Anybody? All right, you certainly know that because you have the knowledge, yeah? And that's the thing, and I cut to the chase, right? It's because you have the knowledge. Now, what we want, obviously, if we have the knowledge, we can retrieve, and then we can generate. And believe it or not, the word generation of generative AI has come from the fact that we've been generating text for many decades. It's just now generative AI. And so coming back to, sorry, I didn't catch your name. Mike. Okay, so as Mike alluded, if you have the knowledge, right, you can basically be able to retrieve information, you can generate information. If the knowledge isn't right, you will not be achieving that. And everybody's familiar with this diagram: domain knowledge, linguistic knowledge, corpora for training, and then obviously we've got the methods, the tools, the systems, and the applications. And then obviously we've been using NLP for a while now, obviously improving communication systems, automating tasks, extracting insights from unstructured data, and building conversational agents. Now, Okay, so linguistics has been sitting in its spade for a long time. Now we have this amalgamation with AI. Now for me, I was started off as a doing linguistic NLP, and finding that whilst I started my PhD in 2010, and I was actually going through that transition of being a linguistic NLP to combining it with statistical NLP. And then obviously now we have we have obviously taken it to the next phase. So I've actually been through that transition of seeing, of not having solutions, being able to work things out for myself. So now we have this diagram of obviously the natural language processing, understanding. We have our intersection with deep learning, and we obviously got machine learning, which is a subset of AI. And everybody's familiar with the pipeline. Obviously, all of this is embedded in. And then NLP, I can't, as a computer scientist, I cannot forget my computational linguistics sort of space, which everybody's familiar with, syntax and semantics, natural language understanding, natural language generation, and all of these would be part of any. You would need to think about how does it apply to your application or whatever you are building. Yeah, so in terms of my journey as well, this is what I had to go through, and I still believe that there is still a long-standing issue within NLP conversational systems in refining the accuracy of interpretation of meaning to provide a realistic dialogue to support human-to-computer communication. It's got a lot better. It's there. But coming back to Chomsky again, right, does it really understand? It's actually just looked at those patterns. But we're accepting at this moment in time, it appears that it's understanding. Now, a couple of examples that now I'm talking really practical, okay? So as a computer scientist, obviously, what are we using NLP for? We're using for communication means, document analysis, email assistance, grammar checkers, checking spam, our email inbox checks for spam each time. Automatic speech recognition, machine translation, which you're all familiar with, and the recommendation systems. When we watch Netflix, it's a recommendation system that is behind the scenes. You've got use cases, sentiment analysis, creditworthiness, identifying fake news. Well, the opposite of that is identifying it. There's a creation of fake news on one side and deep fakes. You've got text prediction, talent recruitment, even talent recruitment. Now what's happening is AI is coming onto the scene where there's a lot of discrimination with AI tools in talent recruitment. Speech and text analysis, and you've got the conversation side. So I'm focusing a lot on conversational agents because that was my focus as well, and that's my focus in terms of my research predominantly. So here's an example of a typical NLU sort of system. Yeah, you've got your user uttering, I want to find a restaurant. First of all, it needs to understand by picking out the key intents. Obviously, you've got dialogue tracking, and you've got the generation, and then it's obviously turn taking after that. And a couple of things from a very algorithmic point of view. You've got machine translation, source and target, summarization, input and summarize, dialogue, obviously the dialogue turn taking, as I was saying, and then I've just an example of an algorithm there. So when we're looking at spam and spam filters, we may use a very simple spam filter. Then again, we will use over time more sophisticated models have come in place, and machine learning models as well. Okay, so we just cannot forget natural language, its issues still with it. It's the issues that are behind the scenes, even though we've come to talk about AI and where it's going and how we're going to use it. Yes, it makes mistakes. Okay, speech requires context. I mean, different dialects, different tones, different words for different things, different lexical sort of items. And then you've got irregularity and the ambiguity. All of this is still in play whilst we are working with these systems and working with the technology at the moment. And obviously, I've given you an example here of some medicine and how if we had a healthcare sort of data set, what we need to think about. Obviously, we need to think about different words, same meaning, different grammar, same meaning, different expressions, same meaning, and same word, different context. All of this we always need to think about. And and then at one point, some of the linguistic courses possibly, you may start on what we call the rule-based natural language processing, and obviously now we're on that space of statistical NLP. So there's a journey between the two where it may appear, right, to some, right, that when they're using rule-based NLP, that they are using, using AI. They're actually not, okay? So there's that distinction. Obviously, we know that rule-based is historical, and statistical requires a large amount of data, difficult to build, no understanding of the context. However, we are going to go on to the models as well. And at one point, you've got various critiques on there, and understanding is deeper than word matching. So just want to get to the point where we get to what have we got in place. I've talked about the rule-based. So from an NLP point of view, what are some of the things that we want to do? We want to tokenize, we want to do parts of speech tagging, chunking, sentence boundaries, syntax analysis, and sentence training. But then with deep learning, we can do all of these, which is what we appreciate. When we use Microsoft Teams, we have the caption generation that goes on simultaneously for us. So we have that question and answering. So some of those, all of these you are familiar with. Okay, so that's just the background. Now, let's just move on a little bit more. Now, the timeline for natural language processing until 2020 was GPT, which is generative pre-trained transformers, okay, being able to predict what the next word in the text sequence will be. And then we've got the large language models. Now, simple as when we start to say something, a helm is, what we're doing is we're invoking a language model, and which is giving us the output wheel for steering ship. And at one point, what we had was a range of techniques, bag of words, TF, IDF, co-occurrence, and we had vector embeddings. Sorry, it's not very clear on the screen, transformer models, and now we obviously got the large language models. So we've seen this evolution, and some courses will obviously focus on the earlier parts, and obviously some courses and some problem-solving activities will focus on the others. Now, what I want to show you now, the first three speakers sort of alluded to a lot of what's happening. So this is as of December 2023, this diagram, and ChatGPT, everybody's familiar, accessible, out November 22, released by OpenAI, basically a conversational model, optimized based upon GPT-3, and basically optimized dialogue, human sort of centered, sort of conversational, human centric, and basically a data set by human labelers. Okay, so remember the human element that we all spoke about before. Now, just a couple of these I just want to mention. So if we go on to GPT-3 came out in March 2023, and it was more about starting more performance, more sort of significant performance, better responses as well. And what you found there was that the evaluation task, before it was a case of, okay, let's produce these outputs, then it came to the fact, okay, what are going to be the benchmarking? How are we going to check if things are going to be correct, or how accurate? What's the precision? So we've got GPT-3 there. Then we've got moving on, I'm just going to mention a couple. For instance, Palm, which I think is very interesting. So Palm, which is based upon Google's BART chat model. So Palm, and then Palm 2, which is also on there. The fact that it had its multilingual introduction, and it had its mathematical reasoning, the fact that it could do a lot of natural language generation, and also tested on what I think they call the language proficiency exams. There's one called the Spanish Delhi CL, I think. So the fact that you've got this introduction of the multilingual models, which is obviously which is going to be key for obviously this sort of space in terms of the linguistics and the NLP and the AI space as well. And then we've got the likes of Llama and for Meta, we've also got Llama and Llama 2. So there's a lot of more emphasis on chat safety as well, and chat safety evaluations. So the introduction of the ethics of what the content, what is being churned out, is also being looked at by the big companies as well, by the prominent companies. And then you've got Claude and Claude 2, I believe it is, by Anthropic. So this timeline, so these large language models from BERT to GPT-4, now GPT-4 is 10 times bigger than GPT-3. Now, I will talk about a little bit more what's coming up next in a bit, but the more the parameters are, basically there's more capacity to work out the relationship between the words and the phrases. Okay, right, so just to highlight that 2020 was the time when things just changed for us. And at that point, excuse me, didn't notice there was a step. At that point, if you notice there, the peak of inflated expectations was in 2020. And as you can see, things have changed so much in 4 years. So to point of all we were managing at that time was we could model, this is a healthcare example, we could model and we could test reports and we could get some, create some trained classifiers, and we could get some, a class basically saying whether a particular person had pneumonia or not, for that matter. So that was where we were in 2020. Now, I'm just going to go through a couple of examples from the AI side, because I think sometimes it's clear just to understand why have we got to this point. So I'm just going to give you just a little bit of a running awareness. So in 1997, IBM's Deep Blue computer was able to win against Garry Kasparov, who's the world chess champion. So that was 1997. Then we've been able to detect malware and viruses on machines of various forms. And then we've seen on our phones, we've been at phone apps, for instance, we've been able to have face recognition, being able to work out the features, being able to allocate siblings, friends into their particular albums. And then we've been able to do the self-driving cars, the fact that it's been able to see, it can see the objects, the landmarks, it can see, it can see edge detection as well. So the fact that we've got self-driving cars which are able to see. And then to the last one, I give a large language model an image and say, basically, show me what you can make from these ingredients. There's 4 ingredients. From that, can anybody suggest what I could make as a quick one? Pancakes, exactly. There's a list of 10, right? So, the fact is that all of these qualities, the fact that we can see, hear, speak, we can learn, adapt, we can reason, we can generalize, we can infer. These are our human qualities, our human attributes. And the fact that we've got systems that are being able to simulate these, is why we've got AI today. And the fact that it's giving us the answers. It's that simulation, and it's not that understanding, but it's the simulation. So that's why we've started to get this space from the deep learning. We've got the generative AI, which is basically being able to generate various sorts of outputs, new output, whether it's a conversational form, it depends upon what you are using. So to now, in 2024, right, OECD, the Organization of Economic Cooperation Development, have come up with a new definition of AI based upon, prior to the one that I've just mentioned, the simulation of human behavior, to the fact that it's occurring in different forms. So it's a new machine-based system for explicit or implicit objectives, infers from input it receives how to generate outputs such as predictions, content, recommendations, or decisions that can influence physical or virtual environments. Now, different AI systems vary in terms of the autonomy and adaptiveness after deployment. Now, this could be, so if I've got an IKEA app, I can basically pick an app from my from my basket and say, watch it live. So at that moment in time, there is object detection happening virtually. I'm sitting in my office. I'm going to I want that table to sit into that space. I have got VR in space, augmented reality, and I've also got object detection. So the fact that we have got AIs coming in different forms, and that is so important. Right, and then let's just move on. So when it comes to AI, everybody's familiar with NLP. We do not need to say that. So the predictive linguistic part, the deep learning part, the machine learning side, in the sense that we're using a whole load of techniques to be able to learn from and improve from tasks by experience. We've got the deep learning where we're using large data sets, and we're basically looking at being able to derive sort of patterns of complex patterns, and also be able to infer. Then we've got speech side, then we've got the vision side, which I've just mentioned. We've got expert systems, which may form very well in a linguistics domain. For instance, a mortgage scenario, you probably have a good 100,000 variables for a mortgage case study, right? Planning and optimization, very, very familiar to the driverless cars, and robotics as well. And then when we come to large language models, we will see from this diagram on the right-hand side that, we've got AI's reasoning, learning, and autonomy machine learning algorithms. And then you've got your deep learning. What does that comprise? And then you've got language models, which is a sequence modeling, predicting the next word, being probabilistic. And then you've got the large language models, which are using everything beforehand, which are the deep learning, the machine learning, obviously the AI there. And so the fact that we're at this space now that we want AI to basically think like a human for us, act like a human for us, give us reasonable actions based upon what we give it, right? And also to inspire us for obviously further reasonable thinking. So this is what we want AI to do. Now, I think I'm going to just highlight this because, right. I think the big question is the part, we've got obviously a larger world population. We've got more connected devices. We've got more connected devices per person. And then in terms of the storage, we could only store 125 megabytes in 2005 to 120, I'm going to read it, 128, it's gone a bit blurred. And then we get to the point where 1 terabyte on your fingertip, which can store 175 of these, will hold every book ever written. And in 2024, we have the NVIDIA, okay, and there's a massive hardware market now, race. There's a race for models, there's a race for the hardware market as well, and NVIDIA are creating $10,000 chips for the next generation GPU, basically to handle all the processing power for AI, robotics, and computing. Now, as you can see from there, as you're over time, what we find is that the cost of storage is becoming less and less even though we've had more parameters per language model. Okay. Right, I'm going to be mindful of my time as well. So one of the things that we really need to understand is that I know we're talking about linguistics, NLP, and AI. We need to think about where are these solutions going to be used. They're going to be used by businesses, right? Businesses, sectors, whatever the case may be. And the big thing is that businesses pushing for the use of AI because of the opportunities that it's providing. It's providing so many efficiencies, so much obviously in terms of competitiveness, innovation, to name a few. And some of these businesses do not need to know under the hood of deep learning models at all. They can basically use generative AI, right? And as you've all found that when the talk was ChatGPT, have you used ChatGPT? Because it was so accessible, so user-friendly, so conversational, we were all hooked. Everybody agree? Yeah? And that's because of its accessibility, businesses have cottoned on, and we need to understand that from a course expectations and delivery, our students are like very, business-centered as well in that sense. Okay, so there's a massive push, and we need to universities need to respond to that. So what do we do with generative AI? We generate natural language. So I could say, here's a piece of text, summarize it for a reading age of 5, for a reading age of 12, and a reading age of 14. Okay, and it'll generate. So with one input, I got variation of outputs. Generating code, translate something from Python to Java, because you might be using a lot of Java NLP. And then also troubleshoot your code, okay, once you've once you had updated it with anything new. Generating images. For instance, we're creating images based upon any form of text. So you've got the likes of DALL-E 2, DALL-E 3, and then, you know, all coming out. Now, when we look at AI and generative, generally machine learning and deep learning and generative AI, we're thinking about the same things. However, generative AI has this flexibility, okay, which is, all right, from one input I can generate extensive outputs, which is what we've seen. And we've got the prompt engineering. So GPT, I think I can skip this. Okay, all right. I'm going to stick on business for a few minutes because I know we're talking about teaching, but business is a massive part of teaching. We cannot discount. So just for a few examples, this is a McKinsey report, April 2023, about 1,623, something like that, participants. It was around that much. So what did they use it for? So they used it for marketing and sales, service operations, for risk management, strategy and corporate finance, HR, supply chain management, and manufacturing. And there's some percentages there. And then, obviously, what have they been doing? They've been using ChatGPT. And what they've done is they've been using prompt engineering cheat sheets. They're exploding across LinkedIn. And then what are companies actually doing? Some of them are reducing cost in their core businesses, creating new businesses and sources of revenue, increase revenue for core businesses, increase value of offerings by integrating AI-based features and insights. And there's just 3 examples, and I think everybody's very familiar with how to ask that. And then just to highlight, businesses are using it for this reason. So they would hire potential linguists or developers to aid in these 3 key goals: innovation, competitiveness, and productivity. Right, so I think everybody's familiar with the fact that pre-training, basically using the standard technologies of masking and obviously being the predictive tests, and fine-tuning, obviously this is where RAG comes in, retrieval, augmented generation, where you introduce your own small data set, a book, a PDF, whatever that case may be. Impact of the top 10 generative AI trends, I'm going to miss and really the space is focusing on those downstream tasks. So a particular model might say, well, okay, all of these previous ones are working on, I'm going to pick out something more specialized, and that is the way that they're approaching the scene. Okay. What a big thing which is also coming out is this multimodality and AI, multimodality AI, natural language processing and vision. So here we've got an image. It's obviously picking out the objects, and then it's been working out the boundaries. From the boundaries, it's been able to being able to work out the relationships between those in order to create those sentences. As you can see here, there's a vision deep convolution neural network, and then we've used some sort of language model like a recursive neural network to look at the sequence of text as well. So this is quite large, and as you can see from that image, you can basically, get precision through the multimodality. Okay, so just to highlight this from a language model perspective, and I'm going to go on to the teaching, that if we look at that image there, we've got GPT-3, and I said GPT-4 was 10 times bigger than GPT-3. Look at the side of GPT-5, which is coming around the corner, and basically we've got something called GPT-4 which is omnibus, which is basically an end-to-end single model, which can deal with a lot of comparisons as well. Okay. All right, so here are some examples. Everybody's talked about tokenization, training process, so this is what we would go through. Okay, right, let's go on to teaching and learning, because that's why this is my area. So, okay, so I have an undergraduate course which is called BSc Honours Applied AI. We are introducing a new course which is called Computer Science with AI next September. We have a computer science course with AI modules already, which is British BCS, which is British Computer Society accredited. So we have a host of AI modules in that course. However, the course I've been running is very a unique type of course, which is very, very project-based. And my focus here was obviously the 2 courses that Professor had highlighted to me, which were these. Now, for any course, obviously, you've got to understand what is your curriculum. What does your curriculum mean to you? And for us, the practical curriculum qualities are to ensure that obviously we create confident, connected, critical, and creative students, okay? And those are the goals. And then obviously when we're developing our curriculum, it's program-centric, it's liberated-centric, liberating students, obviously, and future-focused learning, obviously, for them, and obviously for the scope of the course, and research-engaged learning. So I teach undergraduate MPhil, masters by research, MPhils, and also peer, and also have PhD students. We also have a postdoc provision in AI as well. So the top 10 skills of 2025, it doesn't matter really whether you're now that the roles, there's a multidisciplinary need, right? The top 10 skills, and notice here that creativity, originality, and initiative is absolutely key there, and the whole host of them, technology, design, and programming. I mean, I could say that this has come from the World Economic Forum as well. Okay, so on my course, okay, I'm only taking one particular example. So they have, one very interesting thing is you need people who are interested in what they're learning, yeah? That is the first thing, I would say, right? Don't have anybody coming through the doors, but you do, yeah. It's the way it is, yeah? So we've got stage 1, they learn the methods, the theories, the tools. Stage 2, knowledge and skills. They learn about the ethical implications. So just to highlight, so I work with a small company. I work with an AI tech company. We've worked on a smart ethics tool. I've introduced some of that smart ethics tool into my teaching and my assessment as well. And the third year is sort of like co-design industry as well. So I'm going to talk particularly on the project module first of all. So with my project module, when we were talking about skills, you know, being able to problem solve, being able to use frameworks and methodologies, theories and backgrounds is very important. Notice the data sets are there, you know, doing experiments as well, being able to know what's the way to test. Project management, obviously, this is a group project. So what are some of the techniques and teamwork? Personal development. So what's unique about the course I have is students are learning a subject where they're reflective on every single decision point they make via blogs. And I think that is absolutely key to working out whether, obviously, ongoing in terms of academics, are students really on track? Are they getting where they are? At the same time, those decisions that they make at various points, right, how those impact other decisions they make and their reflections on it. So in level 5, we do a lot of cloud-based work as well. Obviously, there are a lot of cloud-based tools. There's a lot of cloud-based, tools where you can learn about AI. Also methods and the multidiscipline, and level 6 is more open source. Right, and then notice we've got a poster and a demo there. Right, so I'm going to talk about my particular project module that I have. So in my project module, they had 3 projects, and in the first one, I did it as a very scaffolding approach. So they've got the project management, they're scaffolding on, the learning part, they're scaffolding, the way they're using the algorithms is scaffolded, how they're working with their work examples and the case studies is all scaffolded. And then what they have is this is obviously the things that I did. Now on the second one, on the second one, they actually get assessed on the Agile Scrum skills. They're using some algorithms. They're also going to use an architecture where they don't need to understand the underneath the hood. It's okay, right? However, I want them to produce something. I want to produce an application. And that is the one I'm going to talk about. And the second case study is the multimodal understanding and generation for medical images and text via visual language and pre-training case study. So with any sort of problem-solving sort of thinking space, we've got to decide, what are we doing now? Is this something are we predicting something? Are we trying to pack something in a suitcase type of analogy? Are we trying to train something to give us rewards? Okay, are we trying to predict our nearest neighbors, a bit like recommendations and Netflix, and when we get recommended our next movie to watch? Yeah, that sort of thing. Is that is that the realm of what you are looking at? Are you trying to combine, do you need to evolve and combine the best traits? Are you trying to recognize images? Are you trying to understand sequences like stories? Are you compressing and reconstructing data? Are you trying to find the best path to exploration? And are you making predictions with probabilities? Is that important? Which of those fits in what you want to try and do? Because it gives you an idea. And that's one of the things. And then with any sort of thing, you would have a system. And the system is you have an environment, a context, and then your AI system needs to perceive, okay, the data that's within that AI, that domain. And then obviously we use our models, we have our output, and then as in the context, it's actioned upon. Okay, so one of the things we need to realize about these algorithms is bias. So here's a classic example of where it's implicit in the code that there's bias. Okay, that anybody else who didn't fit Asian and female or African male, yeah, or male, right, would be biased. Okay, and then notice what you can do here in terms of the coding. So this is coding 1. This is an example where first time round we have bias, and the second time round we are going to change it so that it's unbiased. This is refining, augmenting the code, because you could get a result, and if you're not augmenting, you are not. You have obviously got an issue there. And the second one here is another large language model example of demographic stereotypical associations, which are also part of how you generate the model. Okay, this is how it's put together. So I'm just going to skip on just for the case sake of time. All right, so I've got a case study. So my case study is creating a chatbot. Okay, and what we first of all got to do with anything is understanding concepts which everybody's familiar with. And here is a total chatbot, and I'm basically saying, right, a couple of things that the story should be about. They should be able to book a room. They should be able to schedule cleaning the room. There should be some frequent, I've just done a snapshot, checking timings, checkout timings, and cancel read, just as a snapshot. And then you have what the user may want, right? And then what the bot will also provide for you in terms of various responses. Right, so you use Rasa, and it's in a framework. It's basically, as it says, it's a leading open generative conversational AI platform to deliver the next AI assistants. So we've got a configuration framework. We need to customize with some files. And what we also need to understand is what type of chatbot are we building? Are we building something which is going to be a very sophisticated one? So we're building a two-stroke street where we're going to use a little bit of conversational driven development. And 5 is obviously, taking it to the absolute, that's something that you would do, you would do maybe on a PhD. Right, so this is my case study. So I wanted my students to create a chatbot using Rasa, and the topic that they're building a chatbot about was their own choice. And what they did beforehand, they did a basic chatbot on keyword matching. So we took some text from ChatGPT, right? And we said, here's your text, and I want you to be able to invoke that using your code. Right, so your code, that was keyword matching. Now from there, they will be able to say, well, actually, there was no position. It basically, anywhere, obviously keyword matching, it will associate anything, and it will give you any response where the keyword is matched. So that was the first exercise. And then understanding the limitations that we need to have better tools to help us build. Yeah, and that was the case. So what I did was I also gave the students a YouTube video to say a journey to the stadium, face recognition in action to inform inspiration. So one thing is their own learning, second thing is an inspiration. And what they needed to do was create a simple chatbot and extend to the hotel chatbot as well. Now, I'm going to go through this and I'll show you the code file in a couple of minutes, okay? So what they had to do was choose the idea, get it approved, but what they did here was they used ChatGPT, right, to help them create the actual utterances, that exhaustive set of utterances that you and I would use. Okay, for checking in a room, for instance. So my question is, what are the different ways to say you want to check in to a hotel room? To say, and I've been explicit about that, and then I've got 15 different. They can literally take those and edit those and reuse those as part of their as the potential user utterances that will be there, right? That was one example. What they, like I said, is embed as possible utterances, ensure intents and stories align, extend with rules and actions. So once they use ChatGPT, they could also use ChatGPT to help them with thinking about what their rules may be as well. And then obviously the training and testing the machine learning model and creating the test pathways. Okay, all right, can I, 2 minutes, okay. So, okay, I didn't realize that I'd gone, yeah, can I, okay, because I didn't realize I'd gone on so much. Okay, all right then, so I'll just leave, I can leave my file, okay, and I actually did have a, okay, all right, so this is my students' presentation. So they decided that they were going to do a cruise liner, they were going to use Rasa, and they were basically going to use Rasa, and they were also going to do, as part of Rasa, they were going to get a picture of the person's face uploaded, and every time they were checking into the rooms, it would check that the face signature was correct. So I'm just going to flick out there. So they did the usual functional requirements, and what they did, I did have a video I was going to show you of their chatbot, which works there, which I won't do. And then obviously they needed to work out the dialogues framework for that. And then obviously they worked on how they learnt and augmented using ChatGPT. So they had to prove where they started without any help and where they got to with some help as well. And then obviously understanding about the limitations. So from a research point of view, I'll try and be really quick here, because I noticed that other people extended. So I'm hoping you'll give me a little bit of a leeway. Yeah.
You've been talking for 55 minutes.
Have I?
Yes.
I really have.
Yes,
Have I?
I think you have extended your time a lot.
Oh, right, have I? Okay, I will finish off. I certainly will do. Okay, so I'm going to finish that there. So from a research point of view, I've been using multimodality when it comes to pre-screening people concerned about memory. Okay. All right, so all right, key takeaways, a couple of things. A lot of things which may be useful for everybody is that the AI and the language technology is faster, better, cheaper, and more accessible. AI literacy for everyone, and the human-centered thinking. Decision-making points, creativity points for students, strength and depth, alternatives. I'm just going to go on to the connected, using dummy guides are useful. Requirement for agile and adaptability. Access to AI leadership is really, really important when it comes to this sort of space and direction. And very important is for the universities to know when what they call shadow AI is being able to know when a chatbot is used, and the fact that it's not infiltrating or causing any conflicts with other systems. Appreciate the limitations and the fact that new roles will be created, and there's going to be a lot of awareness and vigilance required by everybody. Okay, thank you, and I'm sorry I've run over.
Thank you, Kulvinder. So we'll continue with the discussion at the coffee break.
That's perfect.
Okay, and see you in a few minutes.
Thank you. I'm ever so sorry about that.
Okay, so welcome back. After this coffee break, we resume the events program. And we are very pleased to have with us Carlos Periñán Pascual as a plenary speaker. As you may already know, he has made remarkable contributions to the fields of knowledge engineering, natural language understanding, computational linguistics, and text mining. He is a senior lecturer in the Applied Linguistics Department at Universidad Politécnica de Valencia. His doctoral dissertation aimed at the resolution of word sense disambiguation in machine translation. As a result of his impressive research work, he has developed a number of free access online computer applications, including Artemis, which automatically generates the semantic structure underlying English text. Also Dexter, which serves to compile, manage, and explore specialized domain corpora for term extraction. Damien, which performs data analysis on text corpora by means of descriptive and predictive statistical measures, as well as machine learning models. And Casper, which detects natural disasters from Spanish and English messages posted in social networks, among others. He has also been the director of the Fangram KB project since 2004, whose main goal is to develop a lexico-conceptual knowledge base to be implemented in NLP systems requiring language comprehension. And in the last 2 decades, he has actively participated in up to 13 research projects funded through competitive calls of public or private entities, being the principal investigator in 6 of them. He has been invited to deliver seminars about knowledge engineering and NLP in Spain and also abroad, and he is the editor-in-chief of Journal of Computer-Assisted Linguistic Research since 2017. He has recently written the book Minería de Textos para Investigadores Lingüistas. It's a real pleasure to have you here in this international networking event. Thank you very much, and the floor is yours.
Okay, thank you. Now better? Okay. So, well, this is the, well, thank you, first of all. Thank you for the organizers for their invitation to take part in this event. And, well, this is the title of the talk, Constructing Synthetic Corpora with Large Language Models. Okay, the key word here is corpora, rather than large language models. I'm going to tell you why. Okay, so this is the standard definition of corpus, you know. But I have intentionally omitted the end goal of corpora in this definition. Because today, corpora can be designed and developed for linguistic research or for text mining purposes. For example, training, evaluating, validating, etc. And the nature of the corpus is different. I mean, for linguistic corpora, you have collections of natural texts because the goal is to have an empirical description of language use, as you know. But in the case of text mining corpora, the collections can be natural, but also synthetic texts created by the machine itself, okay? Providing that the texts are the texts adequately represent the targeted domain, okay? Well, so the purpose of the talk. The purpose of the talk is to explain how to effectively design and develop synthetic corpora for text mining purposes, not for linguistic analysis, but for text mining purposes, through prompt engineering, and not with the GPT family models, no, with medium-sized and large language models, also based in transformers, and I'm going to tell you why, okay? Well, so constructing synthetic corpora should be understood as a particular task of constrained text generation or controllable text generation, which aims to produce text that meets certain controllable constraints. And this is the key word, constraints that are imposed on the output. Okay, so these constraints is the challenge. How to impose these constraints on the output, how to shape the output through these constraints is the challenge in prompt engineering. So generating synthetic corpora or data sets is not something new. Okay, but it has gained great interest recently. Okay, due to transformer-based, the appearance of transformer-based language models trained with vast, large amounts of texts. Okay, which contribute to generating the popular pre-trained large language models. So there's a renewed interest in this topic. And this is the reason why large language models are becoming the mainstream in constrained text generation. Okay, so we've got to impose constraints to shape the output. And we can do it through or by fine-tuning the language model through prompting. This is one possibility. Okay, so prompting is usually understood as a way of programming. So prompting allows researchers to instruct the computer in natural language. This is the idea. Okay, so here the challenge is how to perform the prompting. What is the problem? The problem is that large language models are black boxes. So how can we program the computer if internal decision-making processes are often not transparent or even easily interpretable? So this is a problem, how to program something that you do not know how it works. Yeah, in theory, but not in practice. Even the people who design it. Okay, so this is the challenge, how to control the large language model. Well, controllability. Well, as you know, many people have been talking about this. Well, OpenAI has significantly contributed with models such as GPT 3.5, GPT 4, producing human-like, realistic texts. But in my case, I've got a problem. Some researchers have got a problem using these two models. It's very easy to understand. Suppose that you want to design and develop an application to be deployed, to be implemented in real life. So you are thinking in a production environment. You've got a client and you are developing an application using a language model. Where's the problem? Well, today, apart from the web application, OpenAI only provides paid API services. First problem, paid. So what does it mean? Very easy. The cost can be prohibitive for your application if you've got to process large amounts of data. I'm talking about a production environment. Second problem, it's an API service. So you've got the typical problems with API services. Latency, maybe, interruption of the service that it happens, okay? Slow response time sometimes. And this is particularly critical when you are developing, for example, and this is my case some years ago, you are developing an application for emergency crisis. You cannot depend on an API service to get the knowledge, okay? Well, so alternatives. There are many alternatives. Well, let's use open source large language models. Okay, there are some which are quite good in this regard, okay? But we've got more technical issues with these problems, particularly if you want to deploy the application in a production environment. Problems. Well, the idea is to ram the open source large language model in a local machine or on your local server. Technical issues, many hardware technical issues, if we are talking about an open source large language model. I'm talking about RAM, I'm talking about the storage capacity, I'm talking about processing power, blah, 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 blah. Okay, more alternatives? Yeah. So, although employing, researching with large language models such as GPT 3.5 or GPT 4, or open source large language models can get very good accuracy with the results, today there's a current research in which they are developing smaller models which are more cost effective. So smaller models which can, which can have a reasonably, not a perfect, but a reasonably good result. and they are more cost-effective to be implemented or to be deployed in the real world through applications that you can sell to clients or that you can install in different places, okay? This is the idea. Okay, so we are experimenting with smaller models, smaller transformer-based language models, okay? That can be deployed in local machines, on local servers, but that can be easily integrated in downstream applications. This is the idea. So are they reasonably good? How do they work? What is the performance? Of course, they cannot be competitors with GPT 3.5 or GPT-4. But the question is, are they reasonably good as far as the result is provided, thinking that you want to use them for text mining? And I'm going to demonstrate that if this is possible. Okay, so methodology. Well, the methodology. This is non-issue for linguists, but this is a big issue for text miners. Why? Because unlike linguists, who clearly have a methodology for corpus construction, most researchers in text mining do not develop training corpora with a robust methodology. What is the methodology? This one. The more, the better. This is the methodology. Okay. Well, maybe that methodology is good. Okay. If it's good, perfect. I stop talking. Okay? But, okay, I'm going to demonstrate that this is not always reliable. So, what is the purpose? The purpose of this talk and what we are doing in the research, because this is the tip of the iceberg. I'm going to put this into context a little bit later. So we adopted the methodological framework used in corpus linguistics, okay? We adapted to design and develop synthetic corpora using large language models. We adapted. I mean, why not working in the same way? I mean, is it feasible? Are we going to have better results? Or the more the better is the winner? This is the challenge, okay? And the challenge is with medium-sized and large, but not very large. We're going to talk about the number of parameters just a bit later. Language models, second challenge. Third challenge, not English, Spanish. Let's do it more difficult, okay? More challenge, I love challenges, okay? So this is the issue. Let's see if it works, okay? So these are the 3 steps. I'm going, because most of you are experts in corpus linguistics, so very, very briefly, just in 5 minutes, the topics that should be considered to generate this synthetic corpus, and afterwards I'm going to apply it. Okay, first, we establish a research question. It's very important. We guide the construction of the corpus. Second, we address domain considerations of the corpus, or qualitative characteristics of the domain. And here we've got to talk about the domain description and the sampling design. I am doing this work as a linguist. This is the idea. I am trying to put the methodology from the point of view of linguists. And afterwards, I'm going to put on a different jacket, okay, the text miner jacket. This is do you understand? This is the idea. Okay, so now I've got the linguistic jacket. Okay, qualitative characteristics of the domain. Domain description, we've got to specify the methods, the resources, we've got to fix the domain boundaries. Okay, qualitative characteristics of the domain. Sampling design, we've got to decide the sampling unit, we've got to decide the sampling methods. No sampling method in text miners. Sampling method is everything that I can gather. This is the sampling method. Okay, and here there are 3 issues. There are 3 issues, as you know, in which you've got to make decisions, very important decisions, because these 3 issues contribute to determining lexical diversity in corpora. So some stratification, proportionality, and randomness. Okay? So very quickly, stratification. So in this case, we've got to generate synthetic corpora based on certain categories, on certain strata. Okay? Because we are adopting, okay, the methodology. Proportionality. All the texts in each strata, in each category, should be proportional. Randomness, relatively proportional. Okay, so the volume of text should be relative with respect to the other categories. Randomness, well, this is grounded, as you know, in the premise that random samples of text are supposed to be less biased. Okay, so I am working as a linguist. Okay, perfect. Now, the third step, quantitative characteristics of the sample size. Well, so everybody knows, all of us agree that, well, size matters here, obviously, okay? And it is a critical factor, both in natural and in synthetic tests. But the question is, will increasing the size of the synthetic corpus guarantee a better performance in the text mining system? Okay? And here, there are some researchers who criticize, who say that the more the better approach should be improved and should be replaced with alternative techniques. Why? Because the more the better is not reliable when you have these two situations, these two problems. So selection bias. I mean, if there's a skewing towards some specific types of texts over others, this is selection bias. Coverage bias, the texts that you can find in the real domain do not match with the texts that have been synthetically generated. So in these cases, the more text you synthetically generate, it does not necessarily mean that you're going to improve performance if you've got these two problems. Okay? Perfect. Okay, so this is the theory. This is the methodology. I have been working as a linguist. And now I put on the jacket of a text miner. Okay, perfect. Let's apply this methodology. And I have chosen, and I'm going to tell you why, because this is not the project in which we are. This is just one of the methods that you will use to conduct the whole project. Okay, so I'm going to use the institutional elder abuse problem. I'm going to create synthetic corpora for this, okay, let's say now topic, but it's not a topic. It's a community problem. Okay, it's a problem that happens in cities. Okay. So, I'm going to apply this methodology, but first of all, I've got to put this into context. Why am I talking about this? Did I choose this topic because I thought it was interesting for you? Okay. I could have chosen to talk about this because this is the project indeed. Okay, so to put this case study and this synthetic corpus construction into context is to talk about this project, okay? Because we've got to understand why, what is the motivation? This is the Allegro project. Well, the Allegro project is a project which aims to create a platform, an online platform. We are developing an online platform that serves to explore society from the perspective of social network users. So you can explore their problems, citizens' problems, as far as they are describing them. I say as far as they are describing them because problem detection is subjective. Somebody can say, I've got a problem, but another person can say, no, this is not a problem. So problem detection is subjective. So from a subjective point of view, we've got to recognize if that person is presenting a problem. This is a very fine-grained text mining task. It's not just to say this is about politics, this is about economics. No, no. This is a problem about institutional elder abuse. And we've got domestic elder abuse, we've got financial elder abuse, we've got, about this one in particular. So, okay, this is the project. I'm going to briefly describe this project because you've got to understand why the motivation of working, of designing this synthetic corpora, okay? So this is the goal of the project. This is the aim, the purpose. So this is the research question of the project. Can we develop a system that can automatically analyze, aggregate, fuse multimodal data, text, audio, and image, information from text, audio, and image, from posts that people, messages that people post on social networks, and we gather everything together, okay? And then with this information, we determine if there's a problem or not, and specifically which problem. Okay, this is within the framework of smart society. So this is the object of analysis. This is an example of an object of analysis, for example, a tweet or a Facebook post. So you've got an image and you've got some text. Okay, and this is the architecture. Okay, this is the architecture, the whole architecture of the system. And if we zoom into the central part, we can see that this system, remember the goal of the system is community problem detection. I say community problem and not social problem because there are two types of problem. One at the social realm and another one is a physical realm. I'm going to talk about this, okay? But this is what traditionally have been tagged as social problem, okay? Social problem recognition. But I use the tag community problem because not all the problems are social. There are problems who are physical. Problems in infrastructures, problems with, these are not social. These are physical problems. This is what we are talking about, the smart city framework, okay? Perfect. Okay, sorry, so there are two, as you can see, there are two modules. One for data analysis and one for data fusion. And in turn, in the data analysis module, you can find three components. One for each type of test that can be processed. Each type of test that you can find in user-generated contents. What can you find? Text, image, audio, video. Well, we treat the video as a combination of audio and image, okay? Perfect. So they are independent components, but clearly interconnected. And we need an ontology. There's a lot of knowledge here that we extract. And the question is that we've got to manage all this knowledge. So we need an ontology. So this ontology organizes all the knowledge extracted from user-generated contents. And we have four layers, okay? So at the top layer, we've got the social problems. Social and physical problems, two realms, okay? The social realm subsumes dimension problems such as living, economy, and governance. And the second one, physical, mobility, infrastructure, and environment. This comes from the smart city framework. Okay, perfect. Let's go on. Third level, we've got domains of problems. So this means that each dimension organizes a number of domains towards which citizens can show some attitude of disapproval. So citizens can show an attitude of disapproval towards health, towards consumption, towards, well, why not, politics. Okay? And the same for physical. Okay, so there are ecological hazards. There's problems with the telecommunication infrastructures. This is physical, not social, but we deal with both of them. This is the reason why we talk about community problem, okay? Not social, just social, okay? Perfect, problems with traffic and so on. And there's the fourth level. You cannot see here because of a problem of a space, okay, with the slide. And it is, you've got the realm, the dimension, the domain, and then you've got the specific problem type. We've got the specific problem types. And this is the most interesting for us, of course, okay? So, for example, if we return to our previous example, the system is able to process the text and has got to identify, this is a very simple and easy text to be processed. That's the reason that I have just put it here to make it easy, the explanation. But the system identifies that this is a traffic congestion problem type. And once you know that it is a traffic congestion problem type, this belongs to motorized vehicular traffic, mobility dimension, physical. Okay, perfect. Okay. So the ontology, this is a knowledge engineering project, okay? Knowledge engineering project with linguists, people experts in social science, and most of them computer science scientists. More than 20 computer scientists and just 5 linguists. The question is why? Well, because this is a computational project. But I'm going to tell you where linguists are very good at. Okay, so for example, this is the ontology, and the ontology is not just a hierarchy of classes. So you've got to specify relations, categories, you've got to specify properties, and all these elements should be described formally through axioms. So we have a fully fledged ontology. This is the first step, to have the ontology, okay? And now, and I'm going to finish this brief introduction about the project. Now, the problem schema. Yeah, I had to explain those things because we've got to understand the problem schema, which is necessary to understand why or how we designed the synthetic corpus. So what is a problem schema? A problem schema is a formal representation of the meaning of a problem. So every problem type that we identify, for example, road marking, this is a physical problem. The problem with the infrastructure has one representation manually constructed by linguists in this case. They are very good giving definitions. So they explore a lot of resources and they manually construct this definition, okay? Which is supposed to be the shared knowledge that citizens have about this problem, okay? Problem schema. Okay, so this is the brief introduction about the context. This is the project I'm working at. Okay, so now I return to the case study, which is institutional elder abuse. And what is institutional elder abuse? It is a specific problem type. Where? At the bottom of the ontology. Okay, perfect. Social or physical? Social, no? Problems with, how do you define this? The abuse of older people in institutions. And this is located at the population. So this is a problem type. This is located at the population domain, which in turn can be found in the living dimension, and it is a social problem. Okay? Perfect. And we constructed a problem schema, a formal representation of this meaning. Okay. So as you can see, these formal representations have got two primary components. You have concepts and logical operators. Syntactically speaking, it's very simple. But the two main components are concepts and logical operators. Logical operators allow us to relate concepts in some different ways, okay? So concepts are language independent. Why? Because they are word-net synsets. So the concept is not the word, the concept is the number. So I have just introduced some words in English to make this more readable for you, to facilitate readability. But these words in English play no role at all in the community problem detection. The most important thing is the word-net synset, the number, and the logical operators. Okay? Perfect. So, if I dissect, how was this constructed? Well, you've got the linguists exploring different resources, and they, after a definition in natural language, they dissect it. And here you can see that the main concepts were selected from the primary semantic components of the definition of the problem. So you've got a problem, this is the what. You've got who performed the problem, the who, the where, and the to whom. And with these components, you are constructing step by step this problem schema. Okay, so now, first step, the research question, where I am applying the methodology. So we want to create a synthetic corpus for the problem type institutional elder abuse. Why? Because I want to help recognize Spanish tests which instantiate this specific problem type. This problem type, not this topic. Okay? If it is about a topic, but there's no problem being described, we are not interested in this. We're interested in problems, in community problems. Domain description. So linguists, in this case, explore different kinds of knowledge sources to explore different types of elder abuse. What kind of knowledge sources? They explore from textbooks to technical reports where community problems are described from a more global perspective, to academic research articles or other scholarly literature where specific aspects of these problems are identified, okay? So exploring different knowledge sources, they identify what typology of elder abuse problems you have. As I said before, you have financial, domestic, blah, 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 and there's one which is institutional elder abuse. Okay, so this is the domain description, and you've got the domain boundaries here. Domain boundaries, we aim to simulate user-generated content posted on social media. I am applying the linguistic methodology, and I am adapting it for a synthetic corpora construction with large language models. Sampling design, sampling unit, the text of the post, and now the most important thing, the sampling method. A stratification. Well, so we want to create a stratified corpus based on certain categories. Which categories or strata? These are the categories or strata. One is language, text length, a speech function, a style, tone, and a speech figure. Okay? This is the way that linguists would work, isn't it? So for language, you've got English. We work with English and Spanish. For text length, well, we've got here 5 values. Why these 5 values? Because we previously compiled English and Spanish corpora containing natural tweets, I mean real tweets, natural tweets about community problems, and we examined the text lengths, and we made this kind of distinction, okay, statistically speaking. Okay, then we have a speech function, style, tone, speech figure, no problem. Well, just one thing, it's very interesting, the difference between criticism and complaint. Why? Because in the scientific literature about claims that citizens make about problems, usually these claims take 2 forms: criticisms and complaints. Okay, let's do it correctly. Let's try to make the machine make this difference if it's possible. I mean, do you understand? Okay, so complaints. I mean, well, criticism. I mean, the difference is that in criticism, the speaker expresses displeasure or annoyance, okay, as a reaction to a particular situation or action, because this situation or action negatively affects the speaker. In complaints, well, complaints put more attention, focus on what is wrong rather than on the speaker. Okay, there's a slight difference, but there's a difference that we didn't decide, that it was taken from scientific literature. Okay, so in short, what is our initial premise? Our initial premise is that if generative models can benefit for corpus certification, because there are semantic and pragmatic constraints that we think can produce more realistic tests. This is our hypothesis, our initial premise. Okay? Perfect. So, well, in this case study in particular, because this is the methodology for the project, but in this case study, in order to have more manageable corpora, we reduced just to Spanish, not to English. And in text length, we took just moderate length. But the other ones were all values were taken in order to have more manageable corpora, because we had to create many different synthetic corpora to compare. Okay, perfect. So this is a different layout of the constraints. Proportionality, well, there's proportionality with all the values. The number of votes were equally distributed. Let's do it correctly, okay? And randomness. But how random? Okay, and here we had a problem. I mean, randomness, because we can control randomness when creating synthetic corpora in 2 different ways. One is through the hyperparameter tuning of large language models, as you know. And these are the typical parameters. I mean, tweaking these settings, you can control randomness. The last 2, as you know, are parameters related to the sampling technique. So here, the higher the value, the more diverse and creative the output. Okay, we are searching randomness. Why? Because this contributes to lexical diversity. It is supposed that if this lexical diversity is related to the domain, to the targeted domain, everything is going to be better, isn't it? This is the idea. Okay, but there's a different way of controlling randomness, and it is through the prompt itself in this case. Why? Because every time that we introduced a problem type, for example, institutional LR review, we've got to give some definition through the prompt. Okay, this definition is automatically obtained from the ontology. But the question is, what type of information do you provide for each problem type in particular? For example, for institutional LR reviews in the prompt. So we provided 2 pieces of information. One was a very brief definition. For example, in this case, the very brief definition is the abuse of older people in institutions. Just that. Very brief. Because giving the name of the problem type as it is used in the ontology is not meaningful. It is just to describe the name, but in a few words. And we used a set of keywords. A set of meaningful keywords describing this problem or describing different aspects of this problem. This is what we call the lexical contest. I'm going to put more emphasis just a bit later. So we give a very brief definition and some keywords. In this case, 3 keywords, just 3 keywords, okay, to describe specific aspects. But every time that we use a prompt, the set of 3 keywords was different. because we've got thousands and thousands and thousands of lexical contexts that are derived from the problem schema. I'm going to tell you how is it possible. Okay, perfect. So as we are changing the set of keywords, we are randomizing the output, because every time that you change one word, you have a different output. So you are contributing to randomness. Yeah, but we, and this was a discussion that we had, we did not insert a phrase in the prompt such as, the following keywords must be included in the post. Why? Because you are generating lexically biased output. The question is, no, these words describe the problem. Now create one. There's a big difference. I mean, you are giving more randomness, not with this option, but with the other one. And we chose the other one, okay? So we gave freedom to the machine to generate it. We didn't lexically constrain the output in this case. Okay, perfect. And corpus size, how many? The more the big, okay, the more the better. No. I mean, we generate the number of texts depending on the strata, depending on the values, depending on proportionality, randomness, etc. So remember, these are the strata. So we've got language in this case is just Spanish. So no option, Spanish. This is a fixed value. Name one. We work just with one problem type, fixed value. Institutional elder abuse. We have restricted text length, but I'm talking about this experiment in particular, but not in our project. Okay? We have restricted just to moderate length. So this, and this have got only one value. Perfect. What happens? We can insert different sets of keywords. This is the lexical context. So how many texts do you generate for one lexical context? You generate, if it is proportional, you generate 2 by 4. So, sorry, it is here. 2 by 4 by 3 by 3. Okay, all the pragmatic ones. By 1 for one lexical context. How many lexical contexts do we use in this experiment? Just 10. So that's the reason why these corpora are going to have 720 texts. Exactly. Okay. We can use more. In our project, they can be, okay, 500,000 tests, because we can generate, okay, from one problem schema, I'm going to tell you how and exactly the number, but from one problem schema, the institutional elder abuse problem schema, the formal representation, you can generate more than 5,000 lexical contexts. So multiply this, 72, by 5,000, and you've got the number. Okay? Perfect. So it's not the more, the better. It is exactly how to make it proportional, how to make it constraint-based, how to make it from the linguistic guidelines. Okay? Perfect. Well, this is the way in which lexical contexts, the sets of keywords, are constructed. So you've got some concepts in the problem schema, and it is a conceptual expansion from WordNet and other linguistic resources. We use paradigmatically related concepts from WordNet mainly, but other linguistic resources. And then we apply data augmentation techniques such as swapping the concepts, because if you change the order of the concept, the output is different. So we apply data augmentation, and then we have a lexical projection. Well, here in this paper, you have a very detailed description of this process, how to construct different sets of keywords from only one problem schema. In particular, we constructed 5,787 lexical contexts in Spanish. In English or in other language, the number is different, okay? Derived from the problem schema. We chose these ones in particular. So we were choosing these sets of keywords. These sets of keywords were introduced in the prompt. Why these ones? They were randomly chosen from this number. Randomly chosen. The people who performed, I performed this experiment, but the people who performed the evaluation data set chose some words. And I randomly chose these words. They could match or not. This was not my problem, okay? So it was not chosen because the words in the evaluation data set are the same. But it doesn't matter. If the words were the same, having the same words, it does not mean that the tweets, the natural tweets, describe a problem. The natural tweet can present a topic, but not a problem. Having exactly the same words And this is a challenge. That's the reason why I am presenting only one. Because the question is, problem, yes or no? It is as simple as that. Okay, let's construct it. So we experimented with 4 large language models, these two ones, Microsoft Orca and Nose Hermes. These are the best ones indeed. Orca is much better because of the results that we have just obtained in these experiments and other experiments. Okay, these language models are instruction-based models constructed from the foundation model Llama 2. This is the large language model. And from this one, they were constructed, these ones, as fine-tuned models. Okay, now look at the parameters. 7 billion and 13 billion. So if we use the taxonomy, this taxonomy can be obtained from this paper, of classification of language models according to the number of parameters. These two are medium-sized, and these two are large, but not very large, indeed. Comparatively, if you think about ChatGPT, GPT 3.5 has been trained with 175 billion, and GPT-4 with 1.8 trillion. This is very small. Okay, but this is the challenge. I mean, but it's not, the challenge is because we have a need to use these kinds of models, which are more cost effective for productive environments. This is the reason why we do it in this way. Okay, they can be downloaded. They are open source. They can be downloaded from Hugging Face. And we constructed one synthetic corpora for each one for each language model. Okay, and from the prompt engineering perspective, we constructed a template. This is a fill-in-the-blank template where blanks can be programmatically filled in with the values from the strata. Okay, so here we replace automatically by the values that we presented in the strata, in the categories. Okay, perfect. We adopted more challenges. We adopted zero shot, not few shot. It would have been better, few shot, isn't it? No, zero shot. But I'm going to tell you why. There's a motivation for everything. Okay, so zero shot because, well, as you know, zero shot, you're fine-tuning the language model only with a direct specification of the task. This is zero shot. Alternatively, we've got few shot. Few shot could have probably generated more lexical diversity in the corpora, probably. And even the results, the performance could have been better. Probably, we all agree with this. But we chose zero shot because it makes the models more adaptable to new problem types. You do not have to give examples with new problem types that you do not know which problem types you can find in the future. Do you see the point? I mean, I'm not searching the best performance. I'm searching the best setting to deploy my application. Okay, for a company or for, okay. So what happens when you've got new problem types? You've got to search examples to illustrate this, but what happens if we do not have examples? Because this is a different story. It's very difficult to find natural examples about this. It's very specific. So the option was zero shot, not thinking in performance, thinking about, okay, a reasonable deployment of the application. Okay, perfect. So this is the templates, and here you can see an instantiation, one of the possible instantiations of the template. So this is the same, but instantiated with some values. So for example, the placeholders in green means that for this experiment, there's only one value. Oh, okay, why? Only one value for text length, only one value for the problem, and only one value for the language. And the other ones have got many different values, okay? We evaluated, perfect. We use, well, lexical diversity measures to evaluate different aspects using frequency, cosine-based distances, graph structure, blah, 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 blah. This is very good, but for linguistic exploration. But what is the purpose of this? And you've got some numbers, you've got some numbers, you've got some numbers. But the external evaluation, we're interested in the external evaluation. How well does it work? I mean, we evaluated with a corpus of 160 natural authentic tests, 78 positive, 82 negative, quite balanced. Describing problems, not the topic. Problems, positive, problem, negative, not problem. With the same words, a combination of 3 words. One from here, one from here, one from here. I did not participate in creating this. Why? I didn't want to influence the evaluation data set. Other people did it for me. Okay. And we classify, okay. So we used we employed community problem detection as a task of text classification, where we employed, in this case, we employed a self-organizing map. Okay? This is a procedure. So, as you know, a self-organizing map is typically a 2-dimensional single-layer neural network. So here you reduce the dimensionality, but you are preserving the topological structure of the data. So we can use similarities. That's the reason I chose this one. Can you have better classifiers? Of course. But I chose this one because I wanted to concentrate, to focus on how similarity were the embeddings. The ones produced synthetically from the corpus, and the one from the tweet, okay? Yeah, just 1 minute, 2 minutes, yeah, promise. Okay, and these are the results. I'm going to make some comments about the results, okay? So we use threshold precision, recall F1. Okay, I'm going to give some comments about this. We have one corpus just with a speech function, another corpus just with a speech function and a style. We combine. We try to combine all of them, some of them, okay? Perfect. Okay, results. I'm going to put more tables with results, but I'm going directly to go to the interpretation. Okay, when you have only the speech function, this is worse than when you combine the strata. So stratification works. However, only speech function and a speech function with another constraint are better if you combine all of them. The problem is why? Very interesting. Because the strata are underrepresented. This is a problem of proportionality. It's not a problem of the corpus size. It's a problem of proportionality. And this is also supported by the following fact. Okay, what we did here is we combined all the previous corpora together. So we put this one, and this one, okay? So we are increasing. Okay, now we are trying to see the factor of corpus size. What happens here is very curious, and the trend is the same for other problem types, not just for this one. The larger the corpus, with the same constraints, the larger, the better. Perfect. But if you are increasing the corpus, okay, you are making the corpus bigger, bigger, and bigger, and bigger, but you are not controlling proportionality, then the performance decreases. So proportionality in a strata is as important as corpus size in this case. Okay, and the Gaussian, when we use the Gaussian kernel as a similarity measure, and it is always the same. So higher than this value means that there's a problem. Lower than this value, there's not problem. Okay, and so this is more or less the conclusion, and I finish. The performance improvement, okay, so to have performance improvement, well, stratify the corpus and increase the corpus size, but preserving proportionality with a higher number of lexical context. This is the key word. You can make your corpus bigger, bigger, and bigger, but not disregarding proportionality in the categories, but changing or increasing lexical diversity using different sets of keywords. This is the key point. And of course, stratify the corpus because results are much better. Well, some conclusions, but I think that this is the same and we are short of time. Okay, thank you very much.
Okay, thank you, Carlos. Thank you. Is there any question, any comment?
Thank you for your presentation. How interesting to build automatically corpus. I have two questions. First one is, you produce the keywords for the prompt automatically from the ontology, is it right? But the ontology is in English. How do you solve it? It's in English because it comes from WordNet, isn't it?
Well,
if I understood you, you produce the words, the keywords of the context from your ontology, and your ontology is built based on WordNet, which is in English. No, so my question is, how do you translate it? What? My first question, my second question, if you want, I do is, do you test the quality of the Spanish produced by the model that you chose? Because we work also in building corpus in Spanish, and not all the models work produce Spanish, I mean, with the same quality. So how do you control it, or is it doesn't? It is not important for you.
Yeah. Well, this is let's start with the first question. Well, the first question. Well, we employed the ontology. By definition, an ontology is language independent.
Yeah.
It's not a lexical taxonomy. This is a different world. The ontology engineers get very angry when they say that an ontology is a lexical taxonomy. No, this is a different world. An ontology is conceptual. You've got categories, and they are language independent. You can map the categories to lexical words. That's a different issue. Okay, so in this case, well, forget about the English words. This is a WordNet 3.0 synsets. And we've got mappings to other different languages. I mean, for WordNet 3.5, you've got mappings to French, German, Spanish, Italian, and it's free. Okay, I think that the team in Galicia, okay, they created this mapping. And of course, we've got the possibility to insert more words to the synset manually in an application that we have in case that some words are not well represented, okay? But this is not English synsets. These are just WordNet 3.0 synsets for English. That's true. But you've got mappings to lexical units in Spanish, English, and they're very good. I mean, I'm talking about 300,000 words. It's not just a few words. But also, we also have the possibility to insert new words, okay? Because it's a bit obsolete. I mean, life is changing, and okay. So I think that's clear. Okay, and the next question, yeah, this is the linguistic exploration. The linguistic exploration. Well, this is very interesting, but it's not part of what we are doing because our work is, this is a text mining data set, and we've got a text mining system, and we've got this task. So this is something complementary, okay, that we can do as linguists. I'm not so interested. I mean, I'm more interested in the text mining part, but this is just to analyze, yeah, are these texts as coherent, fluent, and so on, than the ones created by GPT-3 or 5 or 4? The answer is no. I mean, they are understandable, they are quite well. Sometimes they've got some problems of morphology or syntax, but they are reasonably good. At the end, what you're searching is the embedding, not the text. We work with embedding, and embedding is reasonably good, although you could have some mistakes in grammar. So for us, this is not an issue for us as text miners. Of course, this is something interesting to explore from a linguistic point of view. But this is to improve the large language model. We do not want to improve it. Other people are going to improve it. It's not our work. So it's just to focus the end. Yeah, but of course, I mean, the sentences are reasonably good, surprisingly. This is just very tiny in number of billions, and it is easily understood. It is curious because in Spanish is Latin American Spanish.
Yeah.
You've got Mexican.
True.
Some words are in Mexican, not in okay. Carajo.
Yeah.
Okay, you say, okay, it doesn't matter because you've got root language. Carajo. Chingada, no sé qué yo. Okay, this is not Spanish. Spanish from Peninsula, you know, the country. Okay, but it doesn't matter because the embedding translate this as a slang language, and the embedding is right, where it is important for us. Yeah, but it is very important. Okay, it's very interesting for other types of works to explore linguistically the kind of output. Thank you for the question.
Any other question? No? Okay, thank you again, Carlos. Thank you very much. So let's move now to the second thematic block.
Yes, right, okay. Where is it? Right. And where is it?
So our first presenter is Serge Sharoff from University of Leeds, and the title of his presentation is NLP, the era of large language models, stochastic parrots in a black box. Thank you.
Right. Okay, so what I'm going to talk about today is essentially, so then I have three arguments I want to present, right? So then thesis one is that large language models are very capable, right? Thesis two is that they come with lots of problems, right? And we can detect those problems. And the synthesis of thesis one and thesis two is that researchers in linguistics are the best actually to find out how to get the best out of what they're capable of and how to find out where the problems are, right? So, and I will start with thesis one about how powerful language models are. So let's go. So then what I tried, I asked ChatGPT to write an amendment to the American Constitution on a frivolous topic, right? And the topic is of socks disappearing in washing machines, right? And from this you can see that it is quite capable of knowing about the genre, because it starts quite predictably with the people of the United States in order to, etc. And then it links this more high-level words which are related to the topic of socks disappearing in the washing machine, such as to ensure domestic tranquility, and no individual shall be deprived of their socks without due process of law, right? And then the genre here is well preserved, right? So the other example is, so out of vanity, so what I wanted, I asked ChatGPT to what it knew about myself, right? And the result is surprising because, so on the one hand, so then by looking at the text, so what you don't know is where I was born, where I studied, where I got my PhD from, and where I worked, right? So probably you can guess that the years are not exactly right. Okay, but then the other thing is that whether I worked at Sheffield, Leeds, or Edinburgh, and so it's a bit unclear. So the second thing is that, okay, this is the second paragraph, and this is surprisingly good, right? So then if you think about ChatGPT, so it contains hundreds of millions of parameters, hundreds of billions of parameters, but at the same time, it also read, in order to arrive at the parameters, it read billions of texts, right? And then somehow in the hundreds of billions of parameters, it managed to get the actually very coherent story about what actually I was doing, right? So in that sense, that's actually fantastic. Then the other is just lots of praise. So then it is, again, so probably you know that ChatGPT likes lavishing praise at people, right? And then the next statement is actually why I wanted to show it to you, is that I died in 2018, right? And then again, so then if you read all of this, then without knowing me presenting to you, you would have actually trusted it, right? And then, so then the question is to what extent we can trust. And then again, everyone knows about hallucinations, but my specific point here is about the genre, right? So it looks like, so for whatever reason, when I asked it about me, then it decided to go into the genre of obituaries. Because this is a very, very perfect obituary, and then it's actually very heartening to be able to read your own obituary as coming from a tool. And then it is an unreliable narrator. So then in literary studies, there is the concept of some novels are written from the viewpoint of unreliable narrator, and by reading the novel, you can understand that the narrator actually lies to you, right? And in this respect, so that if you know something about me, then you can be able to detect where it lies and where it gets things right. But then from the viewpoint of getting the genre right, so in both cases, in American Constitution genre and in this genre, it just gets it right. Okay, so this is all good and in a sense positive, with the exception of me dying 6 years ago. But then the thing is that, so then how good they are, and this is the counter argument I like making, and I'm not the first. So Emily Bender, she created this metaphor of a stochastic parrot, right? And then when we look at how good language models are, we essentially look at how good our own language is. Right? So so what they did, they consumed lots of examples, and obviously when we look at the mirror, so essentially ChatGPT, it provides us with a mirror of our language, but without true understanding of what are the purposes of why we use language and for which purposes, right? And essentially, so then the rest of my talk is the synthesis. Right, and the synthesis of the two theses, that we are quite good in understanding of what language is used for, and therefore we can deploy ChatGPT in order to serve so not necessarily ChatGPT, large language models in general, and more specifically, I mostly work with medium-sized language models because computationally they are much more tractable. Right. So so then one of the tasks I like is the task of stylometric analysis and analysis of genres. Right. So in this task we work with essentially with lots and lots of texts. And in my work, what I want to emphasize is the same thing which Michael Halliday claimed for his functional grammar. You need to say sensible and useful things about any text, right? And if you look at any text, so then available from the web, then one of the problems is that you have lots and lots of texts. And also you have genre hybridism, in the sense that you have a text, and then it looks like this is partly this genre and partly the other genre. Right, and this creates problems. So then one of the solutions for this, so from what I can see, is what I have been, then talking about genres, so then again, you can recognize these are the kind of genres I see every day in my life, and then there are many more genres when you if you have a slice from common crawl, for example, then to understand what is there, you need many more labels. And in the typical German fashion, even before the common crawl, before Wikipedia, before anything else, there were, for example, this is a study from Germany, a PhD study of Kirsten Adamczyk, in which she worked essentially with the typology of 6,500 genres. Right? That's a little bit too much. So what I sort of advocate is the importance of functional dimensions. So instead of working with genres, you look at functional dimensions. So you have a text, and to what extent does this text provide an informative report of recent events? You have the prototype, and then this text somehow fits. So 99% of texts, they don't provide informative report of recent events, but some of them do provide. Then probably again, so probably I'm exaggerating actually, I will be giving the precise numbers later, but then some of the texts don't provide, don't try to persuade the reader, right? Some texts do, and then also some texts do both, right? And then we have seen many examples of texts of this kind, and you can probably design a fairly reasonable system for annotation of those texts, and this will be more. So so the result of annotation will lead to a greater inter-annotator agreement. Right? Okay, and then then the model I typically use XLM Roberta, and if you have a number of texts, and if you have, so then in this case, a number of functional dimensions, then for each and every text in your training set, you can estimate, you can use this model to estimate the function of each of those texts. And then the overall score is reasonable if you use XLM Roberta, and therefore you can try applying this to the rest of the web, right? And the next slide is essentially provides an answer to the question posed by Carlos in his previous talk, whether the more is the better, right? So what I did, so you have corpora, which have been used for training the individual language models. So BERT, for example, was trained on Wikipedia. So not ChatGPT, GPT-2. So then they published the whole procedure for training GPT-2, and they used the Open Web corpus. And it is a bit different from the corpus which was used for training Roberta, because Roberta was trained on Common Crawl. Right, so then this is a random crawl of a number of pages from the web, and they published the procedure for selecting those texts, and they had so then this created a corpus. And in GPT-2 specifically, they used a slightly different approach in the sense they went for the more popular texts. So, and for selecting more popular texts, what they did, they took the entirety of Reddit, right? But instead of using Reddit, because this is a very specific genre, right? So then they took links to web pages with a large number of votes in favor of those papers, right? And this essentially shows the popularity of text on the web, and this provides a different corpus, right? And then now the question is, what is there? And if you have a tool like what I presented before, so the tool for predicting the function of each text, right? Then you can have a picture in about what is prevalent in each individual corpus used for fine-tuning large language models. So in the case of BERT, it's quite simple because essentially this is a way of validating how good my XLM Roberta model is for detection of functional text, because it was trained on Wikipedia, and Wikipedia is the definition of texts aimed at reference information, right? And so then the majority of texts from Wikipedia are there. But then what is interesting is that there is a big difference between GPT-2, the corpus used for training GPT-2, in terms of the genres or the styles of texts used there, and the texts used for training XLM Roberta. And the other thing is that there is also a big difference between the two kinds of XLM Robertas, because in XLM Roberta you have the English portion, and you have lots of data from other languages. And then in this case, because again I know that my tool works best for Russian, I applied this for Russian, and then you can see that there is quite a substantial difference between what you obtain, right? So then this gives you an answer. So then one of the answers about how different large language models are, so then how, so that at least what is the difference in the training corpora used in those large language models. The other answer you can also have is to what extent the classifiers I built, to what extent these classifiers are actually reliable, right? And so then back 15 years ago, I published a study in which, so then I was also doing genre classification, but at that time it was using support vector machines and extraction of keywords. And then what we found there, and we tried also doing some kind of explainable AI with SVM, which was easier, right? And then we found out that, for example, our detection of FAQs is biased by the word hurricane and other meteorological phenomena, because there was just a spike in the number of training texts in the FAQ section about hurricanes, right? And so then and this created this unexpected bias. So in a sense, what I wanted to do in that study, I wanted to replicate the same study but on a much bigger data set, and also with the so then with modern large language models, okay, medium-sized language models. And for this task, so what you can do, you can collect very large samples from websites in which you have which are topically homogeneous, right? So for example, in the hyperpartisan corpus, there are only examples of argumentations, right? So then various kinds of expressions of opinions, and on Stack Exchange you have instructions, right? And then you can apply. So on the one hand, these are the sources, right? And and then if you go to Amazon reviews, then you only get obviously texts aimed at reviews. But then you can also do topic modeling, and you can split those corpora into the topical parts, right? And then you can see that the topics don't match on the one hand. The most popular topics, they don't match. But then for each individual genre, you can find sufficient number of texts for training the model in order to build the genre classifier, which is specifically, so what we did, we essentially enhanced, so emphasized the bias of each of the classifiers, right? And then after that, so then once you take your training corpus out of texts which are only on a specific topic, then you show them examples of texts from different topics, right? And this is the difference between the on-topic classification accuracy and off-topic classification accuracy, right? And it is very clear to see that most of the time there is a very, very significant drop. I mean that it is not a drop in terms of several percents of F1 score, but then it is on in the range of something like 20%, right? So then these models are very, very easily biased if you provide them data on a specific topic, right? Okay, so. But then, in order to detect this, you need to know, so then essentially what kind of text you want to classify them for. The other thing which I also want to do, right? Okay, so I will try be quick. So then, essentially, so in the previous examples, so essentially you apply a large language model, and then you get the composition of a large corpus. But then, if you apply the large language model in order to make predictions about the genre, for example, of the text, you are limited, so that then essentially you will get good results, but you don't know what actually is coming from those results. And in order to solve this question, so what essentially I tried taking lexicogrammatical categories from Douglas Biber, for example, and then trying, so that once you have the predictions of the large language model, then you can on the basis of those predictions, you can train a logistic regression model. And then this model so essentially represents the reasons why the large language model, they makes its own predictions. And in the interest of time, so I sort of skip this bit, so then I will talk more about the smoking gun coming from here, right? So essentially, what we have here, we have the task of predicting a difficulty of a text, right? So then some texts are easier, some texts are difficult, and you can again train a language. So you can train two language models. So you can train two models. One model is to predict the difficulty of the text, and the other one is to predict the genre of the text, right? And then if you train two different models, so if you focus on instructional texts in detecting the genre difficulty, so that if you focus on the instructional text to detect the difficulty, and you train the news text to detect the difficulty, then you will find out that there is a difference. And one of the important things here is that, for example, the second person pronouns, they contribute to the difficulty of the text, right? So then the use of second person pronouns is the most significant factor why XLM Roberta thinks that that news texts are difficult, and at the same time the second personal pronouns are the most important factor why the model for classifying the instructional text for difficulty thinks that they are easier, right? And this comes just from the contribution of how the texts are composed. So for example, in news texts, most of the time the second person pronouns, they are used in quotes from other people, right? And therefore they are a little bit more difficult to understand. They represent opinions in comparison to the to straightforward news reporting, and therefore they create this difficulty. So essentially, this is the last thing. So what is the place of us with respect to large language models? So I like the presentation by Ken Church. Ken Church, 15 years ago, gave this talk in which, so he referred to the famous statement by Fred Jelinek: whenever I fire a linguist, the performance of my speech recognition system goes up, right? But then Ken Church argued that it doesn't matter. You don't need to build better speech recognition system. Just buy more data, increase the amount of data in your training set, and then you will improve quality. So, and then it's actually obvious that I was trying using hand-engineered features for years, and then large language models, they actually essentially wipe me out, because they produce much better results, because they know much more than what we can engineer. But then the thing is that if we engineer the right features, we know that these features are right? And we know that the model either makes the predictions for the right reasons or for the wrong reasons. And this is, again, back to the presentation by Anna this morning, the importance of linguistics for training computational linguists, right? So that then if we train them right, then they will be able to understand what is the reason why the language models they behave in this way. So essentially, this is the main statement, and then most of the resources are available, and so feel free to experiment. Okay, thank you.
Thank you very much, Serge. Is there any question? Any comment?
Hi, thank you, Serge. It's a very interesting one. Within your group, do you have like AI people that help you implement? Because I see you're using Hugging Face and a few of the helpful repositories in implementing those experiments.
In a sense, so that in this respect, I think that if you train, so then very much like what Andrei presented this morning, that a substantial number of, so then very much like what Andrei presented this morning, a substantial number of people in digital humanities can get sufficient skills in at least in training a Hugging Face model. So then take XLM Roberta, take your training set, so then learn how to use Python, and then essentially for this you need probably 20 lines of Python in order to do this training. and then you can deploy the model, and then in 5 lines of Python you can start applying this model and producing reasonably good results. So in this respect, this is the other thing, that large language models and technologies of this kind, they are a great source of democratization. So you are a linguist, you know something about language, and then you do need to learn how to do a little bit in Python, but then again, 20 lines of Python is enough to train a model, and then another five lines to deploy the model, right? So, and then to interpret this, you definitely need the linguistic skills, and then this is, in a sense, something which is more difficult to arrive at, and this is something which requires more skills. So actually, so all of my PhD students, this is a requirement. So then if they come from a software background, they need to learn something about language, and if they come from the arts and humanities background, they need to learn how to deploy models in Python. So this is for the PhD students. For MA students, the picture is a bit different, but then in our case, at least at Leeds, there is the self-selection process, because we are well known, probably we're the best translation studies department in the country in terms of language technology. And the reason why the students come to us, because they want to know more about language technology. Even so then taking this bias, we still probably have about 10% or 15% of students who actually don't want to do language technology in spite of coming to Leeds, and then they can find other ways of being useful in this framework. But then this is what we emphasize: learn how to use Python, and then it takes much less than learning how to speak Chinese.
Okay. Thank you.
Yep.
Okay, thank you. So let's move to the second presentation. Sorry. So our second presenter is Antonio Moreno Sandoval from Universidad Autónoma de Madrid, and the title of his presentation is AI Generation Results Enriched with Simplified Explanations Based on Linguistic Features. Gressel. Thank you.
Hey, okay. We are very tired, so I will be very, very brief. Okay, so you can ask me for the PPTs or whatever. Okay. I want to show you today why you cannot rely on chatbot and generative. So I'm going to provide some examples that not only the one with you, that is very terrible, but also with me. So you will be that you cannot rely on that. And I agree with you that the linguist is the most capable to find problems with the ChatGPT and the generative artificial intelligence. Okay, I'm going to present a new project. We will start soon, but we are all the environment to start. And the idea is to use this technology, retrieval augmented generation, to improve the quality of the answers that generated by an artificial intelligence model. And we apply to 3 domains: financial domain, especially reporting, also in fiction, and in digital humanities. Okay, so that's the how we want to test this technique. What is the motivation of this project? Well, we wanted to integrate question answering, which is a chatbot idea, and also the information retrieval, okay? Because we detected a lot of fake information that you cannot trust, and we can avoid that, okay? We want to move to this technology. We want to ensure the contextual relevance, and also, for me it's very important because I am a scientist, the factual accuracy. For me, is the only important. Data are more important than theories for me. I don't know you, but for me, it's more important data than theories. So factual accuracy is the most important motivation of this approach, or this experiment. And also, we want to avoid system hallucinations, okay? Like Don Quixote. If you train your system with novels, and you only read novels, you have hallucinations, right? So for me, this metaphor is very, very similar to what we will get with the ChatGPT and other programs. This is an joint project by 2 universities in Madrid, Autonomous University and UNED. And also we have a collaboration from private institute, research institute, knowledge engineering institute, and also from people from UCREL, Lancaster, Paul Ryson, and Mo Hatz, and also Ignatius Esani. Okay? We start from the results on a previous project we call Clara NLP, which is basically a project based or with the goal is to produce automatic simplification and plain language in different domains. We test this in financial reports, in newspapers, and also in medical reports. And the main conclusion we extract from this project, 3 years project, is that lexical and syntactic simplification can be achieved reasonably, okay? But some relevant information was not reflected when you produce a summary. And especially in financial reports, because omitted information is one of the things we discover when we analyze things. We use several classifiers trying to find, when you provide a test, if this is a report of winner or losers companies. And sometimes some communicators, some writers can cheat to the machine learning system and then provide the complete different. So humans can cheat to the artificial intelligence for sure. So there are some clever writers that can do that. So that's a good point about humans. And this omitted information is not easy to detect. It's not easy. Because you can say, today, this year, we have most selling stocks, but you can omit that you have losses in other places. So this omitted information is really relevant, especially in financial reports. So that was what our hypothesis is: use this retrieval augmented generation-based question answering system to query hidden information, because we have financial experts that know how to ask questions to the reports and say, put your questions, and then we will try and go and find this in the reports. So we already exhausted the lexical analysis. I mean, keywords, so we can get very, very exhausted things, noun, verbs, adjectives, discourse markers. And we wanted to go to the discourse structure, because where you can find these omitted fragments. So if you just concentrate in syntactic or lexical features, probably you don't got this, because this is a problem of the context, of the fragment of the discourse, right? And it's especially important in to look for argumentative patterns like cause and effect and counter-argumentation. So we move to the discourse, not to stay in the lexical or even the syntactic analysis. And this is, for instance, the structure of the letter of the stakeholders, which is a typical document in every Spanish report, and have more or less this structure. The geo assessment, the content data, and here there are some things that are more interesting than the others if you want to see the classification. For instance, accounting data on result discussions. Acknowledgement is not a big deal, right? So we can focus in some part of the document, and we can put the questions in that part of the document. Okay? And what about the argumentative patterns? For instance, counter-argumentation is essential to justify underperformance. But we did bad. But in this case, this year we have this blah, 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 blah. So the counter-argumentation features are really important. And also cause and effect. Because cause and effect pattern is, and we are running some shared tags, fin causal, it's something in English and Spanish, if someone of you wanted to participate. We have some competition in this, cause and effect. Because it's important to understand which is the cause of a certain event. And there are also a lot of manipulation, but you can choose your point of view. So sometimes you can say, this provoked that, and also you can say that provoked this. So we discover that in the argumentation, you can find some subjectivity. They are just reading. They are looking at the test and the results, right? And, well, I wanted also this feature from the financial reporting, but also from fiction. And I want to show you the unreliability of chatbot based on large models. They integrate information without checking its factuality. And I want to show you something, 2 examples in the Don Quixote. And the important thing is they don't search or extract information from primary sources, but from everywhere. So you can find very funny things. I, with 2 people, wrote the dictionary of the El Quijote, which is around 9,000 lemmas and around 20,000 word forms. I check it out, everyone, so I know the lexicon, okay? And thanks to this, I know what the musical instruments are in the Don Quixote. And you go to the, I don't know if you know, the chatbot arena, leaderboard, and you can ask what are the musical instruments in Don Quixote. And that's a lot of fun, because appear things that they are not in the dictionary. So you can easily check it out, that's fake, right? You need to have a dictionary. But if you have the dictionary, you can check it out that. And also, the next example is that it's Antonio Moreno. That's my surname. And Antonio Moreno is like Tony Brown, so that's why I use Sandoval, okay? And, well, there is Antonio Moreno in the second part of Don Quixote. He's a businessman in the second part in Barcelona. And he played with Don Quixote with the talking head. There's a talking head, so trying to confuse Don Quixote, poor Don Quixote. And I asked, who is Antonio Moreno? So you cannot read it here, but that is completely, in one of the chatbot said that Antonio Moreno is a priest, not a businessman. And they're all confused where they appear in the first part of the... No way. So completely confused, completely. Okay. So can you imagine a student talking about an assignment in the classroom? Can you give me information about whatever character in this novel, in Crime and Punishment, for instance? Who is Raskolnikov? Okay. And of course, you can use some search tool to control the words. Here you can see the name Antonio Moreno, so you can see all the paragraphs that will appear. So these are signs. You have to go to the data and to check it out. So this is a good example to tell to students, say, don't trust what you get from ChatGPT. Confused completely, okay? And now moving to question answering. I like the idea, I like question answering. I like ChatGPT. I mean, not ChatGPT, chatbot. And well, why don't do our own question answer system to put questions to the documents? So there are two main approaches to the question answering. The first one is, everybody wants to know, extractive question answerings. The idea is to get directly the answer from the test. I mean, there are all kinds of information extraction. I worked with Ralph Grisman in the previous Mark IV conferences. So what you have to extract is actually the test you are asking for, right? And the other one is the generative or abstractive question answering. Then you can, it's more sophisticated. I like it. It's more sophisticated because doesn't just copy the test, but generates an answer to your question. But can be true or can be not true, right? So why can't we do that? Our approach is the following. In order to be flexible and reliable, we wanted to do abstracted questions, allow for semantic interpretation of the questions, and to get similar vectors. But in order to get reliable results, you have to be extractive. Structured answer. Take from the document and show me. No invented who is this character or whatever. Okay? So abstracted question, but extractive answer. Allowing factual verification. Remember, this is my main point. Factual verification. I'm a scientist. So that's why we go to this retrieval advanced generation, because you can get it with this. So RAG is a combination of natural language generation with information retrieval, which is like, you know, a question answer system, right? But the good point, or the important point, is that improve the quality of the answer generated by the large models. Why? Because, this is the key point, the test, the information is stored in a system database. So the questions are through the database, not through the world. So you have to get the information directly from the test, from the database, right? And of course, you can use a pre-trained system just to do the question answer system, but focus to the test. Okay, so this is more or less the schema. You have to produce. You have the user query. You have to write down queries. Who is Antonio Moreno, or how many different instruments, musical instrument or whatever are in the Don Quixote. You have to write down user queries. These queries are producing an embedding model, and also you have to get the corpus, the test, to do a embedding. Okay. Then these two models, do vectors, go to the database, and then you use the pre-trained model to do the questions to the database. So that's that you get you constrain your corpus, your test, and you focus on that. Okay? We are planning to do this with a lot of novels in Spanish, just to figure out that, and then to apply that using these spatial humanities that are developing in Lancaster to also geolocalizations the themes and the personal, the characters, and also the places. So then you can provide to the user a reliable question answering system, right? Well, here's this summary, very fast. Chatbots based on large model are causing a revolution in the way that the information is accessed because of the natural way of expressing both question and answer. We like that. But the answers are very unreliable in some places because no one can guarantee how they are going to be chosen. Can we imagine someone writing in internet about instruments in El Don Quixote, playing an electric guitar, and then you get electric guitar in the answer, right? Why not? It's in the large model, right? And I think these retrieval augmented generation systems or techniques can provide. We have to explore that, and maybe after we finish the project, we decide that there is not a solution, but this is a way to explore and find things here, right? And that's it. 10 minutes, right? Thank you.
Thank you very much, Antonio. Okay, we have time for 1 or 2 questions.
So, only one. We are hungry. Okay.
In which languages are you going to? I'm sorry. In which languages are you going?
Yes,
to,
in Spanish.
To work? Spanish?
Yes, but in Spanish, but you can do in Yoruba if you want it. If you have, this is not a problem. I mean, it's just to do the word embedding, and then prepare the system, and that's it. You need to have a computer scientist who can run and train models, and you have to have the linguist that prepare the questions, and more or less it seems to be quite possible, and that's easy.
And are you going to use or do you choose? Maybe you don't think yet about it, but any database management system in particular, or?
Yes, we know what. I mean, we are playing with that. The important thing is we will use one. We have to play with Hugging Face, find one of the question answerings that we really like it, and then to put it in the database is not a real big issue. I mean, what you have to really try is what is the best pre-trained model that can do question answering for Spanish, maybe not the same for English, but you have to adapt it, okay? And probably with some multilingual model. We play with MT5 and other things that you need to have a encoder and decoder. So just to play with that. And as someone said this morning, every week or every month there are new models. So it depends on your system capability. But fortunately, you don't need a lot of GPU. I mean, it's with 24 gigabytes, this is enough. So I don't think this is the way that the people in labs we can work, because Google and the other companies don't care about Don Quixote, don't care, and don't care about anything about that. And they have that, so you can play with that, and you can provide users useful tools to the user freely. So we get the Hugging Face model for free, and we provide this for free. We are university researchers, so okay.
Hiya. Musical instruments in Don Quixote. Do you know that can you be certain that the dictionary is correct?
Yeah, the good point is you have the dictionary and you have idea of instruments or whatever instrument you wanted. You can check it out. And of course, what you can check it out is the existence of the word in your novel or not. That's very important, but you can use it. Even with a plain word form, you can get it that. So you can restrict the consultation and you can check it out if there is a exact extraction from the text or not. I don't know. Understand your question.
That's good. I also I wasn't quite clear when you said that there were no primary sources.
Okay, primary sources, of course, yeah, of course. The question with the actual language model that you have primary sources and also secondary sources.
Oh, okay.
So they are mixture. My example, if I can write a post or a blog saying that the Don Quixote play an electric guitar, they can be incorporated in the answer because they cannot distinguish primary and secondary or whatever embedded. Yeah. So that's why I say. But if you put in the database, there is no way other that you can decide that this is not part of the document we wanted to ask. So it's having a question answering system, but focalized in your test, and also with the advantages of the semantic questioning. This is one of the things I really like it most from the new tools or new models that you can do paraphrase, and that is really good. But it's in paraphrase in the question, not in the answer. Thanks. That's the idea.
Just a very quick comment to the multilingual thing. We have experimented with some embedding models, and I have to say that, for example, Czech is, you won't get very good results with REG unless you use some of the large models like GPT. With the local ones and open ones, it's really quite terrible, I have to say. So even those that are supposed to be multilingual are not doing very well. Right. So I would be careful about that.
Yeah, I must say that we have a Spanish language model produced by the Engineering Institute. So we also have this advantage. So we remove all the foreign words. So yeah, we have not this multilingual. That's true. Multilingual is mainly English, and then 2% of Spanish or whatever. Okay. Go for lunch?
Okay, yes. So, lunch break. We'll be here again around 2:30, hopefully. Right? So, see you later.
Good afternoon. The first speaker on the afternoon session is Tony Russell Rose, and he's going to give a talk entitled Computational Sociolinguistics Through the Lens of Social Media. So, whenever you're ready.
Great, thank you. How's that? I can press buttons and talk at the same time. So I'm told. Right, so yeah, welcome everybody. I hope you had a good lunch. I hope it wasn't too good. That makes me the second act. Anyway, so yeah, so thank you for inviting me, and also thank you to Raquel, who I think has momentarily left. I did debate actually whether to give a talk on. We've recently launched a program on computational linguistics as well, a one-year master's course, although 2 years part-time as well, which has brought its own challenges, but it's only we're only 12 months down the road with ours. In fact, not even that. So in the end, I decided that we'd talk about something related in the sense that it's a collaboration between my colleagues in computing and English and creative writing. But I'm not going to be talking about our new program today, although maybe that might be an interesting talk for another day. So this is what I'm going to be talking about. It's a very small project, but I think there's some interesting value in there. It's small in the sense that it was done very quickly. It was done very rapidly, and it was done out of a seed funding collaboration that arose partly as a result of that same collaboration that we had with putting the master's program together, and it's between myself and some colleagues in English, and we also hired a postdoc as well to work on this. So the background to it is that I had a long-standing interest in, you know, obviously climate change and the energy crisis is something that touches all our lives, you know, in home and in the workplace. And this is something I think we'd all been tangentially interested in for quite a while, and we were sort of toying with the idea of could we apply computational methods to this. Anyway, long story short, we thought we would put together a proposal to look into this in a little bit more detail, looking into essentially published sources and also social media sources, looking at the debate around energy crisis and the cost of living crisis, to try and see how the various actors were framed, and to try and understand the sentiments and to try and understand the arguments a little bit on both sides, with a view ultimately to try and find some sort of consensus, although that obviously is quite an elusive goal. But that's where we wanted to start from, is to build some sort of reusable pipeline so as we could make a little bit of an impression on this huge problem, and also build something repeatable that we could potentially apply to other areas of you know, political interest and topical debate. So I won't talk too much about that. The main bit I'm going to talk about today is that WP3. There was a previous stage and a final stage, but I think the interesting bit really is the NLP bit. That is what I'm going to be talking about today, part 3. I've done the reveal already. Here is the pipeline. We built a huge pipeline, which I'm not going to try and read every word on this slide, which basically underpins everything that I'm going to be talking about. Don't try and read it all. I will call out various bits as we go along, but just suffice it to say that there's various bits to this that were required in order to produce an output in its own right, and also required in order for a subsequent part in the pipeline to do its work effectively. So I'm going to pick out a few little bits in this pipeline and talk about them, and then talk a little bit about the results and what that might mean. And I think that's probably enough to fill 20 minutes or 21 minutes. So what we did, we started off with acquiring our data. There's a little bit of a backstory. We started off with Twitter, and pretty much the week after we started downloading Twitter, Twitter said, game over to us, and that were kind of, I thought, okay, fair enough, we'll pivot, we'll try something else. But we always knew we were going to look at mainstream media as well, so it meant that we would focus pretty much all our efforts on mainstream media and park the social media for now. Anyway, we were fortunate in having does this thing, oh it does, a corporate account with LexisNexis, which, as many of you know, is a big database of all sorts of published literature, mainly around mainstream media, but other stuff as well, and legal stuff as well. And we downloaded a corpus of documents around this topic, and we looked at the timeline and tried to find where the peak was as well, to find the most interesting surge, where that became more of a topical issue. And that gave us this corpus that you see here, which we cleaned using various geotags and various other metadata to make sure that it was as representative as possible. And then we moved on to that second bit in the pipeline, which is about trying to find relevant articles from this corpus, which actually turned out to be a little bit more tricky than we thought. Manual inspection showed that there were many false positives. Perhaps as many as a third, I seem to remember. So what we did was we thought, well, we'll need to apply a second level of analysis on top of this to extract the relevant articles out of our initial corpus. So what we needed to do at that point was then hand annotate what we call a gold standard validation set, and then run various retrieval algorithms against that and do a little bit of hyperparameter optimization and choose the best. I was initially of the view, I think there's just some stats on the validation set there, that you can see that there's a significant proportion of irrelevant documents just from in the validation set. So I was of the view, I told our postdoc, just use, just use word embedding, or even just try TF-IDF, BM25, all these things, tried and tested, don't bother doing anything new. And she said, no, I think I'm onto something. So she started doing this snowballing thing, using the subject tags, to find an initial set that were relevant, and then kind of snowballing from that. And I kept saying, no, don't, you're wasting your time. Well, she was right, I was wrong. It actually turned out that her algorithm did better than the sort of classic, vanilla approaches of TF-IDF, and even better than word embedding. Oh, I'm not totally convinced about word embedding, because there's a ton of hyperparameters you can optimize there. And I'm not sure in 2 weeks, which I think is as much time as we had for this bit, we did that. But anyway, the output of it was that her metadata-based algorithm performed the best, which was a nice, unexpected, but positive outcome. So that brings us back to our pipelines. So we're kind of up to here. We've got our ranking algorithm and our optimal parameters. And then we applied that to get our relevant articles. So the next thing we needed to do, obviously you could do a bag of words approach at this point, but you'll lose all the phrases. A lot of these issues and topics and actors are multi-word units. So we need to be mindful of retaining the structure of these, and just sort of blunt engrams probably isn't going to work. So we looked through a few different tools, and we came up with one that actually did a reasonably good job of this, called Autophrase. Some of you may have used it or come across it. Has a number of parameters that you can tweak, and does a pretty good job of extracting unigrams to 6 grams and applying quality thresholds. So that was our tool of choice for doing the phrase extraction. Then, if you remember on the pipeline, the next step was to doing the topic extraction. And we looked at various methods here. We looked at straight latent Dirichlet allocation and various hierarchical methods. But it turned out that the hierarchy actually didn't really add much value, and it didn't work for our particular corpus and our particular data set. So we ended up just going for the fairly sort of, in English we call it the vanilla approach. I don't know if that translates into across cultures, but anyway. It's interesting to know what the Spanish equivalent of that is. But anyway, it's kind of the default approach. There you go. That's something that translates across cultures. Yeah, so we did the default approach, and we evaluated it using one of the many coherence metrics. I forget exactly which one now. And we ran it over several different epochs with different parameter settings, and came out, and this is what we came out with as the optimal number of topics. And guess what? We used ChatGPT to generate topic labels, and actually did a very good job. Much more so than, I guess, one of us trying to hand annotate that. So that was how we did the topic modeling. And when you apply it to the sources, as I remember, one thing I skipped when I showed you that table very early on. When we moved to looking at broadcast media, we wanted to get a tractable size corpus, but one that represented both left-leaning and right-leaning sources, and also represented what we call in the UK broadsheets and tabloids. And broadly speaking, that means broadsheets are kind of the big papers that have the heavy in-depth analysis, the sort of grown-up papers, and the tabloids are the little ones that kind of give you the celebrity gossip. And it's just a different take on what's happening in the world. So we wanted to have both of those, left and right, and also broadsheets and tabloids, which is why we had the choice of the Mirror, the Mail, the Guardian, and the Times for big UK newspapers. So you probably can't read that, but for what it's worth, these are the topics that came out for both the Mirror and the Guardian. And then the next thing, going around in our pipeline, was, so we got our topics, we got our phrases, we wanted now to identify who's who in all this, who is doing what, which I'll come to in just a second, but who's who first. And what are people saying about them? Is it positive and or negative? So we used Spacey to do the named entity recognition, which gave us what we call our actors, the players in this debate. And we used News Sentiment, which again is another third-party library, to do the sentiment analysis. And then we used the bit of the who's doing what was the bit, most of what I've talked about so far has been fairly mainstream, but the bit that's a little bit more exotic or unusual is the semantic role labeling, which, you know, in my experience at least, is a little bit more rare. And we struggled a bit to find suitable tools for this, and we certainly didn't want to build our own, but we found in the end something called Allen NLP, which had a semantic role labeling library and did a reasonably good job of that. And that produced output a little bit like this, where you can see here the agents. So this is for the topic energy bills and price caps coming out of the Daily Mail. So you can see here, using the semantic role labeling, we identified these agents here, and these are the verbs associated with them. So this is kind of the who's doing what. So you can see the government needs to take action, et cetera, put steps into place. Households are struggling to save, and they're switching providers, facing bills, et cetera, et cetera. So you can see that this is reasonably intuitively plausible at this point, which is you know, quite promising. Then was the really tricky bit, which is trying to identify an issue, because we wanted the actors, the topics, and the sentiment. And as I said, most of those are fairly sort of mainstream, but what is an issue? You know, and without being too sort of philosophical about this, and we did actually go off on some strange brainstorms at some point, trying to decide what an issue was. But in the end, actually, we kind of took a pragmatic view, which was that an issue could be identified as, it had to be something that is quite popular, so high frequency. So it has to be something that attracts a lot of attention. It has to be something that attracts a lot of sentiment, so people are strongly motivated to articulate opinions about it, and it has to be polarizing. So it has to attract both positive and negative sentiments. So those were our kind of heuristics as to what could at least identify an initial candidate issue set. So we started using our topic labels, and then we worked our way down the top n-grams for each topic. And that produced things like this. So for a topic of economy and inflation concerns, you can see the issues associated with it are the cost of living, financial crisis, living standards, rising prices. And you can see down this list again here that for each of these topics, these issues are reasonably plausible. You know, you can imagine talking about these sort of things in the pub, as you do, and arguing about them. So, I mean, I know there's probably a few false negatives in here, so, but not bad anyway, for a start, for a very short piece of work. So that's what we took as our issues, and then finally what we wanted to do was visualize all this stuff so that an end user, who was probably not going to be one of us, could consume it in some way, either a journalist or a political commentator, or just an end user, you know, with a sort of dashboard of what's happening in the world today. Although ours is historical. All our data is historical. We did and still do have visions of doing this on a kind of daily basis, like a zeitgeist. Does that word make sense? You know, topical of what's happening in the world right now, sort of with real-time updates, or daily updates anyway. So the next stage was to look at conceptual graphs, like this kind of thing here. So you could explore the relationships between the four major categories that we were extracting: the topics, the issues, the entities, and the sentiment. We'd already got our actors through Spacey and the semantic role labeling. And now we wanted PyViz, which was the library that we used, to give us, well, there's several different types of graphs, but the most useful ones were these four here: the topics and issues per source, topics and entities per source overlaid with role and sentiment, sources and issues across all sources overlaid with popularity and sentiment, and issues and entities of all sources overlaid with popularity, role, and sentiment. We almost ran out of colours, trying to colour code all this. Sentiment was the obvious red, green, blue. I think it was neutral, grey was nothing. Then we wanted to know the role. Is somebody an agent or a recipient? So we arbitrarily chose black and yellow for that, or purple if they were both, or blue if they played no role. And then we got to, back to the pipeline again. So I think we should just refresh our memories, really, that we've kind of got to this point here where we're wanting to do. We've gone all the way around here, now we're doing the visualization. So that leads us to the kind of final bit, which I'm going to do real quick, is looking at the output, really. And this is the bit where I suppose we just ran out of time, partly, in a five or 6 month project. So this is still a work in progress, really, is thinking about what have we learned so far from this, and how can we build on it with bigger and broader data sets. Anyway, this is the first of those four graphs, which shows the issues across all four sources. And you can see here, so you've got Guardian, Times, Mirror, and Mail, and these are the issues that they're sharing in the middle. You can see cost of living, Prime Minister. Oh, you can move all these things interactively. So obviously this is just a GIF or a JPEG, so it's obvious there's a lot of occlusion going on, but you can zoom in and zoom out with the actual tool itself. So you can see here these issues. So you can see which issues are shared by the four sources, and which issues here, which tend to be about personal finance and consumer-related stuff, in the Mirror, and these are more like global macroeconomic signals and indicators here, which is the focus of the Guardian. You can see the popularity represented by the thickness of the arc, and the popularity of the issues themselves represented by the size of the bubble. So if we zoom in on one of those, which is the cost of living, we can now see the actors associated with it. So you can see here the four sources. This is just cost of living issue. And you see the actors in the middle. Again, there's a lot of occlusion going on, which you can move around with the real tool. But you can see there's government, Boris Johnson, Rishi Sunak, and various other characters that were important about 18 months ago. Not that they're not important now if you're of that persuasion. Well, you never know. You'll find out on July the 4th, I guess. Anyway, so you can see here that, here are the issues that are shared in the middle. Now, an interesting thing is, if this is the cost of living issue, if we go forward to the cost of living crisis issue, which is also identified automatically, by this process, we get a slightly different picture. The Times drops out completely, and the Mail almost drops out as well. And of course, one hypothesis here is that framing this as a crisis suits the left-leaning papers more than it does the right-leaning papers. So that might explain why we see that the Times have just vanished from here and the Mail barely registers at all. Then we have things like this, where we move to an issue that is more emotive and about individual lived experience. This is the hard-pressed issue, and we see the actors associated with it here. And again, you can see different sentiment associated with them, like almost saying who is to blame for this, according to the different sources, and again, different sentiments associated with that, and different sizes of arcs and different sizes of bubbles. So British Gas seems to be a pretty large culprit for this hard-pressed issue. So finally, just the last couple. We've got the energy security issue here, which, again, I suppose what's interesting about this one is that this is a kind of global macroeconomic thing, and the Mirror has dropped out. The Mirror doesn't even appear on this, which kind of indicates, I suppose, that they have less to say about energy security, connected with a red line on one side and a green on the other, indicating that difference of opinion. And you can see also who are the major actors associated with this particular issue. So that's kind of it for the analysis. I think where we go next with this is thinking a little bit about, you know, is it possible to do some sort of objective evaluation of it? You know, there's not really any ground truth data for this, and there's a sense in which what we're doing is looking at Rorschach ink blots, if people know what that is, and seeing what we expect to see, and that's a really dangerous, I think, lens or bias to bring to the analysis. So it would be better if we can introduce some sort of triangulation with some sort of objective, but I'm not sure that objective data really exists. It'd be interesting to see if people have solved this problem in some other way. So yeah, we're interested in trying to triangulate and fill in the gaps. So that's still work to be done, but the outcomes are we'll at least build something, I think, a methodology and tooling that arguably is reusable. So we can build on this and use it to look at other areas and optimize it as well. So it's a very, very short project. So I kind of said that a little bit earlier. From a methodology point of view, I think the pipeline is totally reusable. So I'd like to see it applied to social media data, if not Twitter, then something else. And also applying it, scaling it horizontally. You know, we talked about scaling it temporally from historical data to live data. That would be one interesting route. But another one might be scaling it horizontally to other topical debates around the, around the use of cars or, any of the duties of state, inequality. I mean, there's stacks of issues we could look at. Yeah. So I think that's it. Yeah. We probably want to do a little bit more work on the tool itself, so that at the moment, as I said, the JPEGs don't really do justice to the interaction, but the interaction isn't as rich as we would like. We'd like to be able to filter each of those images based on things like popularity or sentiment. Show me all the negative actors. Show me all the highly popular positive actors. Or focus on specific verbs or categories or entity types of verb frames, and then to be able to pivot between those graphs as well, rather than having to switch between them. Yeah, so I think that's it. Yeah, I hope you found that interesting, and I'll take any questions. Yeah.
Yeah, we have time for a couple of questions.
Yep.
Right. Okay. Thank you very much. That's all interesting, and I think that I like this kind of data visualization, which I would like also to apply to data from our own project at some point. So the question is about the end users. So have you tried evaluating this with the end users? So then I can imagine journalists or politicians, and to what extent they find any of the correlations interesting to them, unusual, unreasonable.
So it's a great question. The quick answer is no, but the longer answer is the quick answer is no, but the longer answer is we definitely should. So I think it's almost like a call to action to us. Yeah, I mean, we even have a journalism department in the university, and mea culpa, we haven't even shown it. Actually, I think we showed it to them once, and they said, that's really nice. And then I'm not sure, I think we all got distracted by a whole bunch of other things that were happening. But you're quite right, we should re-engage, and probably re-engage more broadly as well with outside stakeholders. So, I mean, if you're more than welcome, this is all open source, this is all on GitHub. So if you want to try and use it to visualize your data, more than welcome, and we'd be happy to help and collaborate.
Because the project we had, it was on anti-vaccine sentiment, and then again, so then looking at the actors, and then so then we have done other kinds of studies, but that this angle might be quite interesting.
Great. Yeah, happy to hear more. Yeah. Is there any more questions?
Thank you. It's not a question, it's just a kind of follow-on from that. We've had we've had sort of similar problems to this, where we've wanted stakeholders to then engage with the data and the outcomes, and we just find that most people cannot interpret data visualizations and that kind of data. So what we have to do is use all of that as a tool ourselves, and then write up the findings as a series of bullet points or something like that to then pass on to the stakeholders, but asking them to engage and interpret potentially complex and ambiguous data visualizations. They just don't do.
What's possible is what ChatGPT to summarize data. Yes. Because we have seen examples of how well ChatGPT can summarize data points, and then so that it was a Carlos good example. When ChatGPT was sort of, I'm trying to remember who mentioned it, but definitely there is probably.
Hey, I get ChatGPT to write my graduation speeches for the students and parents. It's amazing. But
Okay, that was very interesting. So I've gone for a couple of grants very similar to yourself, and most of them want to know about what your impact is going to look like. So did you need to do this? Because I know from your question just now, how did you propose your original impact? Because getting research grants, it's in this space is really tricky at the same time. However, it's very topical, like you say. So can you maybe give us a little bit of insight on that?
Hang on. I'm going to give you what is a pretty rubbish answer, I'm afraid, because this was just seed funding. So it was a very short, there's a little bit on it, it's on one of the other slides. It was a very short project and it was internally funded. So the section that we had to complete on impact was pretty short. Okay. So we just talked about engagement with external. There's a slide, I must have skipped through it pretty quickly, but there is a slide that talks about engagement with external stakeholders. Yeah.
But if it
that's
was
probably about it.
If it wasn't a seed funding and it was say for EPRSC or the likes of that, do you have any ideas how you would have done impact?
I mean, I know it's one of those things that they always pick up on, and I would say off the top of my head, obviously engagement is a crucial part of that, but I think it's partly about having them on board right from the start, partly about having them ideally as a partner, I think, as an evaluation partner through the process. Also about having advisory boards with the representation on them and co-design sessions. That's the sort of stuff I would put in. I don't think there's a silver bullet really to filling those bits in really. Again, interested to hear if anybody else has got the perfect answer to that question, because I don't think I have.
I think that's probably a great suggestion, because I went for seed funding similar to you for and then obviously changed for and included all what you've just suggested. So I think that's about right.
Okay.
But yeah, stakeholder engagement is key, because research goals and research impact is becoming a lot more trickier.
Yeah, and in a way, I think it's the right time to be asking that question, because I said we paused this because the project finished and we all got distracted with other things. But having now revisited it, I think, after 6 months after the project ended, it's the right time, I think, to kind of reflect and say, let's now productionize this. Let's go to the next level. We've done the proof of concept. Let's put it on a more robust footing, build in those interaction features, and start engaging at least internally with the journalists, because they should be a tame audience, and then externally as well. So,
okay. Thank you.
Yeah. Is that it? Okay, thank you. All right, no problem. Thank you.
So the next speaker is David Sanchez. Of the University of the Balearic Islands.
Javier, where should I get my file? Because le mandé el mensaje, le mandé el... No veo por aquí a Raquel, ¿no? ¿Cómo se lo mandé por email?
Estamos en su sesión.
¿Cómo, perdona?
Que eso está en la sesión de Raquel.
Ah, no, yo se lo he preguntado. Should I? Okay, so thank you, Javier, for the invitation and for organizing this interesting workshop. So the title of my talk is Computational Sociolinguistics through the lens of social media. So we also use Twitter data. And the objective here is to try to get meaningful information out of this data, okay, in terms of spatial patterns, or if you're interested, for instance, in linguistic geography, or in temporal patterns, if you're interested in diachronics or language change. So of course we need this data. We always asking this data to be representative observations of reality. But there is also another reason why this why data can be useful, is that they can serve as an essential guide to build models, to build theoretical models, to deepen our understanding of sociolinguistic questions. So here, as you know, we have kind of two different approaches to collect data. We have the traditional approach, which produces corpora of very good quality, but very limited in size. And then we have more modern sources, which have this big data corpora or massive data, which let's say they are not so good in terms of linguistic quality, but I mean they are so big that that actually any fluctuations, let's say, are smoothed out by the large size of your sample. Okay, and one of these examples is Twitter. Okay, so until roughly last year, one would be able to ask the Twitter API to download tweets, and this is what we have done in our institute since roughly 10 years ago. And but here the only, let's say, condition that we ask the API is that we just want geotagged tweets. Okay, so we only want tweets with geographical location information. So this is just the typical structure that you get from the API. So you have the text of the tweet, so you have the user ID, and then you have some additional metadata, right? Like the date, the place, and some other extra information. So basically, the information that we are going to analyze is the text, okay? Because we're going to, let's say, investigate language variation, and also the location, okay, which is contained in those fields over here. Okay, so as you can imagine, then we have to do some pre-processing before analyzing the data. So we typically remove URLs, user name, user mentions, and also hashtags. It doesn't mean that this information is not interesting, right? I mean, actually, hashtags are, there have been many papers, very good analysis of Twitter hashtags, how they propagate and so on. Is that for the purposes of our investigation, this is, let's say, information that are not useful. And then, since we want all our analysis to be as automatic as possible, we implement also, we employ the compact language detector to automatically filter the language of the tweets. Okay. And also, as I said, another important ingredient of our analysis is the geographical location. Okay, because we're interested in spatial patterns, right? And this can be seen in the data in several ways. Like, so if we are, let's say, very lucky, we obtain GPS coordinates, but only a tiny fraction of these tweets give you the exact GPS coordinates. Okay. Alternatively, you can obtain the country, some generic administrative unity, which can be a province, a region, something like this. the city, and also in many occasions a place of interest, okay, like a restaurant, museum, something like this. This is data from more than 10 years ago, okay, for following, this is a different team, but they follow a similar approach, and so they had a corpus of geolocalized tweets. So they counted the number of users that employed a given language, okay? Here you have English, Spanish, Indonesian, Malay, etc., plotted against this ranking of languages. So you can see that even at that time, which is, let's say, even the prehistory, you have many users, especially for English in Twitter. So this means that, in principle, this is a good tool if you want to do sociolinguistic research, okay? You have many individuals speaking, let's say, in a register that otherwise would be very difficult to analyze, right? Because in a traditional corpus, you have this interviewer bias, okay, and people try to speak better than they do normally in real life, okay? And this is like everyday language, okay? So this is spontaneous language with conversational style, and it's kind of unique in this sense, okay? Of course, then one has to make a more or less precise user selection. Not all tweets do, right? I mean, you have to. There are some thresholds, okay, that I summarize here. I'm not going into all those details, but we always distinguish whether the user is a resident in this cell, is not an occasional traveler or tourist, okay? That the user must tweet a certain number of times with a certain number of tokens, okay, or with a minimum number of tokens, and so on. So this is kind of carefully set in this let's say model selection. But of course, we are not free from biases, okay, as have been let's say investigated in detail. There are some biases in or say important biases in any Twitter corpus, like it's mostly let's say employed in developed countries, in urban areas, by young educated people with high income, more males than females. Okay, so I mean, these of course biases exist, they're there, and we should take also those into account. There have been many works using or trying to, let's say, improve our knowledge of sociolinguistics using Twitter. I just put here a list. Sorry if maybe some of you don't see the your paper here. This is just a summary. It's just like a demonstration that this is let's say an interesting area of research, and people have investigated English dialectology, Arabic, Spanish, French, like this paper here, mostly mapping lexical variation, but also syntactic variation, as I will explain now. So let me then, this is like a general framework, okay? So let me now explain a couple of examples from our group. So the first work is has to do with trying to infer American cultural regions from a Twitter database. And of course, this is a very difficult problem because, first of all, what is a cultural region? Or what is a cultural identity? Okay, there's many factors around the cultural identity. Okay, I mean, gender, age, religion, sexual orientation. There are many. So I mean, even if an individual has like let's say multiple factors around cultural identity, now is it legitimate to speak about like a cultural region in which everyone has more or less similar cultural characteristics? This is one question. Even if the question cannot be solved, mapping these cultural differences is useful, okay, for political reasons, also for demographic reasons, okay. Especially geographers are very much interested in see if there are more or less homogeneous regions within a country in which people share similar cultural practices. Okay. Of course, now how do you select these features? So you put more weight to the religion or to the gender, or what do you do? Well, this has motivated people to propose, for instance, to the US, which is our case of study, several cultural regions. Okay. Of course, these are very subjective. Depends very much on whether the researcher prefers, as I said, some feature or some other feature, right? So what we want to do in this work is actually that those cultural regions should emerge from the data. It's not something that the researcher, let's say, in a subjective way, proposes with more or less accurately, right? And the hypothesis that we make is that, of course, there are many factors that contribute to the cultural identity of someone. However, all these factors are somehow transmitted through the language. Okay, it's not the only means. Okay, so you have also cultural transmission through music, through art, through traditions. Okay, but however, we assume that language is largely a primary means of cultural transmission. Okay, so these cultural similarities, if they exist, they should be reflected in what people speak, the preferred topics. Okay, this is the hypothesis of our work. So what we do now is just counting. Okay, so we count. So we have this, as I said, this geotagged corpus of tweets. Okay, and so we can count the relative frequency of word W in county C. Okay, so we divide the US in 3,000, I don't know exactly how many counties. Okay, so we know the frequencies of all words in these counties. And then here in the left, for instance, this is the raw frequency for the word bruh, okay, which is like an African American variant. Okay, you can see that this word is mostly employed in the South, also in California, but there is a lot of noise in the data. Okay, so one way to improve this visualization is by borrowing a metric from geographers, which is this Getty's Ord autocorrelation metric, okay, which is kind of z-score, okay. So you count how many times you deviate from the mean, okay, and then you weight this with these spatial weights, which is one for the nearest neighbors of each county. Okay, so you put weights to places which are near to your county. Okay, and now you obtain maps which are much more smoother. Okay, and but still keep this information, right? That the word bruh is mostly employed in the south of the U.S. because it's taken from an African American variety. Okay. Now we have a big matrix. Okay, with this metric, this GeoStar that I mentioned before, in all the counties. Okay, so now we can do standard PCA. Okay, and these are the results for the phosphor components. Okay, in the first component is basically determined by the north-south distinction. Okay, so it's just let's say the African American English basically, and the rest. Okay, the second dimension has to do with distinction between rural and urban speeches. Okay, the third division is about Midwest, Texas, and the rest of the U.S. And the fourth division is roughly between the West and the East. So it's nice that even, I mean, you start with a data in a very high dimension, okay, and when you reduce, the principal dimensions are interpretable, okay? So you can assign let's say, linguistic meaning to all the different components, okay? Next, we want to infer these cultural regions. So we just cluster together counties using just standard hierarchical clustering. So here we are not inventing anything new, okay? And this is what we find from, let's say, we find that the more or less optimal, but this is of course subject to interpretation, number of clusters is 5, okay? So from the dendrogram, it is clear that there is, first of all, a split between the south and the, except for Florida, and the north of the US, and then you have further splitting of the north with the Midwest, the West, etc. Okay. Now this is fine, but of course, from the linguistic point of view, you would like to know what are the characteristic words that characterizes those regions. Okay, because this is, let's say, something that that emerges from the data, but this should be reflected in the words. So which topics people prefer to speak about in all these different clusters, okay? And to do so, we define the specificity of a word, okay? By just calculating how close your word is from the center of each cluster, okay? It's like a distance. That's why this is 1 minus g star square, okay? Try to minimize this distance. So the words with this highest specificity are the words which are characteristic for each of these clusters. Okay, so cluster number 1, the south of the US, is basically characterized by African American variant forms, as we know. Okay, by fashion and music vocabulary. Okay, the Midwest speakers are mostly interested in sports. Okay, and also teenage school life. Okay, due to the number of colleges and universities and so on. Cluster number 3 is about nature, basically. Okay, there is a lot of rural population, okay, in the west and also in the northeast. Okay, there are some metaphysical or more religious conversations or vocabulary associated to this cluster. Cluster number 4 is essentially urban. Okay, so you have slang, violence, politics, and so on, especially the west and the east coast. Okay, and the 5th cluster is Texas, which has, as you know, a strong identity. Okay, and they like to speak about themselves, basically. Okay, so it's nice that all of this is reflected in our corpus. Okay, another interesting thing is that let's say a cultural region doesn't have to be homogeneous. Okay, like especially homogeneous, like here. Okay, so there are people connected. Let's say they have people from Los Angeles and New York. They have more, let's say, in common than with people from their own state, like California or New York. Okay, and this is something that, I mean, you don't have to be restricted to spatial homogeneity. Okay. So this is the conclusions from this first work, and now I would like to emphasize that this method is applicable worldwide. Okay, we just chose the United States of America because we have plenty of data for that. Okay, and also we have English and very little, let's say, interferences from other languages. And for the second work, how much time do we have, Javier?
Another 5 minutes.
Okay, yeah, 5 minutes. I will quickly summarize this work in which we're interested in analyzing the difference between standard and non-standard varieties, in this case English, which you know, okay, this is very introductory linguistics. You know that following Leibov's terminology between over and cover prestige, we have this standard or let's say variety which follows some norms which are, let's say, empowered by government, education, and so on. But there is a cover prestige, which is which appears in group identity, solidarity. Okay, like in this Pink Floyd line, we don't need no education. We have this double negation, which is not a standard, but still they like to use it. But this is not something new. I mean, even Dante himself in the Convivio, he argues that he doesn't write in Latin, even at that time Latin was the prestigious language. He prefers to write in vernacular, just because it's his mother tongue. So, and he loves his mother tongue. It's nothing else but that. So there is a cover prestige in this Dante's statement. Okay. So now we have these two varieties, standard and non-standard. And so in this work, we try to see what is the influence of the socioeconomic classes in the usage of these two variables. So of course, this is a very old subject. Okay, it goes back to the 60s or 70s, in which, I mean, sociolinguists, they found out that, of course, that the rich speak different than the poor. Okay, I mean, we all agree on that. Okay. But now we want to analyze this in more detail using Twitter corpus. Okay, we focus on 4 metropolitan areas in UK, in England and Wales, because here language is more heterogeneous in these cities, and also because we have economic data about these cities. Okay, from the census. Okay, and the way we distinguish between following the norm or not following the norm is also automatic, okay, by using this language tool, which is basically a spell checker, okay. So and this tells us if the user made a mistake, so he or she didn't follow the standard, okay, by agreement error or here he going instead of he's going, okay. We focus on grammar. Okay, actually, this tool can tell you if the mistake is a typo or is a different way. So we're following grammar because I think with grammar defines much better this distinction between standard and non-standard varieties. Okay, so this is the 8 cities that we analyze. Okay, in this color match for the number of tweets, only for those people who we consider to be residents in those cities. And this is the income, net annual income, okay? And basically what we do is that we want to correlate this map with the map of the grammar mistakes. This is what I want to do, okay? So these are the first results, okay? So here we have in the vertical axis the average frequency of grammar mistakes, okay? And in the horizontal axis, here we have the average net annual income in each of the cells that the UK census gives us. Okay, and then this is the global results for England and Wales. Okay, and we obtain a negative correlation. So it means that the rich favor standard forms, and the poor prefer non-standard forms. Okay, it's something that was more or less expected, and this trend is observed in all the 8 cities. Okay. The difference is that this pattern, let's say, is stronger in cities like Bristol than in cities than Sheffield. And why? Why? If in Sheffield and Bristol, they have basically, or they have similar, let's say, socioeconomical status or socioeconomic classes. So why in Sheffield, let's say, there is no connection, there is no correlation between the standard language and the socioeconomic class, and in Bristol, it seems that this is the case. Okay? So then what we did was to analyze the mobility pattern in those cities. Okay? Since we have the tweets and the tweets are geolocalized, we can know where people are tweeting, okay? And since we know their home and their work, so they know if they're tweeting from one place to the other one, so if they're visiting different places of the city, so we have all this information. And what we observe is that these mobility patterns change very much. Okay? In London, for instance, people do not mix very much. So let's say that the poor want to visit poor areas and the rich prefer to visit rich areas. So the more diagonal this matrix is, the more segregated is the city. While in places like in Sheffield, this is the poor area, apparently everybody's happy in those areas, and they want to visit this area. So in places that in Sheffield, I don't know if you are you from Sheffield? Okay.
There's nowhere to go in Sheffield. That's why everyone stays at home.
Okay. Well, this is what we find from the data. I don't know. This, I mean, maybe it's just. I mean, I'm not a city geographer. Maybe there is a campus over here, or maybe the city is I mean, if the city is segregated, it's maybe because you have a boundary, like a river, or I don't know. I don't know exactly the reasons for that, okay? But actually, there is a different mobility patterns, okay? And then we can quantify how much diagonal this matrix is by just calculating a correlation coefficient, okay? And this correlation coefficient differ from the different cities, okay? So this is the main result. If we now plot the correlation, the Pearson correlation associated to the usage of standard language, let's say that depends or not on the socioeconomical status. And here we plot the other Pearson correlation coefficient, which is related to the mobility. We obtain a straight line with R of the order of basically -1. There is a perfect correlation. Okay, so what this result is telling us is that mobility patterns and mixing affects very much how people speak. So it's not only how rich or how poor you are, but how much you mix with the rest of your neighborhoods. Okay. Okay, I don't have time to go into the model, but then we were able to propose a model in terms of fraction of speakers and also parameters that quantify these over and cover prestiges. Okay, but I don't go into the detail. It's just that both the simulations and the observation from Twitter seem to agree. Okay, and so then the main conclusion is this one, right? That the correlation increases, the correlation between speaking, the standard or non-standard, and the socioeconomical class increases with decreasing mixing of these economical classes. Of course, there are a number of open questions. Okay, here we only took into account one standard. Okay, what happens? I mean, you could have different standards. What is the role of immigrants, of different communities? Is this real world, or this is only something that we observe in Twitter? Okay, so there is still, let's say, room for research. And thank you for your attention.
Okay, we have time for just one question. Mike.
Okay. Yeah, I think I might know what the explanation is. And so your data looks at mobility, but it's mobility within the city. Because one of the things that occurred. Ah, okay, yeah.
So it's mobility between economic classes. So what we did was to, since we know the income of each cell, okay, so we divide this income, let's say, so we discretize this in 5 bins here, okay? And so here is, let's say, people with economical class 1 visits economical class 1.
Okay.
So regardless of the place in the city.
Yeah, it just sort of occurred to me that I mean, obviously they're all university cities. Bristol tends to, I think I'd be right in saying that Bristol tends to attract students who are from the wealthier end, and they tend to come from London, whereas Sheffield doesn't. So although Sheffield has a lot of educated people who end up settling in the university, and they in the city, they actually come from a sort of a different background from across the UK. So you don't tend to get such a split between the wealthy and the not so wealthy within that city. Whereas I think Bristol has quite a marked. If you were to spend time in Bristol, you would notice the division that you see there, I think. He's from Leeds. Oh no, you're Birmingham, aren't you? Yeah, you might have a different view.
Yeah, I think in one of those cities, I'm not familiar with, as I said, with familiar with all the geography of those cities. But if I remember in one of those cities, I don't know, it was Sheffield, the other one, the campus was in a poor neighborhood, and of course, I mean, the campus was in a poor neighborhood, on a neighborhood with a low income. I don't know exactly which one, and so that was maybe why just people from all around the city were, let's say, moving to this campus, or I don't know, but because, I mean, in many occasions the campus is outside the city, but in one of these the campus was in the center.
In Sheffield it's sort of in the centre of the city.
Maybe it was Sheffield.
But at the same time in Leeds the campus is also in the centre of the city. But the other thing is that, and this relates, Mike, to your observation, is that Leeds also tends to attract welfare students from London. And therefore, and then this is known that they come from London. They spend their 3-4 years in Leeds, and then they disappear. But this creates quite a specific socio-economic pattern in Leeds because of this, right? And then again, so then Leeds in this respect is quite similar.
Yeah.
But then this makes it, because the Sheffield and Leeds, they are just next to each other, and economically very different. But in terms of the university,
yeah, we're always complaining about that. That you attract all the wealthy Londoners. You have better shops.
That's probably the only reason.
But to me, this is nice that this is reflected in the language. In the way, I mean, how if they deviate from the standard English or not. I mean, this is reflected, even though, let's say, socioeconomically they're similar.
Oh, sorry. Yeah. So what's going on in Newcastle then? It's like a vacuum, isn't it? Have we got any Geordies here?
Yeah. Also the scale here differs. Here this is percentage of trips that go from one place to the other one. I don't know. I mean, we didn't go into these details. In terms of the correlations, Newcastle is here. It's not so strong. Okay, so it seems that let's say the so because here at one point is one cell in a city, right? And the cell is defined according to the UK census in terms of, so they try to that each cell has more or less the same population, between 5,000 and 15,000 people, okay? And for instance, this is London with a lot of cells, okay? And Newcastle has less cells, okay? That's why you have less data points here. But it seems that it's, let's say, flatter than as compared to London. I don't know.
So are those? Can you just go back to the heat maps again? The next slide.
This one?
No, the one. Yeah, that one. Are they normalised by the count? Because if you said you had less data for Newcastle, that might explain why there's such a big void above that first line.
I don't remember if we normalize. I think this is absolute counts.
Yeah.
Or maybe they are normalized by the largest matrix element. Maybe.
Okay.
Maybe.
I
have to check in the paper.
Yeah, it's just a strange anomaly that it's the only one where everything's concentrated on the on the lower five cells.
Yeah.
Yeah.
But then, that's why it's let's say more similar to Sheffield in this respect. So let's say, but they mix more. Let's say.
Thank you. Have you thought about looking also not only to income but education levels? Because I think if you're measuring by standardization, income is usually a proxy for education.
Yes. So the quick answer is that we don't have the data for that. Okay. But I'm pretty sure that this is also affecting very much. That actually it could be education more rather than the income. Okay. We do find a correlation between income and so, but maybe with educational, the correlation will be stronger. Yes.
Okay, thank you.
Yeah, thank you.
Something there. Okay, I seem to have an empty PowerPoint. One moment. This on, right. Okay, hi everybody. My name's Mike Peard. I'm director of the Digital Humanities Institute at the University of Sheffield. I'm going to be reading from a prepared statement for part of my talk. This is simply to avoid me saying anything too controversial or offensive about Chaucer and medieval English poetry, because it can be quite controversial. People do sometimes start fighting at conferences and throwing objects at one another. Anyway, so I'm going to talk about the C21 Editions project. So C21 Editions is a joint UK-Ireland digital humanities project funded by the Arts and Humanities Research Council and the Irish Research Council. It consists of a project team at the University of Sheffield, University College Cork and the University of Glasgow. The C21 Editions project aims to explore machine-assisted approaches to the editing of scholarly editions. Machine-assisted, for me, is a much broader term than straight AI, but it's generally processes that involve decision, some form of decision, computational decision making. On this project, we explored the use of generative AI and machine learning alongside open linked data in order to create an online teaching edition of the Pardoner's Prologue and Tale from Geoffrey Chaucer's The Canterbury Tales. The edition features the completed edition, that is, features a diplomatic transcription, a modern translation, scholarly commentaries and annotations, an automatic text-to-speech narration of the Middle English text, and teaching activities that are aimed at training students to engage more critically with AI. So I'll show you the results of these approaches and discuss their value and consider their implications for the future of scholarly editing. But first, why did we set out to use AI to create an edition of Chaucer? Well, there are a number of questions that we wanted answers to. First of all, can AI emulate the critical thinking that is central to scholarly editing, leaving the editor free to do the more creative thinking processes? So, scholarly editors generally consider their work to be sacrosanct, requiring expert knowledge, reasoning and judgment that can only be the domain of a few specialist people who have spent their entire careers building such expertise. The idea that AI can reproduce this goes to the very heart of many people's anxieties about AI. We suspect that critical thinking can be reproduced given reliable language models, but that creative thinking cannot, and therefore any system that assists with critical thinking leaves the editor with more time for creative thinking, editorial judgments that are not based on an assessment of the evidence or on anything that has been written and thought about before. We can have an argument afterwards about whether generative AI can reproduce critical thinking. Second question we wanted to address, can AI be used to help scale up the size and scope of scholarly editions? So scholarly editions are what we tend to refer to as scholarly editing is what we generally refer to as an industrial craft process. What I mean by that is we use digital technologies in order to create them, a form of industrialization. But the way in which we go about using technologies makes the process of editing still very much a bespoke manual craft process. As a result, scholarly editions are often small, curated and highly specialized intellectual objects. And the presentation of sources is often limited due to issues of time and resource. So can AI bring scholarly editions closer to maybe mass digitization in terms of scale, in terms of the scale of content that it's presenting, but retaining the accuracy and remediation and high quality critical apparatus that are often the benchmark of scholarly editions. And can AI and open data be used to support the sharing and reuse of knowledge? And also, is an AI Chaucer better than no Chaucer? So some people groan when they hear that AI is being applied to Chaucer. There are also those within the discipline of Chaucer studies who no doubt feel that this is an affront to their expertise, who believe that the outputs will be of lower quality and that it is debasing Chaucer somehow. But Chaucer studies is dying. Few people are interested in reading, let alone studying Chaucer anymore. When I came through Gatwick Airport yesterday, I noticed that Chaucer's Canterbury Tales was not in the bookshop in the airport. It wasn't this summer's most recommended read on the beach. You know, surely an AI Chaucer is better than no Chaucer. Surely any Chaucer is better than no Chaucer. So we wanted to find out if, good or bad, AI can be used as a vehicle to re-engage people, especially students, with Chaucer and Middle English literature and language. So our edition is a prototype. We focused on one prologue and tail, The Pardoner. It has a suitable length and it deals with subjects that resonate with audiences today, such as sexuality and gender identity. We opted to create a teaching edition rather than a research edition. Scholarly editions that are intended for research, such as genetic and variorum editions, do present considerable opportunities for machine-assisted approaches, but we felt that a teaching edition would require us to undertake the types of editorial work that will be common across most digital scholarly editing projects. Presenting the text, annotating text, creating critical apparatus, commentaries, topic guides, etc. And we also decided to try and do a spoken version, which I'll, just for the hell of it, and I'll report on that shortly. When we applied for the grant, which was pre-COVID, we had envisaged developing machine learning tasks which would perform specific functions on the text, like developing a domain-specific large language model and learning how to translate Middle English into modern English, or scouring huge academic databases and learning how to annotate and comment on Middle English poetry. But when the funding was awarded, generative AI chatbots had arrived as interfaces to large language models, and the landscape had shifted dramatically. So instead of investing hours in training an AI system, we opted to explore the value of generative AI in edition making. We figured that we could easily spend 3 years developing quite bespoke edition-specific machine learning tasks, but these would not be very usable to the majority of scholarly editors who lack the requisite expert technical support. So instead we decided to explore ChatGPT and other generative AI chatbots, since these are readily available to editors and intuitive to use. Accuracy is another issue, but they're intuitive to use. So we wanted to explore the viability of tools that would be available to all. And we didn't opt to generate a new transcription of the text using AI methods, because we'd investigated the domain of handwritten text recognition, and we felt that advances had already been made in that particular domain. So the development process, we opted for a fail-fast approach. We only had 1 year for this part of the project to develop the edition. So each feature of the edition was developed rapidly, with different technologies and approaches being tested, assessed, discarded, and then finally a decision made as to how to best deploy a particular feature within the prototype. And we spent 1 month exploring each feature. Documenting the process for each feature was an important part of the project. Only through this process would we be able to reflect upon and share our successes, mistakes, and what we had learned. For example, we tested multiple generative AI systems on the task of producing a modern English translation using many different prompts and parameters. Basically, we wanted to understand if generative AI could serve as an effective assistant or co-pilot in the process of creating a translation. Does generative AI support much of the heavy lifting, the basic, repetitive, tedious, simple tasks of translation, for example? Does it free up the editor's time to focus on more problematic aspects of translation? Put simply, does generative AI save the editor time, or is the editor's task of correcting the generative AI's errors more time-consuming than the editor simply creating the translation from scratch? So in order to answer those questions, we needed to record the process. So every time we had a human intervention in the generative AI output, we've recorded that, and we'll make that available. So here, for example, this is this summarizes our approach and the questions the decisions we were confronted with in creating the translation. So we discovered that prompt crafting was important, and questions such as how much of the medieval structure, rhyme and meter do we want to preserve. We discovered we had these 2 options to require ChatGPT to retain the structure and the meter, which is iambic pentameters, or to allow it to be more free and close to a modern structure. There were pros and cons with each approach. In the end, we opted for the first one of staying closer to the original structure, because that actually produced less errors in the translation, less errors of meaning. So here, for example, breeches and underpants. I don't know how many people know the word breeches, or breeches as we say in Sheffield and thereabouts. Get your breeches on, we're going out. So the manuscript version, thou woldest make me kiss thine older breech. ChatGPT translates it into modern English as you would make me kiss your old breeches. Obviously, actually, few people, particularly younger people for whom this is intended, understand what breeches are. So the editorial invention would be to change the word breeches to underpants. You would make me kiss your old underpants. And then we had this sort of desire to actually put in a kind of some archaisms as well. There's a bit of a debate as to whether we should keep with those, using thou and thine. So thou would make me kiss thine old underpants. When we were using ChatGPT for the translation, I mean, here's another example: lewd people. We asked ChatGPT to translate this line, and when the lewd people is doing it set, its answer is correctly, and when the ignorant people are seated down. So then when we ask ChatGPT, well, what does lewd mean? Its answer is actually correct, that it understands that it generally means ignorant or uneducated. That was the meaning then, and it's it correctly identifies that it did not carry the modern connotation of being obscene or indecent. However, a jolly wench. With this translation, we asked ChatGPT, well, what does the word wench mean? Again, it correctly identifies the meaning of it, that in Middle English it referred to a young woman or girl of lower social status, could mean a servant girl or a young woman in general. It recognises that the meaning changes over time, but it also correctly recognises that in the Middle English context it didn't have the promiscuous meaning that it subsequently developed. However, if we ask ChatGPT what does the word wench mean today, it does, again, it correctly says that it's considered archaic, it's rarely used in modern English. When it's used, it carries a derogatory meaning. However, the bottom point there, the editorial intervention, it misses the fact that in the 17th century the word came to be racialized and used against black women, enslaved black women. So it misses that out. It also misses out that in contemporary black American vernacular, wench is also an insult and a slur against black women still today. So it kind of misses all of that out. It doesn't have that kind of contemporary and that kind of currency there. So this is, we then went on to annotations. So essentially with the annotations we were pulling in data from Wikidata and then asking ChatGPT to rewrite it, and then we were improving that using the OED. So here, so on the left in the green is an example of what we asked ChatGPT to do. So we're asking it to write an annotation for the term cupiditas as it appears in the prologue of the Pardoner's Tale, and we've also given it some Wikidata output to guide its decision making. And then on the right is the output, which is it's pretty accurate. We're sort of happy with that. In fact, again, it's the same output on the left. On the right, that is the same output, but in orange, that is the extent of the editorial intervention. So you can see that actually with the annotations, we didn't need to intervene very much. It was just really to improve readability and style. So that was the translation, that was the annotations, and then we moved on to the automatic text to speech. Just as a bit of a kind of a crazy, is this possible? We have a kind of an idea that this is theoretically possible. So for this, we used a Chaucer Studio recording of Pardoner's Prologue and Tale. So we used an existing human-created recording as our starting point. We ran it through Allosaurus, pre-trained universal phone recognizer, to generate IPA tokens. We coded the tokens using the speech synthesis markup language. We ran that data through Amazon Polly, the text-to-speech AI tool, and we experimented with different languages, English, Dutch, German, to try and achieve the correct intonation. We discovered that all Middle English pronunciations and intonations are present in Amazon Polly. It's just that they're distributed across different language sets. And we realised that with Amazon's business model, they're not interested in joining those language sets. Why? If your business model is to use text to speech in order to create some kind of customer service platform, why would a bot need to be talking in maybe English and then introduce Dutch and German pronunciations? So it keeps them segregated, so it cannot access all of the data. But if all the language data was accessible at once, then we think we would be able to reproduce it. But the bigger problem is that it's hard to recreate the performative aspect of speaking Chaucer. So in the end, our very, very high-tech solution was to rent a very expensive hotel room for one evening and invite down Professor Jeremy Smith from the University of Glasgow, and we kind of wined and dined him and persuaded him to do a recording for us. So I'll just very quickly give you an idea if this is still available. So yes, so
Este pronounce, when is that he called?
Oops.
Van me bullies, shui Alan summa.
So that's what it should sound like. And then this is what we call Brian Polly.
Thirsty pronounce, when is that he come? And then me ballers, shui Alan and summa.
Yeah, pretty tortuous. So the results, as you can see here, these charts represent 100% of the data. The red is the blue is the extent to which a human editor had to intervene and change the text. So, and you can see here that for the modern translation there wasn't that much into editorial intervention, and obviously with the annotations and the guides there's hardly any, but it's because we're feeding good quality human created content in the first place. So returning to our project's original questions, what does this mean for the what does this mean for the editor? Machine-assisted approaches are a very effective co-pilot for editors, able to, I think, emulate the process of critical thinking in carefully defined circumstances, with their chief benefit being speed and time saving. Given more sophisticated language models that have access to more specialized knowledge bases, it's also possible that a generative AI system could propose information about a text that is not already known by the editor. The implication of all of this is that an AI co-pilot could enable us to scale up the size and scope of scholarly editions, and editors are left with more time to attend to problematic areas of an edition and to contribute their own creative thinking. That is, the ideas that nobody, including a computer, would otherwise come up with. For the editor, in one sense, they become one step removed from the physical hands-on task of editing, but their role becomes more, I would say, editorial, in that their position of authority overseeing the work of their co-pilot and defining and questioning the methodologies being used, whether they're AI or editorial, becomes much more critical. So finally, to answer the last question of our project, is an AI Chaucer better than no Chaucer? Oh, I can't answer the question because oh, there it is, it's over there. Yes, I don't know why it's saying yes over there. It should be saying yes in the middle. In consulting our users and developing the features of our teaching edition, we discovered something unexpected. We can use AI to create an edition of Chaucer, but we can also ask students to use AI to create their own edition of Chaucer, and this has a double effect. It enables students to learn about Chaucer's language much more effectively because they are seeing the results of an AI system, including all of its mishaps. So it kind of has this sort of, it kind of just engages them with the language of Chaucer much more by having seen it translated by a computer. Maybe it's something to do with limited attention spans or something. But we found that they become much more critical readers of Chaucer. And it encourages students to become more critical of generative AI, and we were surprised by that as well. Through generative AI's mishaps in translation and annotation, students develop a more critical understanding of what generative AI is and why it is producing the answers that it does. As a result of this discovery, we intend to incorporate learning activities within the edition, which will invite students to prompt ChatGPT to create new translations and annotations, and then encourage the students to critique what the AI has generated. And who would have thought that Chaucer would have been able to teach students about AI? Thank you.
All right, questions, comments, Antonio.
Okay, thank you. Now's my time. I agree completely that the artificial intelligence tools provide us with more time for quality. 2 weeks ago, I was in a conference on literary translation, and one of the positive feedback was that you use the machine translation to provide a draft, you can spend more time doing quality assessment and quality assurance and devoted time to think about. And I think it's the same if you apply this to reading papers in the classroom and say, provide me a summary. Sometimes the students have a very hard time providing the summary. If you do this with the ChatGPT, usually they provide very good summaries, and you can focus on discussion of the main ideas or the secondary ideas. So I think we have to insist on focus on that positive feature of the artificial intelligence in every part of the humanities jobs, right? So if you focus on that, the humanists really start using this in a positive way and not having fear or whatever.
Yeah, no, exactly, I agree, yeah. And I think that I mean, if you take, have you not got one of these things that just stays on? I was going to say, yeah, so, I mean, one of the points is that critical thinking, which we kind of hold up and we're like, trying to instill into our students, but most of the time it's actually quite a tedious, boring process, and and nothing new is really coming from it. So if you can have a system that does all of that to enable you to focus on, I guess it would be the top of Bloom's taxonomy, the really advanced thinking, then it's going to be, it's going to be, it's going to be useful. I mean, I was struck by what Andre said this morning about, is this like the arrival of the calculator? So I've been saying to people, this is the calculator for language. And I remember at school, the anxiety that we would stop being able to do maths. No one would know anything about maths anymore because this calculator was doing it all. But we still have mathematicians. It's just that, and actually most mathematicians don't need a calculator, but it enables people to focus on the higher order stuff.
Right. Okay. So I have some sort of a comment back to your slide on ventures. Right. So then there is a range. Usually with prompts, there is a way. There is a range of ways of making prompts. So then you can specify. So what wench? So then what is the difference between wench as used in the 16th century against wench used by Black American, for example, population? Or you can be less specific, at least as you showed in your examples, right? So then what's your experience with trying different prompts, differing in the level of specificity?
Really good point there. So I think the thing we find with prompts is obviously the skill of being able to create prompts. The skill, the mic. the mic. The skill at being able to create prompts is obviously, is quite important. Obviously, we found that particular example. By the time you have to know that information at the outset in order to construct the prompt, and so why not just write that down yourself rather than asking ChatGPT to write it? So we reached the point where we realised that actually there's work needs to be done in how you interface. If you take, say, addition making, between the addition text and that kind of system, a kind of just a workflow thing that is going to somehow, wrap all of that intelligence up into the prompt without you having to spend so much time keep refining prompts and basically spending huge amounts of time on it.
But then this also depends on the experience. So then if you develop this experience, then it comes almost automatic.
Yeah.
So then to you, and then So then again. So then I'm getting So then I had one example. For example, I teach machine translation, and then I also teach prompting for machine translation. And then you can vary in the way how specific you can be about either asking it to produce machine translation or to extract relevant terminology. And then, but then when you sort of know how to ask for what you want, then you can keep asking, keep making better prompts all the time. Yeah. So, but then I hope that you discovered the same thing.
And I mean clearly this is where, as an editor, your expertise is shifting. You are still valid even more, so it's just that your expertise is an area which is what people mentioned there.
It's not a question, it's just a comment. That it's very useful, for example, to give a role to the machine. For example, you can start the prompt saying, suppose that you are an expert in medieval English. Okay, because you give the context, and then the answers. No, it is just a question. So it is related to that question. So in this case, he's going to contextualize the answer better. So suppose that you could give it a role. Suppose you are an expert in, and this is better, much better.
Okay, I just wanted to sort of, it's okay. I just wanted to sort of generalize from what you have. So everybody's going to have this stage where they're going to have an interpretation. Yeah. Now, have you thought about how? So that will be generic in any project that everybody will be working on. Do you think there's going to be? Do you think everybody will need to start introducing some sort of evaluation metrics? Because the interpretation is very subjective. At the same time, it's very creative as well. Now, that's going to be where the humans are needed. And again, we're going to try and find out other ways in which those jobs can be also, well, new roles will come out, but how we can make that stage more effective. Do you have any ideas, obviously this is a very creative exercise, do you have any ideas how that could be done?
Well, I mean, not necessarily related to this project, but with other things we're doing, we're discovering that the amount of work, time, and therefore money that you have to invest into evaluating outputs is just growing and growing. And obviously you have the problem that you with the scale you can never ever be 100% confident that you have 100%. You can never achieve 100% accurate data. So it's just a growing problem for us. But we are seeing a shift in, for example, with researchers, where you deploy their time. It used to be traditional digital humanities projects. It used to be on content creation. Now it's on accuracy validation, testing, and things like that. So then I'm kind of the view that research needs to be done into things around agency with AI, with human interaction with AI systems, and better tools, that whole interface. Because certainly in digital humanities we tend to be using tools and therefore interfaces that were actually designed for other purposes, and so they're not really fit for us. And I think ChatGPT in a way is a chatbot in a way is an example of that.
So you mentioned that in the original proposal, it was in the pre-ChatGPT phase, before all that really kicked off, and you had a different approach to the methodologies. Have you ever stopped to think how the outputs of the project might have changed, or would have changed, had all this not happened with ChatGPT and everything?
Yeah,
know?
So we, on the face of it, it's just a very conventional pedestrian project. But then I put the word AI into the bid to excite the funder, and it seemed to work. But we hadn't really thought this through. And my one of the guy who's, we have sort of research software engineers in the institute, and the guy who was going to be assigned to this was getting quite nervous about what he was going to have to be doing, and was actually he too, I think, was quite relieved when we went down the ChatGPT route, because it enabled him to kind of play around and experiment with that. In terms of the outputs, I think it would have been a very different edition. I think we would have been tempted to go more down the route of a research edition and revisiting sort of questions relating to Chaucer around the manuscript tradition. Because there are 84 plus different versions of Chaucer, so it's a big research. It's a big research domain, and none of them are in his hand. So it's a big research domain to try and establish what did Chaucer actually write, because they're all slightly different, and they're all written by scribes. So I think we would have gone down that domain of trying to use machine learning to compare, textual variant analysis, essentially, and trying to understand the relationships of the different manuscripts. So it would have been quite a different edition.
All right, thank you.
Thanks.
Do we get to keep these as souvenirs?
Okay, this is one of the keynote sessions in our event by Professor Ruslan Mitkov, who is professor in computing and communications at Lancaster University. Before joining Lancaster, Professor Mitkov worked at the University of Wolverhampton, where he was director of the Research Institute of Information and Language Processing, as well as director of the Responsible Digital Humanities Lab. Professor Mitkov has been working in natural language processing, computational linguistics, corpus linguistics, machine translation technology, and related areas since the early 1980s. He's best known for his seminal contributions to the areas of NAFRA resolution, automatic generation of multiple choice tests, and new generation translation memory systems. Professor Mitkov is editor of the Oxford Handbook of Computational Linguistics, as well as the executive editor of the journal Natural Language Processing, editor-in-chief of the Natural Language Processing book series of John Benjamin's Publishers, and consulting editor of Oxford University Press publications in computational linguistics. His recent research is based on the use of deep learning, large language models, and artificial intelligence in natural language processing, translation technology, linguistics, and language research in general. So today's talk by Ruslan Mitkov is entitled The Future of Natural Language Processing. You have the floor.
Thank you very much. So basically, I won't be sitting here. I'll be moving around. So I just want to check whether, and what I need to do. I need to use this mic and hold the remote control here. So let's see whether I could do it. So I'm going to start now. And first of all, I would like to thank very much Javier Arista for inviting me, and for members of his group, including Raquel, for organizing this trip. It's my pleasure to be here for the first time in Rioja, hopefully not for the last time. So this is the outline of the presentation. I'm going to have to speak very fast because I used to have 180 slides until yesterday, and I reduced them to 118 only. So I'll speak very fast. I hope you understand my English, and let me know if you don't understand something. This is the outline of the presentation you're going to see when I discuss all the things. So just to be clear, this is very important. So this is a presentation written by a human, by myself. A couple of my students helped me with a few slides. There are a few slides, well, images mainly, generated by ChatGPT. And there was a guy from India who helped me with Tamil. So let's go back in time. So a little bit of history. Well, the reason I'm starting with this beautiful song by the group Chicago, because it's called The Beginning, because I'm going to mention about the beginning of machine translation. So we were 47, only between 2 and 3 years after the first computer was developed. He came with the idea that source language can be encoded and decoded into target languages. I mean, this presentation is going to be very easy to follow because I thought the audience was a mixed one. So I apologize to my fellow colleagues in NLP who know a lot about NLP. So you'll find this presentation probably too easy to follow. So he didn't do a good job because this was not a good idea. And for instance, if you read some textbook, especially the one by Doug Douglas and Louisa Sadler from '94, they had this example, which in my view has never existed. They claimed that there was an English to Russian and Russian to English machine translation system, which would translate the biblical sentence, the spirit is willing but the flesh is weak, into Russian and then back into English. And then the output was the vodka is strong but the meat is rotten. This has never existed in my view, but this example was given to show that this concept was wrong, machine translation didn't work. So at that time we had many limitations. Computers were very slow and unreliable. In fact, those of you who are as old as me, there are not so many people who lived in the 60s or even the late 50s. We remember that we needed a space like this for a computer to be in an operating an air conditioning environment. They used punch cards, so it was a different story. Another problem was that at that time, in the late 40s, there was no programming language. So how can you develop a machine translation program if there is no programming language? On top of that, there was no linguistic background, so there was no theory of language. Chomsky's work came in '56, so how can you do machine translation with this? It was almost impossible. So why did he fail? My claim is that he would have failed even if he had the supercomputers of today, because his idea was flawed. His idea was wrong. You cannot simply encode the language and then decode it. This is not machine translation. His views was too simplistic, and the problem that nobody knew at that time was that language is a very complex phenomenon. Language is irregular and ambiguous. And just to show how this was, I have a few examples for you. First of all, I'm going to ask only those who are not native speakers. Native speakers are not allowed to reply to these questions because they will know the answer. So non-native speakers. Does it make sense, this sentence, please? What do you think? Yes or no? You say it doesn't make sense. Unfortunately, you're wrong, because you're thinking about this. You think about this situation. And of course, if you're thinking about this, it doesn't make sense. But those who are native speaker of English, they know that pen has another meaning. Pen could be a playpen for children, for babies. So depending on the meaning, it could be sensical somehow. Also, pen means animal pen, for this animal to be enclosed in the pen. So depending on the meaning of pen, this sentence could have a meaning.
So at that time, we had people like Barhill who said that computers that could not look like humans, they couldn't do machine translation, and he was right. So for those who don't know much about the history of computing and machine learning, I'm going to say one thing which is very obvious. At that time, in the 50s, in the 40s, in the 60s, computers were not able to learn. Humans were able to learn, because if I ask the same question in 1 week, in 1 year, you know the answer, because as humans we learn. However, machine learning and deep learning have changed the landscape, and now, obviously, thanks to deep learning, computers can learn. However, understanding language could be a problem. So it's a huge challenge, and I'm going to start with ambiguity. We know very well that language is ambiguous. Many people, the majority here speak Spanish, so this example is clearly understood. When the Pope visits Havana, he is greeted with the slogan, "Welcome potato," because the word papa in Cuban Spanish could mean potato as well, not only Pope. Also, this is a semantic ambiguity. If you read the sentence, "We serve only men here," in English, it's ambiguous semantically, because those of you who have studied semantic roles know that we could have the semantic role of recipients. The men are to receive drinks at the bar, but also the men could be the patients on the menu, so they're the ones to be ordered. So ambiguous. In Spanish, this is not ambiguous because you have a preposition to disambiguate. In Bulgarian, it's triple ambiguous, because in Bulgarian, this same sentence also could mean "we are the men who serve here," so the agents. So it's really ambiguous. And an additional problem with languages is the phraseological aspect. You can have collocations, you can have idioms. I've given examples in English and in Spanish. You can see that, in fact, this complicates the picture of language understanding significantly. And what is something very important that probably many people don't know, that in language, we have more multi-word expression than single words. This is something which has been already proven. This is a multi-word expression, fly off the handle, which means to lose temper suddenly. As you can see that multi-word expressions don't carry literal meaning. So, so the problem is not only computers understanding language, it's also humans understanding humans understanding language. I hope you can enjoy this very short video. Well, humans understanding humans' language is a problem, really. So I'm going to give the history in 3 minutes, the evolution of natural language processing from rules to neural networks to generative AI. So I think this is the core of this presentation. I'm going to try to, many people are worried that generative AI will take over. So I'm going to explain in a very easy to follow way that, well, you're going to see what my view is, whether we're going to be taken over or not. History in 3 minutes. So rule-based natural language processing was the norm for many years, and this is an example of a word sense disambiguation where you have rules. If you have a word bank, which is ambiguous in English, if it's surrounded by money, finance, saving, etc., it's more likely to be the financial bank. If you have in its context words like river, walk, water, fish, it's more likely that we have the meaning of riverbank. This is another example of rule-based NLP. This is an alpha resolution. If you read those sentences, you can see that in the first case, they are most likely to be the, I don't know what happened. Sorry, I did not press anything. I need to turn this up. Okay. Okay, in this example, in the first day is obviously the soldiers. The second day is the women. But we as humans know this, but computers will find it easily to find a solution. So the way to do it is to design those rules. If X shoots and Y, and if Z being either X or Y falls, then it's more likely for Z to be Y. And then also another rule for the second example. So what you had to do is to encode the whole real-world knowledge of the world, which is impossible. You cannot encode every situation in life like this. So if in order to have a computer which understands a real-life situation, you have to have millions of rules like this. And then we had machine learning, which took off and helped NLP significantly. This is an example where we have actually supervised learning for spam and non-spam, learning from different examples. The computer program using this decision trees, I think is here C45, the algorithm, so it knows what example is a spam, what not. On the basis of examples, it learns when a specific text is more likely to be a spam and when not. And then we have another song. This is the hit James Brown, 66. It's a man's world. Today we're far away from man's world, we know this. But the reason why I'm playing this song is because I want to pass the message that today it's a deep learning world and a world of large language models. So this is the message of this slide. So deep learning started and it's holding a lot of promise. It started with face recognitions. In 2015, I started advising all my PhD students to use deep learning to solve different NLP problems. And now almost everything until recently, until the LLM came out, everything was done mainly with deep learning. Neural machine translation is, of course, underpinned by this deep learning. And then we had the large language models. I mean, we have spoken about this already today a lot of times. They actually repeat the next token of the word or words. And then now the question I want to try to reply in this presentation is, are they always better? So we have rule-based methods, we have deep learning methods, then we have large language models. So what happens? Is the performance getting better and better thanks to large language models? Is there a danger that they are always so good that they replace humans? Is there a danger that they take over everything? So I'm going to show a few case studies of mine. The first one is automatic extraction of metaphorical names of flowers and plants. I have worked with several colleagues and we're doing it, actually there's another one, we're doing it for Italian now. I did not add her name because we started on it last week. So this is for English, Spanish, and Chinese. So the idea is to develop methodology which automatically extracts the names of plants and flowers which are metaphorical. So we have a Chinese corpus also for Chinese, and we have corpus for English and Spanish. Of course, the word corpus here is used very loosely. They have annotated encyclopedia for flowers because obviously those are not available as sampled in balanced corpora. So for instance, for English and Spanish, we have not only single words, but we have multi-word expressions. And the same applies for Chinese. We have names of plants and plants and flowers, which are metaphorical, which are both multi-word expressions and single words. So I'm going to go fast through those slides. These are the sets that we used, the data sets that we use for learning and training, for training and evaluation. And this is important now. I want to say a few words about the evaluation. So you can see here the results for English. So the best results are deep learning, BERT-based multilingual case. ChatGPT falls behind. Rule-based, I suggest that we ignore the rule-based here because those students working with me, they actually developed those rules overnight because we simply needed the baseline model. So let's compare on this project only large language models and deep learning models. You can see that all large language models are doing pretty poorly. Then Spanish, interestingly for Spanish, the best performance is Llama 2, even better than deep learning. For Chinese again, we have the deep learning taking the upper hand. So on this specific task, we see that deep learning are the ones that usually do best. And then this is another task that I wanted to share the results with. Name entity recognition from Holocaust data. I have a student who is working, PhD student who is working on Holocaust data, and we wanted to see how well we can extract entities. So this study is part of another study that I'm interested. I won't have time to report on this because I know that both Carlos and Serge spoke about quality against quantity. I have been always interested in it, and I published a few papers a few years ago where the results that I obtained were that basically quantity only is not enough. We need to have data set or corpora of minimal quality. And so this actually experiment, this study is part of this larger study. So what matters more, quantity or quality? So let's see the results. So we use clean data from Holocaust, narratives which are easier to process as opposed to noisy data, interviews, questions and answers which are more difficult to process. And the results here show superiority of the so-called Holobird transformer model, which was developed specifically for this task, both on clean data and noisy data. So here, the examples show, the results show, this is important, and I'm going to highlight the important results, is that large language models like Mistral and Falcon do not do very well. In fact, if you look here, the rule-based model does better than the large language models. Can you imagine? Here as well, which is surprising. So large language models are not that good always. Another case study, enough resolution. I mean, when Javier kindly introduced me, he mentioned that probably I have worked on more than 100 different topics, but maybe the three most well-known topics associated with my name are enough resolution, automatic generation of multiple choice tests, and also new generation translation memory. This is enough resolution. For those of you who don't know what enough resolution is, I'll give you an example. This is a keynote speech at the conference in India a few months ago, and this is a song by Mary Hopkins, Those Were the Days. But a long time ago, 69. I want to see whether the days of the rule-based methods have gone. This is why I did this song. So this is an example of enough resolution. It is the anaphor here, so we need to, the program has to decide whether it refers to the table or the wine. And I don't know whether you could see well the results because it's very, very tiny, the font. But one thing that I want to say, that the best performing model here is DeepLM, a specific type of deep learning model, way ahead of ChatGPT. In fact, ChatGPT has two variants, one held by us. When we tell ChatGPT those are the possible candidates, or ChatGPT has to look for them themselves. The regional indicators are pretty well. They're not as good as ChatGPT or deep learning, but they're better than some deep learning models. So which means that the rule-based models are not things for the past yet. Another example that I would like to give, another case study, is machine translation. So I always give this example when it has to do with multi-word expression. We have kick the bucket, which is to die. So the machine translation programs used to fail in the past when they have to translate kick the bucket because they used to understand it literally. So 2018, we had already the first neural machine translation systems. Prompt, you see how badly it translates kick the bucket. I mean, it's a nonsensical translation in Spanish. Sistran, which has been used for many years in the EC. Golpeo Cubo just doesn't make sense, badly translated into Spanish. Then we had Google, slightly better, but still doesn't conjugate the verb estirar. Still not perfect translation. And we have DeepL at that time. We had DeepL, which was advertised as the first neural machine translation system, performing very badly as well. And then I was giving a talk in Granada in September last year, and I simply wanted to experiment with a few. I used the same systems. DeepL, much better because of the huge amount of data and because of the way deep learning has changed. So Google Translate did a much better job in September 2023. And ChatGPT did an amazing job as well. So only over a period of 4 or 5 years, we had a dramatic improvement of machine translation thanks to the data and the methodology used. I'm going to give you a few examples of another case study, the automatic generation of multiple choice tests. I'm not going to explain why it is important. Here's an example of multiple choice tests. So I wanted to, the original methodology goes back to 2003 where we developed NLP methodology to automatically generate multiple choice tests from instructional, educational text. And it was so successful that it was adopted by the National Board of Medical Examiners in the States to use it on a daily basis to generate tests for future doctors. So this is one of the things I'm most proud of. But only last couple of years ago, we developed a new system based on deep learning, which would generate text not only from sentences, but for whole paragraphs. And just to show you how it worked, we would identify the most important concepts in a sentence. In this sentence, the concept was syntax, and then this NLP approach back in 2003 would generate this multiple choice test. You can see that the distractors are very plausible. The correct answer is syntax, but pragmatics, morphological, semantics are plausible distractors. If somebody wants to guess, it won't be easy to guess. So let's see how large language models do on the generation of multiple choice tests. I'm not going to show you all the examples I have because we have limited time. ChatGPT, above is the prompt. You can see that does very well. I have scored it 4.5 out of 5, almost as well as the NLP approach we developed. However, Claude 3 didn't do very well because the distractors are too distant from the correct answer. Then Claude 3 actually did even worse because the questions and the options did not make sense. Then Gemini did pretty well. And let's have a look at the more challenging task where we generate multiple choice tests not from one sentence but from whole paragraph, because it's challenging because the system has to understand the meaning of the whole paragraph, not in one sentence. Here we have ChatGPT really failing because it's not testing essential knowledge. It is asking, it doesn't ask what is computational linguistics, it doesn't ask what is NLP, it's asking which is an obsolete term. I mean, this is not the essential knowledge that we want to be tested. Gemini also pretty badly. All answers, all options are wrong. Then we had Mistral, also pretty badly, 1 out of 5, because the distractors can be easily guessed. But Falcon did pretty well. I gave it a score 4 out of 5. So we can see that, of course, I have tested different large language models with different tasks. Unfortunately, I don't have the time because I also use it to generate comparable corpora, which I presented in the conference in Las Palmas a couple of weeks ago, but they did not do always very well. In fact, they didn't know what comparable corpora are. So the future of natural language processing. So this is something that is going to be a bit provocative. This is something that I'm going to share some thoughts, and I would like to see whether you agree with them. So I wish I was a clairvoyant, but I'm not, and nobody is a clairvoyant, because if we're clairvoyants, we'll be all very rich. So this is a very nice song, a hit from '69. It's called In the Year 2525. The reason why I chose this song, because I'm going to show you the lyrics of this song. Please read the lyrics. So you can see that, in fact, they don't mention any computers, they don't mention any AI, they don't mention anything. They only say some machine is doing it for you. So people were not able in the late 60s to predict what was going to happen. And we couldn't predict at that time that we'll have internet, we couldn't predict we'll have mobile phones, we couldn't predict that AI would be at this level. All AI attempts in the form of machine translation failed in the 60s. So I'm going to introduce a concept which I call linguistic intelligence. So it is my concept. I'm going to define it in a bit of a restricted way. So very restricted. This is the ability of somebody to write text well. So the mastery of writing texts, like people like Shakespeare, like Cervantes. So we have had those peoples who were masters of writing texts. And so my question is, I'm going to start by asking, do you think that we have people like Shakespeare, Goethe, Cervantes, Dante Alighieri, who are as good as, well, do we have people today who are as good as they? Any views? Yes or no? I know that this is a difficult one. Some people will say, no, we don't have those people. Some others will say, yes, we have them. So I think it's difficult to reach an agreement, but one thing that I believe we could converge on is by saying that this type of skill, the mastery of writing text, hasn't advanced that much in the history of mankind. So, okay, this is why I'm presenting this. The blue line is the so-called human intelligence, the mastery of writing texts, and the red line is the so-called computational intelligence, the how intelligent computers are. This is, in other words, AI. And you can see here that it is starting as from 43, 4, 5, 6, when the first computers were proposed. I'm not going to go into historical debate. If you read German sources, the first computer was Z1, 41, 43, British sources, Bletchley 44, American sources, Pennsylvania 46, so I'm not going to get involved in this. But the first computer appeared somewhere between 43 and 46. So this intelligence has been going up, the computational one. So we are somewhere here, and we want to see how far can this red line go. Again, I'm going to repeat many times, I'm going to hedge bets and say that I'm not a clairvoyant. So this is what we have at the moment. So the question is, can we be relaxed? Is AI getting better and better? If it's getting really so good, then some people might be worried. People are worried about losing jobs. And we have this crazy situation where we have every week the so-called generative AI wars. All those companies are really investing a lot of money in fighting. These are the battles from this week. You can see what's happening. OpenAI has begun training new advanced AI model to succeed ChatGPT-4. Apple and OpenAI have reportedly partnered to integrate ChatGPT functionality into operation system for Apple. And Elon Musk have criticized Apple for security breaches. We have actually here Apple recruited AI experts from Google to establish a secretive AI in Zurich. I mean, those wars are happening every week, and if you read Robodale's newsletter, Natural Language Processing, he reports all those cases, and it's really fascinating to see the millions, billions of dollars those companies invest to be on the top. It's happening every week. And you have also this leaderboard of LLMs. I don't know whether you can see this leaderboard very well, but for the first time in March, number one was Claude 3, not ChatGPT, but things have changed, and unfortunately it's very pale, but only on the 16th of June, which means 2 days ago, ChatGPT 4.3 was number one again, followed by Gemini. So this happens every day. If you go to this website, you'll see the ranking every day, which is different. So we have all kind of terminology. We have artificial intelligence, general intelligence, the type of AI which can perform as well as or better than humans on a wide range of cognitive tasks. And this is a little bit of a worrying term, because if this is going to happen, people are starting to worry. This is in contrast to narrow AI, which is designed for a specific task. I'm sorry that for some reason the font is not visible very well, and this is the primary goal of AI research of companies like OpenAI, DeepMind, and many others. So what is happening? Now we have new jobs, just like we had new jobs with the advent of machine translation, where the post editors emerged. We have now the so-called prompt engineers. And there was a panel discussion at NLP in Varna in September last year, and I had a look at the jobs of prompt engineers in London only, 1,000 jobs. I had a look at those jobs about a week ago, 170,000 jobs. Prompt engineer, this is a new job. So if anybody is looking for a new job, this is a very good job, by the way. And we'll have new jobs like AI, prompt linguists or corpus linguists, AI or prompt translators. Prompt is a big thing. I mean, we have to admit it. In fact, I have just written a paper with a colleague of mine, Nanomi Samanalilaka, and also co-authored by me and Paul Ryson, where we show that if we do better prompt engineering, the results are much better. We're looking at this task of name entry disambiguation for gay special names. Prompt engineering is a big thing now. So we have also the scary term of super alignment. Has anybody heard of this term? This is a scary term which was announced by actually OpenAI. This is the concept in the field of AI, safety and governance. It refers to super intelligent systems which surpass human intelligence in all domains. They're claiming that they will comply with the human values, but you never know. So this is the illustration. Until now, we had traditional machine learning where the supervisor is the human teaching a student. The student is a computer. The superland means that the computer, all of a sudden, the deep learning system or the large language system is getting much more powerful and taller than the human. But what they want to do, they want to keep the computer not so big and not so powerful. So this is the whole concept. But the whole thing is a bit scary, isn't it? So we could have that very soon. My initial chart was not very accurate, and we could have this situation where the computational intelligence already surpasses the human intelligence. This is scary. I don't know when this will happen, but this could happen. Or this is even worse, that they go rocket sky. So, is it possible? Well, I decided to have a look at a few difficult cases in terms of NLP and see how well those large language models work. I mean, I have worked on AFO resolution, and this is an example I came across in 2000 when I was writing my book on AFO resolution. This is in the British newspaper, The Guardian. So if you read this sentence, so he, who is he? It's a very difficult example, even for humans. He is not Tony Blair, is not Peter Mandelson, because Peter Mandelson cannot ask for his own, he cannot demand his own resignation, and Tony Blair was the prime minister then. So it's a very difficult example. Humans have difficulties. I know that at least 50% will get it wrong. So he is, in fact, the antecedent of he is neither Tony Blair nor Peter Mandelson. It's an imaginary character who didn't exist. The imaginary character of Peter Mandelson being the prime minister. And of course, you need to know a little bit of the British political culture to understand this better. So I tried BART, it failed. It said it cannot give me information without context. ChatGPT-4 failed. And then when I ask once again, it gets confused. When I ask ChatGPT whether they are sure, it's getting even more confused. And then when I say sorry, it's wrong, it gets very, very confused. So basically, not able to resolve this. So I looked at another example. Now we have a very fashionable topic in NLP, low resource languages, NLP for low resource languages. I tried to experiment with machine translation for Tamil. And I wanted to see whether computational intelligence is so advanced. I had a look at several translations from English into Tamil, and I wrote this text myself, just to feature quite a few multi-word expressions. All those expressions in different color are multi-word expression. So I wanted to see how this one is translated from English into Tamil. I tried in Bulgarian, it wasn't very good. I don't know who speaks Tamil here. If you speak Tamil, I don't speak Tamil, but I used a colleague from Chennai, formerly Madras, to help me. So I tried Google Translate, Microsoft Bing. They failed most of the times on multi-word expressions. We tried also LLMs, and interestingly, LLM did better than those machine translation programs. And I have just published a paper with a student of mine from China. We're trying to translate idioms from Chinese idioms into English, and we're comparing different MT programs, including some very advanced Chinese one, with large language models. And interestingly, when it has to do with idioms, large language models do better job. Not perfect, but better. So this is the paper that I was referring to. It's going to be presented at the NET conference in 20 days in Varna. So because multi-word expressions are pain in the neck for large language models and in general for NLP, and pain in the neck itself is a multi-word expression. But I'm going to bring you back to this slide. This is a very important one. So do you remember this was the Holocaust data? So for me, deep learning models, Holobot, they represent quality. And large language models don't represent quality, they simply represent quantity. So we have a situation where huge data, quantity, they're still not able to deliver results. Why? The explanation is very simple, because those deep learning models are trained on specific data, they're trained on those tasks. So Isuri, my PhD student, developed a special deep learning model transformer called Holobot to deal with Holocaust data. It can be downloaded from GitHub, no, from Hugging Face, sorry, from Hugging Face. So it shows superiority at all levels. Again, I cannot predict the future, but I'm going to say something that has been discussed today several times, the hallucinations. So this is an issue that we know. I'm not going to everybody knows that all those language models hallucinate, but this is something which also comes in the way of supporting that large language models are not perfect. I asked this sentence: who won the UK general election in 2024? ChatGPT once, twice, 3 times. The 4th time, it gave me this answer. So it says, it hallucinates, it makes up that Labour has won already. Maybe Labour will win, but ChatGPT is also saying this, which means hallucinating. But the interesting thing is here that the first time it says okay, the second time okay, but then when you put pressure on it, it starts hallucinating more. On the other hand, Falcon did a much better job. Falcon is a large language model developed in the United Arab Emirates. It's doing really very well. So the trustworthiness of generative AI is a very hot topic. You know this, people write about this. Somebody who has written about it a lot is Ken Church. He was already mentioned by Sergey, I believe. So Ken Church, he writes the column Emerging Trends in the Journal of Natural Language Processing, published by Cambridge University Press, for which I'm executive editor. And back in December 2023, but the paper came out at the beginning of 24, he actually highlighted those issues, and he said the best way is to combine actually large language models with fact-checking, which makes sense. And he wrote another paper which is going to come out any moment. It should have come out yesterday, but there was something very unpleasant what happened. Cambridge University Press was attacked. There was a cybersecurity attack, and now everything has stopped for a month. So this means delaying production. So this is really very unfortunate. So every large language model has guardrails to guard the output, which goes beyond the training data. And Ken Church was saying in his paper that they hallucinate the large language models when it has to go beyond the training set, or if you speak about something unspecified. And here is the example. Please summarize the paper on psycholinguistics, unspecified, obviously hallucinations. So he is proposing something which is already retrieval augmented generation was discussed by Antonio. I mean, he's proposing this paper which has been already published but cannot be accessed because of the cybersecurity attack. He's proposing that using retrieval augmented generation will improve the quality and the accuracy of the outputs. And because in retrieval augmented generation, it has to do with generating, extracting latest information from available files which are not different from the training data. So this is something that he believes will improve. So I'm going to finish in about 5 minutes at most. I'm going to make a few final conclusions and comments. Probably I'll be the only one who will finish ahead of time, but it's not bad. So do we regard artificial intelligence as enemy or friend, as an opportunity? I mean, those people who panic, I think they're going to be the ones who lose. There'll be new roles for translators and linguists, as I already mentioned. But the question is this too pessimistic? Could it be that something worse happens, that those large language models replace her and wipe us out completely? This is another interesting thing that could happen. I think that this is not too optimistic. I think that generative AI is still far from human intelligence. I'm going to highlight a few takeaways. Large language models are not always better than deep learning models, and I show it on the basis of several case studies that I reported during my talk. In fact, sometimes even the rule-based ones are better than large language models. Interestingly, large language models, they bow to pressure. And this was the example with the hallucination about the UK general election. They hallucinate. We know that human control is still needed, and we know that computational intelligence has still some way to go. It is worth noting, however, one thing that really worries me is that we're comparing AI with the higher end of human intelligence. So we are looking at humans who are intelligent. What if you look at illiterate people who have no knowledge of anything? Can they compete with chatbots? Possibly not. So I think this is something worth noting at least. I still believe in the current human superiority, at least in the world of translation and language understanding. I still believe that humans are better. And in the field of translation, I gave a talk recently where I looked at literary translation, machine translation applied to literary texts, and people in the machine translation community regard literary translation as the last bastion of machine translation. But I think this last bastion will go soon as well. Then, at least for the time being, I believe this is the case. For how long, I don't know. If you ask me after a month or after 1 year, I may give a different answer. I was tidying my house in the UK a month ago, and I found a newspaper article published in 2003, an interview in a newspaper, and I was interviewed by a journalist, and I was asked, could the computers become as intelligent as humans? In 2003, I said, no way. If you ask me now, I'm not sure I'll say no way. Things change. So this is what I believe still. I don't know until when, but this is something that I still passionately believe in. An important message to finish this presentation is that for the time being, translators, interpreters, and linguists are not endangered species as long as they embrace the AI revolution. But they must embrace this revolution. Otherwise, if they're afraid, if they go away, they'll be the losers. Questions, comments?
Yeah. So it's just a blimey. So it's just a bit of a kind of contentious observation, really. It's back to the quote from Noam Chomsky. I think it was in your talk, actually. It was very relevant to what you were talking about, Ruslan. I'd imagine if you asked ChatGPT or any chatbot to provide a contentious quote about itself, as if it was written by Noam Chomsky, you'd pretty much get exactly that. So I'm kind of thinking, ironically, I actually find the outputs from ChatGPT more imaginative, more creative, and more unpredictable than those from Noam Chomsky. Anyway, on that contentious.
But not everybody agrees with Noam Chomsky. We all know that he's not very predictable either.
Well, I think that quote
So one of the things which actually keep me sort of comfortable working as a linguist, as someone who contributes to large language models. So then the thought is about control, and the thinking about, so then essentially what they lack. So then large language models, and they haven't improved in this respect practically in any way. So what they haven't improved in is the set of intentions. So then ChatGPT does what you ask it to do, and if you ask it in the right way, then it will produce a reasonable job. And then, so then essentially what ChatGPT is doing, it is waiting for you to give the command, right? And then whether this, so then if the output is convincing, and in this respect, the output does the job you want. So then I can imagine lots of jobs, such, and then in exactly the same way as you, I experimented, and also with my students, with different prompts. So you have a text, and you ask it to extract terminology from this text. It does. If you write the prompts in the right way, then terminology extraction will be better. If you want to extract bilingual terminology, it will be the same. If you ask, so then lots of different tasks you can do, and if you ask it, it will produce something. So the next generation of ChatGPT will not lie that I died in 2018, and it will not actually it will refuse even under pressure to predict the results of the general election, but then it will not do anything unless you ask it to predict the result of the general elections. So in this respect, because the models, and I don't see the source for the models to have desires and intentions, and then and they remain a tool. So then okay, nuclear weapons is also a tool, and then you can destroy half of the humanity with a tool, right? So but then as long as but then the nuclear weapons, they don't fire themselves, right? And they, or at least under their own volition, and so at least this is the future. So how can we control large language models? That's a question, and but then in a sense we control them all the time. At least this is my optimistic view.
Thank you. I would like also to thank you for the comment. I would like also to mention something about the pressure. Okay, in this particular case, when it hallucinated, it had to do with factual information. Okay, it made it up because it was under pressure. But when it has to do with a bit more deeper task, when I gave it some difficult enough resolution examples, obviously it doesn't have this information. It has to figure it out on the basis of the text. When I told those large language models, you're wrong, they would correct themselves in a very silly way by accepting straight away what you tell them. And if you tell them this is the right answer, they'll accept it. So this is something that probably has to improve as well, because they don't have the factual knowledge to check, they don't have it in the training, they have to resolve the problem. So this is something which remains a challenge. I don't know how this could be done. There are two more comments. So ladies first, and then gentlemen.
Thank you. Okay, so there's an expression, we might as well talk about it, horses for courses, and I think it's going to be the case when it comes to large language models, the space that we're in. There's going to be so many people who are going to benefit from it. There's so many people who are going to lose out. The literacy on AI it needs to be, I think it needs to come to the fore for most people. But I do believe, I mean, I think your viewpoints are absolutely sort of spot on. I think it's going to mean different things for different people, and where you can see a use and where it can be effective, it's not going to be dismissed. However, because everything is changing every week, so when I was looking at Palm 2 has got a lot of multilingual mathematical reasoning, has a lot of common sense built in. Maybe that's the next model that we need to check again. So every couple of weeks, we need to be doing the Thames test again to see how it's improving. So from 1 month, we might have a different story and a different answer.
Exactly, and this is what causes a challenge to the teaching. How can you teach the latest things if they change every day, and how can you teach it if you're not allowed to teach it? It hasn't been validated. This is a limbo. Catch-22.
Yeah, I was just wondering, you were talking about, and I've seen that myself, where the ChatGPT or these chatbots are very subservient and deferential to their human interrogator. I'm just wondering if, in your experience with it, whether you've experimented with either few-shot prompting or some other technique to actually tell it not to do that, to tell it to, as we say in English, stick to its guns and argue its case where it believes it is right.
No, I haven't told ChatGPT or another large language model to stick to its guns because I didn't feel I had to play the role of an educator. This has to be the people who developed it. This is the way I felt. This is useful, but what if people mislead it deliberately? So we have two more comments, Serge, and then...
Okay. My comment is an immediate reaction to what Tony said. So then I learned while working with large language models, I learned a nice linguistic term that's psychophancy. and then there are empirical estimates on the amount of psychophancy in large language models, and it is very, very substantial. So the psychophancy is the tendency to be subservient, right? So, and then one of the explanations to this is the reinforcement learning with human feedback. So then essentially all the chatbots, they're trained with the reinforcement learning with human feedback. And essentially this forces them to, so then essentially how this is done, human choose what is the preferred response. And then because of this, they tend to favor the preferred response on the side of the humans all the time. So, and then this is what is a natural byproduct of the reinforcement learning. The other thing which people didn't actually test with, and I suspect the other thing, they are trained on large texts, and texts, they tend to be internally consistent. And because of this, going into the contradiction is inherently, so in each individual text, you don't have space to contradict yourself, right? And therefore, then again, this creates the bias in language models to agree with whatever is coming on the side of the, that whatever is in the current discourse, it tends to agree with what follows this discourse. And therefore, it's very difficult to go against this bias. But then the interesting thing is that there are empirical estimates on the amount of psychophancy if you design your experiments in the right way.
And are the large language models intelligent enough? Do they have emotional intelligence to see whether you have good intentions or ill intentions? This is another thing.
I thank you for the very interesting talk. I think the reason we are having this argument around whether, LLMs are good or whether they are effective or whether they will take over is because humans are still relevant in the equation. So we will continue to see what you mentioned, Serge, the reinforcement learning from human feedback. But I relate with your slide where you had that plot and you have human intelligence at the top, but then LLM intelligence is meeting up as a nightmare. 10 years ago during my PhD, I never would have thought we will come to where we are right now. Even, for us who are AI architects, we are still stunned at what these models can do and how powerful they are. And you mentioned those guardrails, which is why I gave a talk about the safeguards, and we're actually doing a study about that, safeguards within the models, such that they don't return things like hate, abuse, but people do know how to hack these safeguards, by deception and other types of attacks or injections. So humans will continue to remain relevant, but we will see that gap continue to narrow, because as humans continue to make these models more intelligent, it's like that English narration of saying shooting yourself in the foot. You're making the model better, but in the process of making it better, it could also harm you as well in some way, which is why we have things like the EU AI Act to check how companies and organizations apply these models, not just for profit, but also for some form of social good, and to put in these safeguards in there. But I don't have the answers, but I think it's still a dilemma. We don't know where we'll be in a year's time.
Thank you. Carlos wanted to make a comment.
Yeah, well, it's a question for you. Just asking for your opinion about, prompt engineering. Well, we all of us agree that it's the future, but most of the scholarly publications say that prompt engineering is an art more than a science. So this is at the extreme, at the other pole of the line that we are searching, interpretable artificial intelligence. So how is it possible to bet, to put all the efforts on something that it is just trial and error?
I was going to say exactly the same term, trial and error, because when I started using prompt engineering, I did exactly this, trial and error. I try, and then if it doesn't work, I try. So at the moment, I don't think I can give any formal answer, or I don't think there's any formal evaluation as to how good. I'm not aware of any literature which compares the prompts apart from trial and error, apart from empirical evaluation. So this is something that the future will have to tell us. And then one question that I have always asked myself: how come people are so interested now in the generative AI, in the large language models, and not so much in deep learning? Because deep learning delivers better results in general. Maybe because of the way they communicate, because they're chatbots. Maybe because they're easy to communicate, easy to. I think that it's the communication that attracts people, not the performance. Do you agree with this? I can hardly find any people who haven't used ChatGPT to improve their English, for instance, or at least to revise their English. Obviously, it does good jobs on this. Well, okay, there's one final comment or question. And then I think that Javier will tell us that we have to head for the winery.
Sorry, so very briefly, I just wanted to point out that the reason why ChatGPT, for example, behaves in such a subservient manner, it's partly the fine-tuning, of course. The last layers are fine-tuned to do that, but also partly, and I think largely, because of the system prompts that precede all our prompts. If you, for example, create a new custom GPT, it always starts with the default, you are a helpful AI assistant. And if this is not there, it's not even a chatbot, right? It's really just a generator that doesn't do the chatting. And this, I think, not only turns it subservient, but also so interesting, as you just pointed out. It's the chat feature that is so enticing that people really want to use. If it was just generator, people wouldn't really be feeling that this is so important. And maybe slightly different comment also. I think that while we will see a lot of progress by, making the models even bigger than they are now, I think that we may see even more progress by actually empowering the LLMs with different types of tools, as we can, as we start seeing it now. It's not only the RAG, the augmented retrieval, that's one of the tools, but we can also see that now ChatGPT can access internet. It can use Python to run code. And what I find really exciting is that, in a way, it behaves more like a human than we would expect computer to behave. It can't do a lot of things that people also can't do, like count, do mathematical operations well. So it needs to use those tools. It needs to use libraries to get information. It needs to use internet to get immediate current information and so on. And the more we empower it, the more powerful it will become in this sense. And there are interesting tools like Open Interpreter, where you can let the LLM do anything with your computer, with your permission. So it can start to run any code, access the internet, and so on. And this really brings very interesting results, because it starts making a decision about what, for example, libraries, like programming libraries, it wants to download. It downloads them. It starts installing stuff on your computer and starts doing things with your computer. And you can see how it behaves really, as an empowered human.
I'm going to give the microphone back to Javier, because...
Okay, thank you, Ruslan. I'm really sorry to have to interrupt you, but we'll have to continue the discussion over a glass of wine. For those coming to the winery, we'll meet downstairs. We are going there by taxi. And for those who aren't coming, we'll see you at La Cocina de Ramón at 8:30. Okay? La Cocina de Ramón.